everyone and welcome to the Tableau Full Course, your complete guide to mastering one of the world's leading tools for data visualization and business intelligence. In this course, you will start with the fundamentals of Tableau, learn to build interactive dashboards, create charts, graphs and calculations, and explore advanced features like LOD Expressions, data blending, and integration with Python using TabPy. Through hands-on projects, you will gain the practical skills needed to turn raw data into powerful insights that drive business decisions. So whether you're aiming to become a Tableau developer or enhance your data analytics skills or prepare for Tableau interviews, this course will help you achieve your goals. So before we get started, please like, share and subscribe to Edureka's YouTube channel and hit the bell icon to stay updated on the latest tech content from Edureka. Also, check out Edureka's Tableau certification training that helps you master Tableau Prep, Desktop, Charts, LOD Expressions and much more. Gain hands-on experience with real-world projects across industries like retail, entertainment and healthcare, and prepare for Tableau Desktop, Analyst and Server certifications. So check out the course link given in the description box below. Now, let's get started with our first topic, that is, what is Tableau?
In the prevailing world, every organization relies on taking data-driven decisions. But have you ever thought, how does data lead to decisions? In order to make a data-driven decision, data needs to be studied and analyzed to identify the factors that may influence your business on the run. And to make things easy for you, here comes Tableau. The renowned IT research firm Gartner has deemed Tableau to be one of the best BI tools for data visualization. But why is it so popular? What does it actually do? Imagine this. Your boss gives you a sheet with millions of rows and columns. He then asks you to find patterns from the data. It is going to be a hard time for you to even go through it. Forget finding patterns. Traditionally, you would be dumping this data in your database and would be writing SQL queries to refine your data to gain insights from it. And no doubt that you need to be really good at it. Then you would be plotting charts to make it look presentable. Now imagine doing all of this with just a simple drag and drop. And that's what Tableau does. With its simple drag and drop user interface, Tableau writes optimized SQL queries at the backend to fetch data from your data source in the desired way. Talk about visualizations. With its high-end graphics and color schemes, Tableau makes the charts look as apt as possible. You can plot bar charts, pie charts, bubble charts, heat maps, tree maps, and even scatter plot on a real geographical map. With Tableau, you can even drill down your data using filters and visualize your data at a granular level. That's the power of Tableau, and that's how easy it is to harness the power. Just clicks, drag and drop. From large-scale corporates to small-scale organizations, Tableau is used and preferred by everyone, everywhere. Tableau product suite includes tools for development like Tableau Desktop and Tableau Public, and sharing tools like Tableau Server, Tableau Reader, and Tableau on Cloud, which is Tableau Online. A company called allrecipes.com was successful to harness this power, which in turn helped them to improve their user experience and gain an even bigger consumer base. With Tableau, allrecipes.com can understand every stage of the customer journey. From analyzing web analytics to tracking content engagement, visual analysis allowed them to spot and stay on top of emerging trends. By leveraging Tableau analysis, they were able to see an immediate improvement in their business and scaled up to 1.5 billion annual visits, making it a top media food brand worldwide. This is how every organization is using Tableau. Time to find out what you can do with this ever-rising tool. Number 1. It is easy to learn and use. The biggest obstacle that comes while adopting a new technology or a tool is the time and the opportunity cost involved while learning it. And this is something you don't have to worry about at all when learning Tableau. If you consider the learning curve of Tableau, it is very small as compared to the other BI tools. The obvious point to note here is that Tableau is easy to learn only because it is very easy to use. Tableau UI is just a simple drag and drop interface, but you will be amazed to know what Tableau can do with just dragging and dropping and a few clicks. Just look at the visualizations here. Reason number 2. It is the best BI tool. And I'm not saying it. It's Gartner who has been naming Tableau as the leader from the past 5 years. Gartner is among the top IT research firms who makes an analysis every year on different tools, and Tableau has proven to be the leader among them all. Tableau has completely defeated other major players in the market like Microsoft, Qlik, IBM, who are the parent companies of popular business intelligence tools like MSBI, Power BI, QlikView, QlikSense, Cognos, etc. In easy words, Tableau is the best BI tool in the market. Number 3. It is very interactive. The visualizations created with Tableau are very interactive. You can play around using filters, tooltips, and map navigation, which provides you much more power to quickly test new ideas, drill down into specific data segments, or remove outliers from the analysis. It also reduces the number of charts that needs to be created in a document, which improves navigation and is much more intuitive for the client. Although traditional analysis tools have some basic interactivity which are cumbersome to program, but interactivity in Tableau is created in seconds. You can also easily embed your visualizations or charts in your web page. Number 4. Enhanced visualizations. Tableau visualization is not limited to the traditional set of bar charts, line charts, and pie charts. The software offers many more options that can release new insights from the data that may not have become apparent with the limited set of traditional visualizations. In particular, Tableau's ability to plot a large number of data points with visualizations such as the packed bubble charts significantly enhances the ability of users to analyze data more effectively. You can even plot your data on geographic maps. And guess what? You don't even have to explicitly specify them. Tableau detects geographic locations automatically if your dataset contains it. Reason number 5. Seamless and automated data updates. With Tableau, data updates are seamless, be it daily or weekly or monthly, yearly, anything. All visualizations and filters are updated automatically, and any joins between data sources are not affected. What's more, these updates are normally automated so the user may not even need to initiate the update. And this can save huge amount of time for repetitive analysis such as the monthly KPI reports. Reason number 6. With Tableau, you can access large datasets. Now, Microsoft Excel sheets are limited to just over 1 million rows. In truth, performance tends to drop well before this level. With Tableau, users can now manipulate much larger datasets, well over 100 million rows. This has implications for the quality of analysis that a user can produce. Instead of analyzing aggregate data like the daily sales by store, users can now analyze transaction-level data, generating much more granular insights and providing more value to the clients. Tableau can even connect to your big data platforms like Cloudera, Hortonworks, etc. You can connect to the data present in your Hive database and perform analysis on it. Reason number 7. Data joining and blending. Data joining also involves a simple drag and drop in Tableau. You just have to drag the new dataset to the existing loaded dataset and it will join it automatically as an inner, outer, left or right join based on the fields present in your dataset. Data blending in Tableau is the operation of combining multiple data sources into the same view by finding common fields between them to join on. Unlike an ordinary join, which combines data sources at the lowest granularity before any aggregation is done, a data blend can join data sources after aggregation is performed on the individual sources, ultimately limiting the number of records that are joined together and maximizing computational efficiency. Reason number 8. Tableau for all devices. Ever wish you could make your dashboard look great on desktop and as well on the mobile phones? Well, say hello to the device designer in Tableau. With its new feature, you can design, preview, and customize dashboard appearance on phones, tablets, and desktop monitors. Then you can publish a single dashboard to Tableau server with optimized viewing and interaction across a range of devices. You can tailor a dashboard's composition and contents according to different browser window sizes. When you publish the dashboard to Tableau server or Tableau Online, people who interact with it experience a dashboard designed specifically for this screen size, whether it's a phone, tablet, or desktop. Reason number 9. No technical assistance required. Since Tableau is so easy to use and understand, business analysts and other non-technical people in your organization can use Tableau easily. Since Tableau is so easy to use and understand, business analysts and other non-technical people in your organization can use Tableau and harness its power to create visualizations and build dashboards that could be shared across your organizations. Reason number 10. Last but not the least, it is aligned to your career goals. With Tableau being adapted by all companies, there is a huge demand for Tableau professionals in the industry. Tableau is a desirable skill in the industry now. Take a look at the Tableau job trends that has been collected from Indeed.com. And as you can see, it is rising every day. And with its high demand comes a high salary too. A Tableau expert can earn from $61,000 to $127,000. It depends upon the years of experience you have and also the organization that you're joining. I hope these reasons were enough to trigger your nerd adrenaline and get started with Tableau. So what is Tableau? Well, Tableau is known to be a groundbreaking data visualization software created by Tableau Software. So with Tableau, you can easily visualize your data. Now, your data mostly lies in form of spreadsheets, in rows and columns, with numbers and text. So it is hard to just identify problems and come up with solutions just by viewing numbers and text on a spreadsheet. And that is why you need to visualize that data in order to understand how your business is going, what are the problems, and how can it be solved, and also identify the interdependencies as well. What Tableau does is that at the back end, it writes optimized SQL queries in order to fetch your data from the database and then present it to you in a visual form, which is very attractive and also very insightful. So in order to summarize, it's a data visualization software that makes our work very, very easy. And plus, it is also very easy to use. For example, let me connect to the Superstore data in Tableau. So there are measures and dimensions in Tableau, which are nothing but different fields that you can use to create your visualizations. Measures are usually numeric entities or numbers, and dimensions are text. So let us see in our Superstore which is the customer segment that makes the huge or most purchases. So just drag and drop the segments to the columns, and we want sales in rows. And you can see here directly that the consumers or individual buyers are the ones who purchase most of the products as compared to corporate or home office customers. Now let us see what are the products that they purchase. And there you go. It has listed out different products they buy. So these are the items that are purchased on the Superstore with the bar chart indicating their number of sales. Well, you can also sort it according to your own convenience. And this is how you do it. Now, if you just hover on a bar, you can see the details as well. Now let's just find out which are the most profitable items. Just drag and drop the profit to colors. And the color legend over here indicates the darker the orange, the more is the loss, and darker the blue, the more is the profit. And here we have phones with the darkest blue, and if you see in this case, tables, which is one of the highest selling products, is under loss. Now these are the things that you can understand by visualizing, and Tableau is a very good tool for that. Moving on, Tableau is also a leader among all the BI tools. Now this is Tableau's 5th year to be on the leaders chart or in the leaders quadrant in the Gartner's Magic Quadrant. Now it is among the leaders and it has beaten other BI tools like Microsoft, Qlik, Salesforce, etc. Now let us take a look at the Tableau product family. Now, the main development tool in this Tableau software suite is the Tableau Desktop. So with Tableau Desktop, you can connect to numerous amount of data sources. You can connect to your data in your local system. You can connect to cloud databases. You can connect to cloud applications. You can even connect to big data with Tableau Desktop. And this is a very good development tool. This is where you create all your visualizations and your dashboards that you want to share across your organization or with your friends. Then we have got Tableau Reader. This is again just for viewing purpose. If someone has created a dashboard or a workbook in Tableau Desktop, you can view it in the Tableau Reader. Now you can interact with the visualization with filters, but you cannot make any changes to it. Then we have got Tableau Public. Well, Tableau Public is also used for creating dashboards and worksheets. The only difference is that you cannot save your workbooks in your system. You have to publish it in the Tableau server where it will be available publicly. And it has also limitations to connect to data sources, unlike that of Tableau Desktop. Then we have got Tableau Server, which is an enterprise level sharing tool. So if you want to share all the dashboards across your enterprise or organization, you can use Tableau Server for that. It is secure and reliable. Then we've got Tableau Online. Now this is just Tableau hosted in cloud. So you can view your workbooks and your projects that you have created in Tableau Desktop in your Tableau Online. Moving on, let us understand the need of data visualization. So there is a very good example to make you understand why do we need to visualize this data, and this is the Anscombus quadrant. Now these are the X and Y points that you can plot on a graph, and it is there for 4 different quadrants. Now if you take a look here, the numbers are almost the same. The sum, average, and standard deviation are completely equal. So you might be thinking that when we plot these points on a graph, the graph will look pretty much the same. But when you actually plot it, you can see it is completely different. The lines formed by these points are completely different from each other. And you wouldn't have known that unless you have plotted it and visualized it. And that is why you actually need to visualize your data in order to understand the differences in situations, and that is how you come up with different insights and solutions to your business problems. And that is how Tableau exactly helps you. Now let me show you a sample workbook, and I will let you know what ways you can make visualizations with Tableau. So here is a workbook on the world indicators. So before making the workbooks, first thing you need to do is connect to your data source. Now this is a world indicator dataset. In the first worksheet, we're going to find the relationship among the population and birth rate. You can create a new sheet from over here. You can click here and it will open a new worksheet for you. Now I have dragged and dropped latitude and longitude over here. These measures help you to plot an actual map in a Tableau worksheet. If your dataset contains any geographical location, Tableau detects it and it can plot a map just like this. For example, we have country here. Well, this is just a simple visualization, like a simple scatter plot with varying colors and sizes, but it gives you a lot of information. Here, bigger the circle means bigger the population, and the color legend description is over here. So if the birth rate is above 3%, it is red. If it's between 1.5 to 3%, it is gray. And similarly, the description is over here. So clearly we can find out here that even if China has a huge population, the birth rate is quite low because it's blue. You can see in countries in Africa that even though the size of the circle is quite small, it is red, which means birth rate is quite high over here. Here you can get an indication that the population is low even though the birth rate is high. And this could only lead to the fact that the mortality rate in these countries is very high. So you can identify threats just by visualizing the data. And you can conclude here that there might be fatal epidemics or famines spread in the countries because of which the population is less but birth rate is high. Similarly, if you want to view the infant mortality rate in different countries in Africa, you can visualize it like this. The color legends are over here. For birth rate, it is blue. For infant mortality rate, it's orange. For health, it is yellowish, and for life expectancy, it is purple. Similarly, you also want to see the care spends. So if you want to check which countries spend more than 14% of GDP on healthcare, you can edit this part, edit the text of the question here. You can even add filters to adjust the threshold value, which is 14% in this case. Let's drag it to 8%. You can see that the text also gets changed here because I've included the variable in the question. And it looks like every country spends at least 8%, just leaving the African countries, which explains the health situation. Now let's check the technology worksheet. You can use filters to drill down a single country view. This is for Argentina. Now you can make dashboards to combine all the worksheets together. Just drag and drop sheets to create your dashboard. Dashboards in Tableau are interactive as well. You can make changes directly in your dashboard, which will reflect in your worksheet too. Finally, you can also sum up everything in the form of a story, just the way we found out that there was an imbalance among birth rate and population in Africa. And the best part in Tableau is that in order to tell a story, you don't need a storyteller. You can view the story just by clicking ahead. And stories are also interactive. But let me tell you, even if you make any changes here, it will not reflect in your actual worksheets like that of dashboards. So these are the kind of things that you can do with Tableau.
What are Tableau products? So Tableau has a number of products like Tableau Desktop, Tableau Reader, Tableau Public, Tableau Server, and Tableau Online. Tableau Desktop is a paid desktop application where developers create charts, formulas, dashboards, actions, and other visualizations. The dashboards which are created here can be published to Tableau Server or Tableau Online or Tableau Public Server. It can also be opened in Tableau Reader. So that's about Tableau Desktop. Now, Tableau Reader is a free desktop app which can help us to view the Tableau dashboards created in Tableau Desktop or Tableau Public. So Tableau Reader is basically a reading tool for the existing workbooks. But the security level in Tableau Reader is pretty low, as anyone who gets the workbook has an access to it. Next, we have Tableau Public. So in Tableau Public, workbooks cannot be saved locally, and it gets saved in Tableau's public cloud, which can again be accessed and viewed by anyone. So it is specially built for the cost-effective users. So next, we talk about Tableau servers. So Tableau Server is basically designed to share workbooks and visualization that are firstly created in Tableau Desktop or Tableau Public. But Tableau Server is highly secured and only the licensed users can have access to it. The admin of the organization has the control over the server, and both hardware and software are operated by the organization itself. Next, we have Tableau Online, which is again similar to Tableau Server only. So Tableau Online is also a sharing tool, and the functionalities are similar to that of Tableau Server, but here the data is stored on the servers hosted in the cloud, which are maintained by the Tableau groups. So that's about the products of Tableau. Next up, let's discuss what is Tableau Server. So Tableau Server is basically a web-based platform where we can share our workbooks, reports, and dashboards made in Tableau Desktop. But these dashboards can be accessed only by the licensed users. So the data security is very high in Tableau Server. Now let's look into the difference between Tableau Server and Tableau Online. So when we create a dashboard on Tableau Public or Tableau Desktop and we want to share it across our colleagues, on the front end, there's absolutely no difference between Tableau Public and Tableau Server. So the main difference is where the data is being stored in the backend. So Tableau Server is hosted by the customers or the organization itself and their data engineers. So that way the data is accessible to only the users with licenses and only the admin will have the control over sharing the data. Whereas Tableau Online is hosted by Tableau itself and it's a software as a service. So the organization do not need to purchase and maintain a new hardware for Tableau Online. Whereas for Tableau Server, organizations need to manage everything on their own. Upgrades, facilities, hardware optimization, everything is managed by Tableau for Tableau Online, whereas Tableau Server is for organizations who focus on data security and complete control over the data workloads. So that way Tableau Online is a bit costlier than Tableau Server, as Tableau itself manages everything in Tableau Online. So next, let's look into the components of Tableau Server. So there are total 8 components. The first being Gateway. So Gateway is basically a kind of web server that helps clients to communicate to the server via HTTPS. So the server receives incoming client requests and directs them to the appropriate server for action. A gateway handles processes such as load balancing, traffic routing, URL rewriting, serving static files to clients, serving multi-thread processes, and things like that. Next, we have application server. So gateway interacts primarily with the application server, which is also known as work group server. The application server basically deals with login processes, domain authentication, data authorization, user or group permission management, content searches, etc. It basically works association with the server's repository and handles data access operations. Then we have repository. So the repository in Tableau Server stores server metadata related to user permissions, assignments, groups, and projects. So along with the metadata, it also stores visualizations in flat files and performance data for auditing. So whenever a server service or component demands for metadata, it is provided from the repository. Also, it cooperates with the Active Directory to provide useful information to the app server for login verification process. Next, we have WizQL server. And it is a very important component of Tableau Server as it is responsible for loading all the visualizations that you see and work on with Tableau. So basically it has an inbuilt caching for performance improvement and editing tasks. Whenever a user requests a visualization or wishes to update an existing one, a request is received by the WizQL and then it is converted into SQL statement and sent down to the data sources via respective data source drivers. So that's the job of WizQL server. And next we have data engine. So the data engine is another efficient component which handles processes related to Tableau data extract. It is invoked only when a query is short, which involves data from TDE. The data engine stores multiple TDEs and can run on multiple servers. Then we have backgrounder. Backgrounder is an essential multiprocess and a multiprocess element that manages schedules for information refreshing and ensures proper functioning of the Tableau server and data engine. Penultimately, we have data servers, so which helps in centralizing the metadata management, driver deployment, and extract management. And lastly, we have search and license. So these are two very important components again. The search component manages the search indexing for the data in the repository, whereas the license component is responsible for licensing and configuration of the Tableau server. So that's about all the components of Tableau Server. Now let's look into the architecture. So let's see how all these components work together. That's about the architecture. So here we have multiple layers. We have 5 layers or sections in the Tableau Server. Firstly, the customer data, next the data connectors, then main components, then gateway, and then clients. So in the customer data layer, we have all sorts of data sources available for a Tableau user like the data warehouses, data marts, files, cubes, and relational databases. Then in the second layer, we have the data connectors. In this layer, we have data engine, SQL connector, MDX connector, and the repository. So the data engine processes the data requested by the user and assigns the data type, decides whether it is a measure or a dimension, and then create TDEs. So at the background of the data, engine runs an SQL connector, which creates an SQL query for all the user requests and interacts to the data sources. The SQL connector primarily deals with the data marts and flat files. Similarly, the MDX connector deals with the multidimensional cubes. In the third layer, we have the main components that are the data server, WizQL server, and application server. So the application server takes all the user requests coming from the Tableau desktop, mobile, and browser for accessing the visualization. While the WizQL is a patented component of Tableau, which means visualization query language. It basically works behind the logic of Tableau visualization and creates the visualization as per your instructions on the dashboard. In the fourth layer, we have the gateway. So the gateway is the gatekeeper of the Tableau server, and any request or query sent by the client first hits the gateway or load balancer. So basically a gateway is nothing but a primary server which receives the queries and redirects it to an appropriate available secondary server. That is the worker server. So finally, the fifth layer consists of the clients, where we can visualize the dashboards in desktop, mobile, or browser. So that's about the Tableau server architecture. Next, we will see how to install the Tableau server. So the setting up a Tableau server is a fairly easy process. There are multiple ways to install it on your system, such as automated installation or jumpstart installation, or installing Tableau in an air-gapped environment, cloud installation, and Tableau Online. However, in this slide, we will discuss how to install the Tableau server from the website. So firstly, you will have to open the Tableau website on your browser and click on the Tableau server from the products drop-down menu. As you can see in the slide here, from the products drop-down menu, you have the Tableau server. So once you select Tableau server, it will lead you to a page where you'll have this option of try it for free. So once you choose try it for free, you can download the setup as per your requirements. So here after this, you'll be led on to a page where you'll have multiple options. Here we will choose on-premises version. So once you select on-premises version, you'll get a pop-up where you'll have to put your business email address and download the setup file. So once the setup file is downloaded, you open it and select the location for the installed software files and leave the default. You open the setup file and select the location for the installed software files. And then you click on the next button. So after that, you will have an option of create new Tableau server installation. So you click on the checkbox for the authorization to run to activate the server. So then you click on the install button and wait for the installation to be finished. And finally, you can enter the product key that you've received in your mail and follow the registration process and complete the setup. So that's about installing the Tableau server from the Tableau website.
Now the question is, why do we actually require this Tableau Online? So this Tableau Online, if I want to define it in a few sentences, I can say that this Tableau Online is a powerful way for the organization to build, share, and collaborate around the data analysis. Okay, so it will help the people of that organization to share and collaborate in the cloud, which means the people who are users of the Tableau, especially the Tableau Online, so they don't have to worry about setup in their personal computer. So it's an analytics problem, analytics product or a platform, and this analytics platform, which is Tableau Online, so it is fully hosted in the cloud. And by using this fully hosted on the cloud, so the users of the organization can publish dashboards, share their discoveries and the insights with anyone, especially in their own company, and they can invite colleagues or they can also invite the customers to explore more hidden opportunities by creating beautiful visualization with accurate data. And the best part is it's easy accessible from the browser, or the users can actually access the data or the visualization on the go with the help of mobile apps. So that's the benefit of using this Tableau Online. So it's fully hosted on cloud, which means people do not have to worry about server setup or software setup. That's actually the second advantage or second reason as why we require this Tableau Online. So by skipping this setup time and the hardware cost, so we can actually get up and running in minutes, and we can actually seamlessly add multiple users as per our need and as the organization grows. And by using this Tableau Online, which is a fully hosted solution, so we never have to worry about configuring the server, managing the software upgrade, or even when I think about scaling, I don't have to worry about scaling my hardware capacity, because this Tableau Online is a fully hosted solution. And another reason why people or companies prefer to use this Tableau Online version is, more specifically, whenever we are working with this data source, so we can ask the question in a natural language. Now, when I talk about this natural language is the language that we humans speak. So currently, to converse with you or to explain what exactly is this Tableau Online, I'm speaking in English language. And I'm speaking in a way where we are comfortable with, where we are familiar with. Now, the best part about this Tableau Online is this Tableau Online supports natural language, which means I can empower my organization to ask the question from any published data source. So I can have any published data source. Data source is something where I have my data set present. Okay. So I can empower my complete organization to ask questions from any published data set using natural language. That means using the language which we are comfortable with. An example can be saying it as, hey, what's the average sales per day, or what's the average sales in the last week? So I can just type this question over here in this Tableau Online, and I can get the necessary output in the format of visualization. And I can also control as how the visualization should look like, whether I need a bar graph or whether I need a scatter plot, depending on the question that I'm asking over here for my data source. So here what happens is, with the help, we actually call this feature as a ask data. Okay, so with the ask data, so we can just type a question and we can get the answers in the form under the hood with the help of powerful visualization. But what happens in the backend is it actually makes use of powerful natural language algorithms to automatically profile, index, and also optimize the data sources. And along with these benefits, or along with these features, with the end-to-end web authoring capabilities, it's always easy to add additional data sources, or even if I want to create an interactive dashboard as well. So that's the feature about Ask Data. Okay. Now, the another important advantage or important feature when we talk about this Tableau Online is, so we can have the AI-driven explanations for the given data. Okay, so which means I can leverage the power of AI, which is the artificial intelligence, to explain the data points with a single click. Now here, on the basis of statistical model, I can explain the data, which in turn helps me to uncover the insights which I may not have found otherwise. And the another best part is, while working with Tableau or Tableau Online, so I can also embed the Python code with the help of TabPy add-on, and I can also make sure that during the execution, I'll be doing the statistic-based analysis as well. So which in turn helps me to explain the data in a much more efficient as well as meaningful. So it will help me to explain in much more efficient as well as in a more meaningful format. And the best part, especially when it comes to normal users, is so it will help the users to interact, edit, and author on the web page itself. So by doing like this, the users can spark new insights even on the go. That means they don't have to install anything. They can just log into their tabs or in their company provided laptop, no matter where they are in. They can just spark insight even on the go when they're traveling. They can just create the visualization and try to get the insight that is present in a given data set. So which means here we are going to give the people the power to explore these interactive dashboards from anywhere. And by giving this ability, the users can drill down and they can also highlight, and obviously they can also do the filter the data on the fly. Now by doing like this, they'll be customizing the views with robust web editing, as well as by authoring the new workbooks from the published data set which they already have in their organization. So that's another advantage when it comes to Tableau Online. And not only this, so especially while working with the data, so the users can connect to any data anywhere. That means they can actually connect to databases like Amazon Redshift, Google's BigQuery. So they can connect to databases like these other databases, and from these databases they can actually refresh the data automatically. And while refreshing, they can actually make use of web apps like Google Analytics and Salesforce. And while refreshing, they can also perform the like query on on-premise databases, or even we can actually schedule and extract the refreshes from the Tableau bridge. So the power is always in our hands as where exactly that we want to keep the data and from where I have to fetch the data. And when we talk about security, so security is one of the important thing whenever we are dealing with enterprise data, because that contains the day-to-day information, day-to-day transactions, and it contains the gold mine. Because as I mentioned at the start itself, some of the important asset of any company is data and its people. So here we are giving the power, that is the power of data, to the people, and it's very important that we keep it secure. And coming to Tableau, So Tableau has highest level of security standards, and by default it is present, and by design it is set to make sure that the product that they have built is very secure. So here we can actually empower the site admins to easily manage the authentication, and we can also set the permission for the users, content, as well as the data as well. And here, like when we talk about Tableau, so it's easy knowing that Tableau's online, like it's worth noting that this Tableau's online infrastructure, it actually meets some of the suggested highest level of. So last I've seen, it actually supports SOC 2 requirements when we talk about the security of Tableau product. And another best part of working with Tableau Online is we can effectively manage the data environment. So which means I can actually make use of Tableau data management, which will help me to better manage the data within my Tableau Online. And by doing like this, I'll be ensuring that the trusted data is always used to drive the decision. Now, from data preparation with Prep Conductor, that's one more product from Tableau. So from data preparation with Prep Conductor to cataloging, search, and governance with Tableau Catalog, the data management add-on will actually build the confidence in the data that we are working with. Thus, it's going to accelerate the adoption of self-service analytics, because that's what we want to drive, isn't it? So we want to give this ability to do the analytics or to derive the insights from the data to the people that we already have. So by enabling the various products that are present with the Tableau, and which we can combine it with Tableau Online, so we'll be giving the power to the users itself directly. And not only that, so by doing like this, we'll be empowering the organization with insight. So as I mentioned, so it will help us to accelerate the adoption of self-service analytics. And not only that, so this Tableau Online has dashboard starters. So when I talk about this dashboard starter, so it's actually designed to help you hit the ground running with actionable data in a matter of few minutes. So with just few clicks, I'll be able to connect to popular web applications and create pre-built dashboards in a seamless manner. So that's another advantage of working with Tableau Online. So whenever we are empowering this organization with the data, so it actually helps me to enable everyone in my organization to see and understand the data with offerings for every user type. So the user type can be many things. So I can have an end user, I can have an business analyst, I can have a data scientist. So we can control what is the data and what is the depth of data that will be shown for each and every users. Now, as I mentioned, it could be end users like casual users who are just looking to make a data-driven decisions from a published dashboard. So these users, you can think of them as the end users. So who can be like a salespeople who just looks into the published dashboard, and on that basis they are going to decide, okay, which product should I sell to the next customer, which will help me to boost my sales. Or it could be data enthusiasts in the organization who actually want to use the web authoring to ask new questions from a published data source. Or it could be data geeks who actually want to create and share the wizards and the data sources with the rest of the organization. So this Tableau Online, it enables everyone in the organization by giving all this flexibility and all these features. Now here, whenever we are talking about this Tableau Online, so it's our data which will be powered by the cloud. So here under the data management, this Tableau Online centralize the access to the data in the cloud, and it will help us to publish the data models, and it actually makes it everyone like which is an easy to work with from a curated and a single source of truth. And if I'm using this Tableau Online, so this would make sure that the version that I'll be using, it's always up to date, because it's a managed by Tableau and it's a complete end-to-end solution. So which means we don't have to worry about deployment, we don't have to worry about updation. So everything will be taken care by the Tableau automatically. And the best part is, even when the latest version releases, so we'll not have any downtime during the upgrade as well. And this Tableau Online, it's a subscription based service. So it actually gives the power to the companies to subscribe anyone on our website and choose when people receives any update. And last but not the least, the reason that we would prefer this Tableau Online is, so when we talk about Tableau, the innovation comes as a part of the standard offering. So it has been noted that this Tableau, they actually invest more in R&D than any other businesses in that data visualization industry. So there's always some or the other updates which are coming around, and each update will actually is actually what we have seen is like each and every update that is being released by Tableau. So it is actually making the product a better and better one. So now that we have understood why do we actually require this Tableau Online? So let's understand what exactly is this Tableau Online. So as I mentioned already, it's a cloud hosted SaaS platform. So SaaS is nothing but software as a service. Okay. So which will help us to perform the data visualization and business intelligence. So this will help us to build, share, and collaborate the data that we have in the organization and help us to derive the insights from it. Now that you have understood about the importance of Tableau and why do we actually require this Tableau Online, let's look at the structured learning when we look into learning this important topic that we have just seen, that is the Tableau. So I'll give you a demonstration as how does a structured learning path would look like if you're learning with us. Okay. So in case if you're planning to have your own self-paced learning journey, we recommend you to follow the same learning approach because this learning path is curated by the industry experts as well as the professors from NITW. So this this learning path is actually curated by the experts and the industry leaders. So as a part of your module 1 of this Tableau certification training, so you'll be understanding how you can perform the data preparation using Tableau. And this is followed by an hands-on session, followed by a module 2 where you'll be learning how you can create a connection with Tableau. The reason because as I mentioned already at the beginning, we'll be using the data and this data can be present in various sources. It could be in my Redshift or it could be in Google BigQuery table. So it could be in multiple sources. It's very important that we understand as how we set up this connection. And this is followed by an hands-on activity. And as a part of your module 3, you'll be understanding about the basic visual analytics, where you'll be learning how to create a basic plots, which will help you to derive the insights in a matter of few clicks. This is followed by a hands-on session, which will reinforce the learning that you'll be learning as a part of your module. And this is followed by module 4. Here you learn how you can perform the calculations on the data because not every data that you will be having can be directly used. So we'll have to do some kind of aggregation, some kind of mathematical operation to summarize the data that is given to us. Just to give you an example, suppose as a user, so or as a someone who is traveling to the Bangalore city after such a long time. So if I go to the Bangalore city and if I drink, if I stay in Bangalore city for 1 month and I drink coffee in 30 different places, and if I list down the coffee prices that I paid in each time, so it will be just collection of numbers. So just to let you know, give you the intuition as what I'm trying to say. So let's say on day 1 I've drank a coffee, it costed 20 rupees, and day 2 I've drank 30 rupees, and day 3 I have paid 50 rupees. Likewise, I'll be having 30 different numbers which talks about my coffee prices that I have paid. Now, by simply looking into this column of numbers, it doesn't make sense. So what it would make sense is if I try to find some average of this 30 data points, I'll be able to say, okay, on an average, I have spent, just to give an example, I've spent close to 40 rupees on a coffee. So calculation in Tableau is very important, which will help me to derive the insights from the data, which cannot be seen by simply looking into the tabular, or it could be in the tabular structure. So once you learn about these calculations in Tableau, you'll be performing an hands-on activity to practice the same. And as a part of module 5, So you'll be learning how you can create advanced visual analytics, and this is followed by a hands-on session. And as a part of your module 6, so you look at Tableau, which is called as level of detail expressions, and this is followed by another hands-on session. Now as you can clearly see, so each important topic is followed by the respective hands-on session, and all this will be demonstrated to you by the industry expert. And as a part of module 7, you'll be learning how you can create the geographic visualization in Tableau, and this is followed by an hands-on activity. And as a part of module 8, you'll see how you can perform advanced charts in Tableau, followed by an hands-on session. And module 9 is all about creating the dashboards and representing the data stories, followed by the hands-on session. And this is one of the very important module, guys, that is creation of dashboards and the stories. And at the end, as a part of module 10, so you'll be an industry ready Tableau specialist, and at the end you'll also be given with a project which will help you to practice and recap on all the topics that you have learned. And that project will be on the same standard that we will be working with the enterprise data. So whether you're joining the course with us or whether you're taking your self-paced learning journey, we recommend you to follow this approach. Now, the benefit of joining with us is you'll have the expert support who will be with you throughout your learning step, who will make sure that you'll not only understand the topic, but you'll understand from his experience as how exactly that will be used in the industry. Now, let's see how we can create our first setup using this Tableau Online. Now, before we actually go ahead and create our first site using this Tableau Online, the step one is we have to first plan our site. So this planning plays an important role. The reason because as an organization, I might have the data with me. So while creating the app or while creating the site, it will be like a blank sheet. So I have to first plan it. How does my site would look like, and who are the actual end users, and for what purpose we'll be using those sites. So as a part of step one, so planning the site is very important. So here you actually need to know where exactly the data will be hosted, because we will be having the data present in various scenarios. I can have in AWS, or I can have my data in GCP, Azure, or it could be from the on-premise database. So it's very important that we understand where exactly the data will be hosted and how will I be setting up the connection, and what will be the latency of data. So what will be the speed in fetching the data, and how exactly the data will be utilized, which means who is going to use this data, and also how will they use it. Will it be used for day-to-day monitoring, or will it be used for real-time monitoring? So these are the important 3 things that we have to consider before we build any site using Tableau Online. Okay, now once this plan is complete, so we can actually decide, and it will actually give us many advantages. So here when we are planning the site, so if I come back over here, I have mentioned that one thing that we need to understand is where exactly the data is hosted and who will be using it. So let me do one thing. I'll just open up my Tableau. Okay, now this has various information. I have created some visualization. Some visualization is not visible, but when I post it to Tableau Online, you'll be able to see the complete visualization. I'll just open up this tourism. So you can clearly see that I have some collection of visualization which I have done with the help of the data source, which is called as word indicators. Now I'll do one thing. I'll come over here and click on my data source. Now the data source which I'm currently using is actually called as word indicators. Now here in this word indicators data source which I'm currently using, I have various columns. So I have the birth rate, I have the business tax rate, I have the carbon CO2 emissions, country, year, and ease of business, energy usage, GDP, health expectancy. So I have the information about various columns for each and every instance. So when I say instance, it actually refers to my individual row. You can clearly see this is the collection of data that I'm having. Now on top, if you look at the connection, So connection, I have two types. One is live connection and the another one is called as extract connection. So here, when I talk about live connection, so my data will be present in my source system. That means where exactly the data will be there. So the data will be fetched in real time, and using the data in real time, I'll be creating the visualization. And that's what happens when we talk about live connection. Now, as I mentioned already, whenever I have this connection set as live, so the speed in which I'll be creating the visualization, or the speed in which I'll be fetching those data, it depends on many things. It depends on what's the server speed, or what's the network speed which I have in my current server when I'm communicating with my third party system. It could be my Amazon AWS Redshift or this Amazon Redshift database. So what's the speed in which I'm able to connect to that database? And if I'm fetching some data, so what's the data transfer rate that I have? So which means my network speed is going to play an important role over here. Now, along with that, if I have thousands of users who are interacting with my plot or interacting with my site, and if I'm using the live data, it means I want to monitor the transaction in real time. So if I'm doing some kind of activity where I don't require the live connection, I just need refresh at every intervals. It could be 1 hour, or it could be 1 day, or it could be few hours. So in such scenarios, we actually make use of the connection that is called as extract. Now here, extract is nothing but we'll create a snapshot of my current existing data and we'll store it somewhere, and we'll use that stored information in order to access the same. So that is called as creation of extract. Now by doing this approach, so one advantage is, so I'll not be worrying much about network connectivity between one server to another server. So because I'll be having the data stored somewhere. Okay, now with the data stored, so there will be very less latency when I'm accessing the data. So to give you an example where exactly that we can use this kind of connection of extract is like whenever we are working with report. Just to give you an example, so if I'm worried about as what is the sales at the end of the day, so I'm okay if my data gets refreshed at the end of the day. So I can create the visualization maybe after that particular business day transaction is complete, and then I'll take a snapshot or I'll take an extract, and then I'll go ahead and try to find the insights on the same. So that's one of the example, and to help you differentiate between live connection and the extract method. So as I mentioned, if by using my extract, so I'll be able to work with very large data set with very less latency. And if I'm working with extracts, it will be very fast for me to create the visualization and derive the insight from the data. And obviously, it will help me to improve the performance. And not only that, it will actually provide the offline access to my data because I've already created a snapshot from the given data set with me. So that's the advantage of using my extracts instead of live connection. So once we plan the site, the next step will be building it out. So we'll just have to go ahead and build it. Now, I'll do one thing. I'll show you the steps as how you can create an account with Tableau Online. So in my scenario, I've already created an account with Tableau Online and I have logged in. I'll be showing you once I've logged in. So before that, let me just share you the steps as how you can actually create an account from your end as well. Now, in order to create a trial account, do note that you need to use the business account and you cannot use your personal account over there. So when I say business account, it could be the account email address that you have got from your company which you're working with. Or in case if you're associated with an academia, so if you have an email address from your education institution, you can also use the same. In order to access this Tableau, so I'll do one thing. I'll click on Tableau. I'll just search for Tableau Online, and from here I'll show you. Okay, I'll go to this URL online.tableau.com. Okay, currently it's asking me for login. I'll click on sign up button. All right, so using this link, you can actually create an account with Tableau. See, it says what are the reasons that you have to start with Tableau Online. So you can connect to data sources without leaving the web browser. You can build notebooks and the visualization with web authoring capabilities. You can share interactive dashboards, visualizations, as well as curated data sources with anyone in your organization or in your team. You can seamlessly integrate with Tableau Desktop. So Tableau Desktop is the desktop application which I currently have over here. And I'll show you in a bit as how you can share this visualization that you have created with Tableau Desktop to your Tableau Online. So we can seamlessly integrate the same, and we can take the full advantage of the cloud architecture. The best part is it will be taken care by themselves. So they'll handle the hardware as well as the setup. And the best part is, as I mentioned, the data will be secure in the cloud, and they have the highest level of security standards, and all the Tableau trial sites includes data management add-on functionality. Now what you can do is to create a free account, just click on start your free trial and fill up this form. Okay, and once you fill up this form, so you'll be getting the access. That means you'll be receiving an email using your email address. Once you click on request free trial, so you'll receive an email, and once you receive the email, just activate your Tableau account, and you'll be required to enter your page name, and you'll be required to enter your password. And once your account setup is complete, so you just have to use the same URL, online.tableau.com, and then just log in with your email address and the password. So you just have to specify your email address, click on sign in, and then you'll have to enter the password. And once you are logged in, so you'll be redirected to a home page of Tableau Online. So let me show you how does the home page of Tableau Online would look like. Okay, so this is the home page of the Tableau Online. So I've just created I think yesterday or a few hours back, I don't remember. So this is I have logged into my account. So this is the home page that you'll be redirected once you logged in to your Tableau Online. Now here for that page, I have mentioned the page name as My Learning Tableau 666. Now you can mention your own name during the account creation. All right, now this is the home page, and in the home page, let me just give you a quick walk around on this home page of Tableau Online. So here it says, welcome to your Tableau site, and here using Tableau, you can actually harness the power of your data, unleash the potential of your people. So the main focus of Tableau is data and the people who are actually using it. Now you have the options to create new workbook, new project, new flow, new published data source, or you can also create the virtual connection. And if you have your own workbook, you can also upload the same over here using this button of upload workbook. And you have some other links as well. You can upload a workbook, you can manage projects which are already created, you can manage the users who are actually using your website or this Tableau site, and you can download the Tableau desktop if you require, and you can also download the Tableau prep builder. Okay, so this is about the home page. Now on top, you can click over here. Now once I click over here, it is going to display the personal space, my content, my account settings, and what is the start page that I have to use whenever I'm starting out, and I can sign out. So I can click on my content. So this is going to display the contents that are created by me or which have been made accessible to me. So for now, I'll click on home. Okay, now apart from that, here on the left hand side, I have something called as favorites. Now using this favorite, in case if I have set some workbook or something as favorite, so it will appear over here under the favorites, and I can access my recents. So whichever the sheets or data source which I've used earlier, so it would open over here. And in case if someone has shared some assets to me, it could be sheets or it could be data source, so it would appear over here. And if when I click on recommendation, it's going to display the recommendation. I can click over here on the personal space. So this personal space is nothing but the private space where I can create new content and I can explore by myself without sharing to any other users. And here we have something called as collections. So here we can create our own collection, and I can click on explore, And when I click on explore, it actually displays me the top level projects. So currently I have two top level projects. One is default and the another one is called as samples. And if I go inside one of the top level projects, I can see the various files. So this is the data source, this is actually a sheet, and so on. This is actually a flow. Okay. And if I have some external assets, so I can get to know about the external assets that I've currently used over here in my account. And by clicking on users, I can get to know about the other users who are created over here. I can create my user groups. So we'll come to the users and user groups very shortly. And then we have schedules. So in case if I have some setup, or if I want to refresh some data, or if I want to fetch the data, so I can set the schedule. I can see the jobs, okay, and I can look at the task, and I can look at the health of my site by looking into my site status, and I can click the settings over here in case if I want to set up my own settings over here. Okay, so this is about quick walkthrough on this Tableau Online website. Okay, so now that we have understood as how we can log in and create an account, now let me do one thing. So here on my Tableau desktop, I have this workbook which I have already created. Now, if I want to share this workbook to my Tableau Online page, so it's very simple. I can just click on this share button. Now, by clicking on the share button, so it is going to ask me what is the server that I want to use. So here I have two options. One is Tableau Online and the another one is Quick Connect. Now, in case the Quick Connect is selected and not the Tableau Online, just you can do one thing, just click on this Tableau Online button. Okay, so this is going to set the Tableau Online and it will ask you to sign in with your Tableau Online account. So let me just do the sign in from my end. So I'll just specify the email address which I've got. So once I log into my Tableau Online account, so it's going to give me a pop-up and it asks me as where exactly that I have to publish this particular workbook. Okay, so currently it's asking me to select a project. Let me do one thing. I'll select the project as samples this time. And for the name, I'll specify it as word indicators, example demo. And I can specify the description. I can say this is a Tableau Online demo for word indicators data source. Okay, so this is about the description. Now here I can add tags. Now tags will help me to identify my workbook, and which will actually help me to sort it, or if I want to do the filtering at a later point. Now when we are starting, at least when I'm adding this, I do not have much projects with me, but as I increase the number of users, so as more and more number of users start using our site and they start to create their own visualization to talk about the data storage, it will become very complex. And if I want to search for something, so it will be difficult to simply explore each and every notebook that we have. So the best practice that we follow is we are going to create the tags. So using the tags, we can actually access the required one. So I can create some tags. I'll just say it as GDP. I think that tag has been already, yeah, I can add a tag as GDP. I can add the tag as tourism. I'll add a tag as economy. So in this way, I can create the tags. And here I can mention how many number of sheets that I want to add. So by default, I have selected all the sheets. Now in case if I want to publish only selected sheets from the workbook, so I can do the same. So I can click on edit. So if I hover my mouse over here, you can clearly see that it actually gives me the visualization about each and every sheet. So which in turn helps me to save time. So I can just hover my mouse. Okay, I can understand, okay, this is the sheet which I'm talking about. So let me add it, or if I don't want, I can uncheck this. So in this way we can actually select the sheets. And coming to the permission, so permission means I can mention, okay, which user has which access. So that's actually called as permission. Now by default, here the permission is set as same as project. So whatever the project has, this project has, the sample project has, the same permission will be given for the existing users as well for this new workbook which I'm trying to upload for my Tableau Online. Now for the data source, so I'll be using the data source which is embedded in this current workbook. That means the word indicators data source which I've shown you earlier. So the same data source will be used over here while uploading or while sharing with my Tableau Online. And here I have the more options where I can select whether I want to show the sheets as various tabs, whether I should show the selection, whether I should include my external files as well. So I can do all these selections. And once it's complete, I can click on this publish button. Okay, so this would take a while for publishing to complete. Now, once the publishing is complete, we can go to the Tableau Online to validate whether whatever the worksheet that I have shared from my Tableau desktop, whether is it visible in my Tableau Online. So normally what happens is once the publishing is complete, it would automatically launch my browser. So if you look at it, it has automatically launched my browser and it says publishing complete and the name is word indicators example demo. And here I can share this workbook with the other colleagues of mine in my organization, or I can preview different design layouts. For now, I'll just click on close button so that I can view my worksheets. You can clearly see I have various worksheets that I have just imported, and the owner is Nachiket Murthy, and I have just modified a minute ago. So I have modified at 8:51 p.m., which is just a minute ago. So I have various things. I have views, I have data sources. So data source is the same data source which I've used earlier. Okay, and so I have various data sources. I like this. I have connected metrics. If I've connected something, or if I've built any custom views, it would show. If I have any subscription, it will show. And if there is any lineage in the data, so it would show over here under the lineage. Now under the views, so it displays each and every sheet that I had over there. So in this way, I can build my own page using this Tableau desktop itself. It's very simple. I can create my workbook using Tableau and Tableau desktop, and I can just share it with my Tableau Online. Okay. Now this is about building the site. Now the next thing is adding the user. So obviously while working out, so like it's not a one-man game, or it's not a few people using this Tableau software and creating the visualization. So the main purpose is to enable the data as well as the people to unleash their highest potential possible, which means we need to add multiple users of our organization. They could belong to multiple groups. When I say groups, they could belong to multiple departments, multiple job roles, and we'll be enabling everyone to use the enterprise data so that they can derive the insight from it, which will help them to take the action on the basis of data. So which means we'll be adding multiple users. Now to add the users, you can click over here, the users, and you can add the various users. Now if you want to add the user, you can click on add user, and there are various options to add the user. One is you can add the users by user using their email address, and the another way is you can import from the file. So while importing from the file, you can actually create a file which contains multiple users. So this will help you to create multiple users in a single go. Okay, so for the demonstration purpose, I'm going to add users by email. Now here I can set up the authentication, so whether I need multi-factor authentication or not, and so on. So I can just add the users whether it's Tableau with multi-factor authentication, and here I have to mention my email addresses of the various users. So I can specify something like this. I'll say demo1 at example.com. Okay, and here I can select the site role. Now when we are talking about this site role, so we have various roles that are available whenever we are working with Tableau. So if I click on site role, so under the creator, we have site administrator creator and a creator. So here, when I talk about site administrator creator under the creator, so this is one of the highest level of access for Tableau Online. So the person who is having the site administrator creator access, he'll have the unrestricted access to the content whenever we are working in this Tableau Online. So uh, like if I want to name a person who is above everything, so that person is actually called as server administrator. So this server administrator is actually present for Tableau server. So when I talk about Tableau server, it actually gives the highest license activated, and it allows the unrestricted access for the configuration settings of Tableau server, browser environment, all sites on the server, users and groups, and all the creative assets that we'll have. So for everyone, we'll have the server administrator as the highest access. So that means server administrator has all the access, and the similar access will be provided to my site administrator creator, and this is applicable for Tableau Online. Okay, and we also have something called as creator. So here in this creator, so whenever the user has been assigned to this role of creator, it allows new features. That means this site role, it actually offers non-administrators the maximum level of content access. So if I want to name few actions, so they can connect to Tableau or external data in the browser, they can build and publish flows, they can access the data sources, and they can workbook along with that workbook, and they'll also have access to dashboard status as well, and use the interaction features on the published views. Not only that, when I talk about this creator, so they'll also connect to the data from Tableau Prep or Tableau Desktop, and they can publish, or like when I say publish, they can actually upload or save and download the flows, and they can also work with workbooks as well as the data sources. Now this is about the roles under creator. So site administrator creator and the creator. And under the explorer, so we have something called as site administrator explorer. So under this, so it has the same access that as we have seen for site administrator creator. So one difference is they can't connect to the external data from the web editing environment. So that's the difference between site administrator explorer and the site administrator creator. And the site administrator explorer can connect to Tableau published it. They can connect to Tableau published data sources to create new workbooks and edit and saving the existing workbooks. So likewise, we have something called as explorer, and under the viewer we have only one role that's called as viewer. So this viewer can see the published views which others have created, and use most interaction features, and he can subscribe to views, and he can download the various views as images or and whatever the summaries that has been created. So they can also download the same, but they cannot connect to the data, they cannot create the data, or they cannot even edit or publish a content. Okay, so it's a very limited role. So this is the kind of role that we'll be giving to the end users. Okay, so this is about various site role that we can assign to my individual users. Now, whenever we are working with the organization, so as I mentioned, we'll have most number of users using the content or the data that we have. So which means my individual department has multiple employees. Just to give you an example, my account department has 10 employees, and my data analyst group has 15 employees, and so on. So each user, the permission or the access that I'll give for each and every user in the department will mostly be the same. Now to help us in assigning the permissions, so what we can do is we can actually create the user groups and assign various users for the users, and I can create it as a group, and while giving the permission I can give it at the group level itself, which will help me to manage my permission in an effective manner. So this is about creating the users, and then we can set the permission. So while setting up the permission, so it's always takes in this format. So we'll actually evaluate the permission. So first we'll see whether the capability which we are looking at, whether it is outside the scope of that site role. If it is yes, obviously it will be denied. If no, then I'll be evaluating the role specific or the user specific permission. So whether he's the admin or project leader, if yes, allowed, and so on. So in this way, we'll be evaluating the various permissions, and we can plug in the data. Now, when I talk about plugging in the data, it's about the data source. So we can plug in the data by creating cloud connection, dashboard starter, as well as Tableau bridge. And we'll also have the monitoring and looking at the performance. So monitoring means understanding how the various users are using and what are the sheets that are mostly used and which are the permissions which are actually not required but I have added to them. So those comes under the topic of monitoring the site. And under the step 7, we'll look into increasing the performance. So one thing is like cleaning the data that we have, and instead of using the live connection, wherever possible using the extracts, and pay attention to the site design to make sure that the data and the site that we are working with, it's clutter free. So by doing all these things, we'll be improving the performance, and once we have achieved an optimal performance, we can also look for tuning those performance as well. And coming to the authentication, so Tableau supports various ways of authentication. So we can make use of Tableau authentication, Google, or SSO based authentication.
First, let us check out the meaning of both of these. As I've already mentioned, Excel is a spreadsheet software that displays the data in a tabular format. In Excel, the data is stored in cells. We've already discussed this. And the data can be easily manipulated by manually set formulas. You have to know these formulas, then you can really play around with your data. And one of the advantages of Microsoft Excel is that it is a great tool for visualization too. You can really use graph charts or presentations to highlight a particular insight or data set in your Excel. On the other hand, Tableau is obviously the most powerful data visualization tool that is currently available in the market today. It helps in viewing your data graphically, and it also quickly spots patterns, trends, or correlations between data points. It also grants users to combine various kinds of dashboards in Tableau and charts that really facilitate, interactive analysis between your data. And because of Tableau, one can save a lot of time if one transfers a pre-designed Excel dashboard in Tableau. Here you can update new content and update new visuals. That's another advantage. As I've already said, you can pull your data from external sources. And it also has a very user-friendly functionality, that is drag and drop features, drop down menus, and it really allows users to explore data more freely and more effectively. Now that we know what is Excel and Tableau, let's understand its automation functionality. So the automation functionality helps businesses in getting up-to-date data to make very huge decisions or critical decisions in their organization. Here, both Tableau and Excel have great features to really work with, such live data from multiple sources. Excel here allows you to refresh an Excel worksheet automatically. It involves some manual programming processes. That is, you can create macros. It helps you also to automatically update the worksheets data whenever you open the file. You can really also create simple macros using Excel's Power Pivot and macro recorder tools. Now, if you want to create advanced macros or, manipulate the existing ones, then you will have to have some basic knowledge of Visual Basic application. Now, when you create your macros for the very first time, it may be really time consuming, but once you create it, it will really reduce the time it takes to complete repetitive tasks in a longer run. On the other hand, we have Tableau, which is a little more intuitive with creating processes and calculations. Now, for example, if we need to type the formula once, after that, it will be stored as a field and applied to all the rows referencing to that particular source. So in this way, Tableau really allows you to create an application for the recurring processes. Other than that, you can also create custom formulas in Tableau, but you will not find the custom formula feature in Excel's Power Pivot table. Next, we have data visualizations. So visualization is definitely one of the most important point between the comparison between Excel and Tableau. Visualization is the process to highlight the most important data in your given data set, right? Excel here allows you to manipulate the data on cell level, and then you can create visualization like graph, charts, PPTs of your data. Now, to simplify your visualization creation in Excel, you need to have a deep understanding of how Excel's features work. But on the other hand, Tableau is one of the most powerful and most popular data visualization tools in the world today. That's why it visualizes data from the beginning. It allows you to really see the significance right away. Apart from that, Tableau also differentiates correlations with the help of color, images, size, labels, shape, etc., different features. Thus, it is giving you context as you drill down the data. In the next difference, we have the use. Now, there are different uses of Excel, like it stores the data, it manipulates the data using various operations. It also stores the data in the spreadsheets using cells. We've already talked about that. But you can organize the data into the cell in your preference. That is one big advantage. Now, apart from that, you can also use Excel to represent the data in a very eye-catching manner. You can use tables, graphs to really serve the data in Excel. It also provides various kinds of charts to represent your data. On the other hand, the primary use of Tableau is visualization, that is data visualization. And as we all know, it is one of the best in the markets. It also offers the best user-friendly interface that allows various users to perform data visualization tasks effectively. And the best part of Tableau, as we've already discussed, it can integrate with other software and tools to get raw data. And once you get the data from external sources, you can just visualize it the way you'd like to. Next, we'll be talking about data discovery. So data discovery is really helpful in businesses, right? So if you discover something from your data, you can make future predictions, and it will eventually help the organization to find some insights about it. But the ability to discover data entirely differs in Excel and Tableau. Excel may definitely not be an option for data discovery. While working in Excel, you must have an idea that the data should really help you find the critical insights. But Excel is having an advantage that it saves data in a tabular form. So it really helps you map out your path to insight. And it does that with the help of building formulas, visualizations, and information analyzing. But the sad part about Excel is the entire process causes that problem of drilling down into the data less flexible. Thus, it makes it really hard to explore information in a granular level. On the other hand, Tableau is the best software for data discovery. It helps you explore your data very freely. You need not sometimes know the answer you want ahead of time. It really has, built-in drill down and data blending features. And with the help of these features, you're really able to spot some relationships and trends in your data, that is patterns in your data. And in the end, you can dig down to understand the causes of whatever you are working with, that is the data that you're working with in Tableau. The next difference is in terms of business. So businesses usually use the Excel to produce quick on and off reports, right? Now, because it is really easy to generate the report in Excel, so Excel really offers the spreadsheet where the analyst can put the data and then eventually manipulate the data according to his functions or formulas. And then he can finally create the report in the shortest time without having any coding knowledge. But on the other hand, Tableau, you can really get insights from data. It offers the self-service function that would pull the insights of the data. The analyst here can really use Tableau to get insight from raw data. Most of the time, Tableau automatically imports the data from various sources. Applications. So where is Excel widely used? It's used by data analysts, developers, and also in the process of explore, transform, and load. It really provides the functionality to data analytics in performing the various tasks daily. On the other hand, Tableau is very popular among data analysts to get insights from data. Apart from that, it can also be used by data scientists to perform some inside operations on data. And as I've already mentioned before, non-technical users can also work on these softwares. It's not really that hard. So what are their specialities? Excel is definitely best for data manipulations and descriptive statistics. It is used by data analysts very often to perform such manipulations and statistical performance that you will need from your data. On the other hand, Tableau is best to visualize any size of data without any issues. Okay. Apart from that, it is also helpful to store a very large amount of data. In Excel, there is a limitation though to store the data. Integration. So I'm sure you must be aware of the integration part. Excel offers integration functionality to users. You can connect Excel to different external sources with the help of some plugins. On the other hand, Tableau has many external sources and internal sources that it can connect to. Apart from that, it also has the capability, or it also offers cloud. Now, if you want to integrate any sources to Excel, then you need to have some system requirements. But in terms of Tableau, it is much easy to make live connections to external sources. That is, it provides faster speed and access to connect with such sources. Finally, the various versions. Excel, as you must be knowing, is a Microsoft licensed software. It comes with Microsoft Office, thus it gets its version with every new version of Microsoft Office, that is Office 2019. On the other hand, we have various versions of Tableau. It has desktop version, server version, cloud-based version, etc. You can pick one as per your requirements. So there are two ways to purchase the Microsoft Office. The first one is you pay for the offline version and it's a one-time fee, but you can also get yearly subscription of Office 365, and the charges of Office 365 are $99.99 per year. And for personal Office 365, it's $69.99 per year. On the other hand, Tableau offers 3 different types of subscriptions to users, and all these subscriptions are as follows: the creator, explorer, and the viewer. They are charged based on monthly basis. So for the creator plan, you need to pay $70, while on the other hand, you need to pay $35 for the desktop version and $42 for the cloud deployment. You can go to the official website of Excel and Tableau to check out the latest pricings of their versions. So let's check out a use case. So Tableau employees, managers, and leaders find themselves in a very dramatically altered business world. COVID-19 is obviously impacting every part of the business, from where they work to where they measure success. And in these challenging times, analytics have definitely been critical to helping make decisions confidently and very quickly. While the dashboards that you're seeing on the screen have been simplified, the data has been randomized and made completely anonymous. The use cases that you see are real. So here on the screen, you can see how this dashboard shows the amount of pipeline at risk due to COVID-19, and it also allows their sales leaders to make better decisions about how to allocate their resources. Here you can see how the sales leaders from Tableau itself, the organization itself, are making decisions about how to make their sales, and how to really allocate and use their resources better. There's so many use cases of Tableau that have been used during this pandemic. Like, for example, human resources are using it to ensure employee safety and success. Also, the marketing team are understanding new digital initiatives by using Tableau. So there are many other use cases of Tableau in general.
So let's look at the features based on which I'm going to compare these two tools. So first of all, we're going to talk a little bit about the ease of use and ease of learning these two technologies. Then I'm going to talk about the license cost, base price of both of these. Then I'm going to talk about the connectivity of both of these tools to various other tools, databases, languages, etc. Then utility and system requirement, followed by insight generation, user experience, security, and finally scalability. So without much ado, let's get straight into the module. Now, QlikView is very easy to use and explore given the hidden trends. To search, just type any word in any order into the search box and associative results will pop up. It will also show connections and relationships across your data. It is difficult for the user to design their own views though, due to the menu-driven properties. As per Tableau, its interface is pretty simple, not filled with too many features at one page. It has a drag and drop interface, which does not provide feature to search content across your data, but the user can easily create their own stories using various objects, and it is very easy because of the well-designed GUI surface. Let's talk a little bit about the license cost. Now, QlikView's Personal Edition is free with limitation of document sharing. Each named user license has a base price of $1350, and it will charge you $15,000 for a concurrent user. Now, server license is $35,000 per server and additional $21,000 for PDF distribution. As for Tableau, the private versions come with a fixed fee of $999 or $1,999 depending on your data access. The Tableau server anecdotal evidence says $1,000 per server user with a minimum of 10 users plus maintenance. Apart from these, both of these have their free versions, which you could try out before investing this kind of money. Next, let's talk a little bit about both of these tools' connectivity with other tools, languages, or databases. Now, QlikView integrates with a very broad range of data sources like Amazon Vectorwise, Redshift, Cloudera Hadoop, Impala, CSV, DataStax, and so on and so forth. It can connect with R using API integration and also connect to big data. As for Tableau, it can integrate with a broader range of data sources, including spreadsheets, CSVs, SQL databases, Salesforce, Cloudera Hadoop, Firebird, Google Analytics, Oracle, Pivotal, Greenplum, and Windows Azure Marketplace. It can connect with R that powers the analytical capabilities of the tool and also with big data sources. Now let's talk a little bit about the deployment process and the system requirement. Now QlikView has its own data warehouse with the addition of scripting feature that adds more value to it. We can use multi-level layers in QlikView deployment. As it is very easily deployable and configurable, it starts producing stunning reports within minutes of installation. This product does not use cubes, hence loads of tables and charts in the memory enable interactive queries and creation of reports, a technology that is not yet found in other products. It can be developed on both 32 and 64-bit, and its associative technology makes data modeling way easier. As for Tableau, it does not have its own data warehouse. It cannot create layers while connecting with the dataset, but it is much easier to deploy because it requires more structured data. With that, let's move on to the insight generation of each of these BI tools. Now, most of the people use these two tools for this specific purpose. For all the data analysts out there, QlikView's associative technology makes it way more powerful and helps to read association between variables easily. This feature sometimes helps businesses to understand hidden relations between data points as well. For Tableau, the storytelling feature helps you create a presentation using your available data points. Let's just say if this were a beauty contest, Tableau would definitely win. Next, let's look at the UX of both of these. Now, QlikView has great options available to visualize information. It is loaded with various objects, and we can play with their properties easily and customize it. We can also create custom charts like waterfall, box plot, geospatial charts by customizing properties. While inserting objects, it has a layout and formatting options similar to the theme of the document. Here, we need to work on formatting options to make it more visually appealing. Apart from this, QlikView will also suggest bits and pieces of a dashboard that you could pick up and throw it in yours. Tableau has great visualization objects as well, but with better formatting options. It has very good visualization for geospatial graphs and numerous options for visualizing data. Now, these graphs are always in the best of quality in Tableau. This is why Tableau wins this round. Now let's talk a little bit about the data security. Now QlikView has various security options for script documentation, section access, and user authentication. Direct access to the QlikView document using QlikView Desktop is always governed by Windows NTFS file security. Access to the web-based QlikView Enterprise Management Console is restricted to Windows users who are a member of a particular Windows group. Tableau has great security features as well and is highly handled by the Tableau server. It is a modern enterprise analytics platform that enables self-service analytics at scale through governance. Security is the first and most critical part of the data and content governance strategy. Now, Tableau server provides the comprehensive features and deep integration to address all aspects of enterprise security. This helps organizations promote trusted data sources for all users. so the right data is used to make the correct decisions. And finally, we have scalability. Now, you may have heard that Tableau offers better scalability than QlikView, or that QlikView can scale faster than Tableau. The truth is that both the vendors can handle very huge amounts of data. In fact, the majority of organizations are not even producing that much data, which either solution cannot handle. So with that, let's move on to see how the basic charting works in both of these tools. So this is the QlikSense desktop app, and it is used for its dashboarding functionalities. It's got a great layout. It's very, very user-friendly. And so we're going to see how we're going to create an app here. So this is a button here which says create new app. Pretty self-explanatory, I'm guessing. So I'm going to go here, name this Edureka demo, and create. Now we can see the Edureka demo app was created successfully. I'm going to open app. This might take some time to load. Yeah, so I'm going to go to this option right here. It's going to initialize the data. So what I'm going to do is I'm going to go here to my computer and select the location of the file that I'll be using. So this is the file that I have picked for this particular demo. Here we basically have the average income of all the countries in the world. So we have Southeast Asian countries, Sub-Saharan countries, Europe, Central Asia, Middle East, North Africa, a bunch of different countries. And they are divided into low income, middle income, and upper income categories. All right, now I'm going to add data. And as we see, the data was loaded successfully, so I'm going to close this, and it opens up a new sheet for us. Now there is this amazing feature in QlikView, which is called Insight. Now, the button is right here, but as soon as your data is ready, you can go ahead, click on this button called Generate Insights, and it's going to suggest plots and graphs for you to put on your dashboard. So basically here we have a bunch of different graphs. We have a tree map here, and we have bar graphs and scatter charts and maps and whatnot. So from here, I can choose whether to add these graphs to my sheet or not. So I'm going to add this to the sheet, go down, add this to the sheet, and add the comparison chart to my sheet. Now that we've added 4 of these to our sheet, let's go see what the sheet looks like. So here we are on our sheet. So after I've made my dashboard, I can basically cross-highlight, which is very popular in most of your BI tools. Here, if I select it, you can see the corresponding parts being highlighted in your other graphs, right here and right here. And if I want, I can also cut out all my filters. Then I can edit it, let's say, put in a name for the sheet, call it Tableau versus QlikView demo, because that's what it is. And then you can go ahead, give an expression, create a thumbnail, so on and so forth. But for me, this is enough, so I'm going with done. And then I'm going to save this as my sheet. Now this is as simple as it gets in QlikView. So let's go ahead to our Tableau desktop and see what it has to offer. Now let's try to do the same thing with Tableau. So what I'm going to do is I'm going to connect to a Microsoft Excel file, the same as I did before. It's going to be the same spreadsheet that I had used earlier. Okay, so if I had to say something about Tableau, the first thing would be that straight off the bat, you can see it did not pick up on all my column names, which, if you remember in the QlikView, it had done on its own. Yeah? So then I'm going to open up my sheet and let's try to make a few visualizations. Okay, so I'm going to bring the country names and I'll put up, say, some values. I'm going to turn this into a bar graph per se. I am going to select this and I'm only going to keep, say, our A's. Alright, so select this. I'm going to open up a next one. I'm going to put in, say, a map. So first what I'm going to do is I'm going to take this F1 dimension and convert it into a geolocation. So I'm going to put in country/region, and then I'm going to pick up this dimension and throw it straight here. And it automatically turns into a map. Now, the Tableau desktop might not suggest many insights, but here you have the freedom to create whatever you like. Now that we have two sheets, let me go ahead and create a dashboard. So here we have a new dashboard option. I'm going to go there and drag both my sheets. Now this is definitely not the best dashboard that I could make, but my purpose here is to show you how easy it is to use this Tableau desktop, right? I've put it right here. I'm going to take this and let's say I'm going to edit the title, put in map, edit the title again, put in bar chart. And again, I can do the same. I can just drag these many points, select keep only. And as you can see, these maps are as interactive as any other BI tool. You can choose to save it or put it up in the Tableau server where you can share it with your other colleagues and friends. But this is what creating a standard dashboard on Tableau desktop would take you. If I want, I can change the location of both of these. I can make like a horizontal marking here, add something else to the box right here. But I choose not to do that and keep it just the way it is. You can add text, image, a web page or anything right here. Extensions if you will.
Starting off with data visualization. Tableau is well known for its ability to visualize data. Users can create interactive and customized dashboards that are device agnostic. In Power BI, on the other hand, have a large number of data points to offer data visualization. Its simple drag and drop functionality is a deal for both technical and non-technical users. Next is the products. Tableau and Power BI both have released new data analytics and business intelligence products. Here are the various types of products which are used in Tableau and Power BI. First is the Tableau Serve. Next, Tableau Public, Tableau Online Cloud, Tableau Reader, and finally, Tableau Mobile. Power BI is a part of Microsoft Business Intelligence. It offers a wide range of products which are Power BI Desktop, Power BI Services, Power BI Pro, Power BI Premium, and finally, Power BI Mobile. Next is the security. Tableau comes with the following predefined user roles: viewer, interactor, and editor. The publisher can configure access permission for these roles. Tableau offers data security, network security, and RLS option for administrator. It recommends SSL and HTTP configuration for network communication between the client and the Tableau service. On the other hand, we have Power BI. Power BI stores and manages data storage security using Azure Blob Storage, Azure SQL databases, and role-level security is also provided for role-based data access. And the final one is the dashboard. Tableau features are comparable to those of Power BI. In comparison of Power BI, however, many of the features are hidden behind the menus. Tableau is well known for its attractive dashboards that are simple to build with drag and drop. On the other hand, Power BI includes modern features that assist in converting raw data into interactive and visually appealing dashboards. It allows users to visualize data insights, even if they have no prior knowledge or experiences. Creating dashboards with Power BI tiles or visible matrices which directly interacts with the reports and data sets. Moving on to data cleaning in Tableau and Power BI. Data cleaning in Tableau entails preparing and shaping raw data so that it can be efficiently analyzed and visualized. Here are some of the common Tableau data cleaning steps. Connecting to data. Connect to your data sources in Tableau using one of the available connectors, which are SQL, Excel, CSV, etc. Handling missing values. Identify and manage missing values. You can filter out or replace missing values within Tableau using data sheets. Removing duplicates. Check for or remove duplicate row if necessary. You can do this in Tableau by using the remove duplicate function. Finally, data type conversion.
Ensure that the data type conversion are appropriate for each file. Tableau automatically assures or assigns data types, but you can change them manually if necessary. Data cleaning in Power BI. Power BI is a process of preparing and transforming raw data into a clear and structured format for analysis and visualization. Here are some of the common data cleaning steps used in Power BI. Data loading. Load your raw data into Power BI using the data source connector, which are SQL, MySQL, Excel, CSV, and etc. Handling missing values. Identify and address missing values. You can use Power Query Editor to filter out or replace missing values. Next is the data type conversion. Ensure that data types are appropriate for each columns. You can change data type by using the Power Query Editor. Finally, handling errors. Identify and handle errors in your data. Power BI provides option to replace errors with default values or remove error rows. Now, we will take a look at the parameters of Tableau versus Power BI. Performance. It improves performance while dealing with large amount of data. Source of data. Having access to a large number of services and database sources. Ease of use. Tableau is known for its simple drag and drop interface that allows users to create visualization quickly. Visualization capability. Tableau is well known for its powerful and versatile visualization capability. Tableau is famous for its ability to provide complex and detailed visualization. Finally, data preparation. Tableau has data preparation feature, but it is less advanced than the Power BI's Power Query. A separate tool, Tableau Prep, is available for advanced data preparation. Next is the parameters of Power BI. Performance. It can handle only limited amount of data. Source of data. It can handle only limited sources to access databases. Ease of use. Power BI is well known for its user-friendly interface, particularly for those who are more familiar with Microsoft products. Visualization capability. Power BI provides a wide range of visualization options, as well as the ability for the user to create custom visuals. It focuses heavily on interactive and dynamic dashboards. Finally, data preparation. Power Query provides robust self-service data preparation capability, allowing users to clear and transfer data into the Power BI interface. Now, we will move on to the use cases of Tableau versus Power BI. Here are some of the common Tableau use cases from various industries. Business dashboards. Create interactive and dynamic dashboards that display key outcomes. Track performance against target by monitoring real-time data. Data exploration and analysis. Quickly explore and analyze large sets of data to discover trends and patterns, and how analysis is used to answer specific business questions. Financial analysis. Create visual representation of financial data, such as revenue, expenses, and profitability, by using interactive dashboards and performing financial modeling. Finally, operational analytics. Visualize key functional matrices to monitor and maximize operational process, identify errors, and process improvement opportunities. Next is the use cases of Power BI. Data exploration and analysis. Discover insights and trends by exploring and analyzing large data sets. Perform independent analysis with Power BI user-friendly interface for quick decision making. Inventory and supply chain management. Visualize and analyze supply chain data to improve inventory management. Monitor supplier performance and maximizing the supply chain to reduce cost. Project administration. Monitor project status, resources allocation, and team performance. Create a visual representation of the project timelines and achievements. Finally, data monitoring in real time. To monitor and visualize real-time data, use Power BI streaming capability. It deals with the requirements which are immediately made as insights, such as manufacturing or IoT applications. Now, we will discuss about which should you choose. Both Power BI and Tableau performs well in business intelligence and data visualization. making it difficult to say which is superior. The only conclusion that is relatively easy to draw is that Tableau is more robust than Power BI, whereas Power BI is easy to get started with and it is more affordable. Learning both can be a best option. And the salary for Tableau and Power BI may differ in India and in United States. In India, the salary for Power BI is 5 lakhs to 9 lakhs per annum, whereas in United States it ranges from $117,000. And Power BI salary in India is 5 lakhs to 8 lakhs per annum, and in United States it is $110,000. If you still need to choose which tool is best for you, then try both of them and find out which is perfect for you.
So now let's go ahead and understand why do we need Tableau dashboards. So suppose our manager wants to see the profit performance of the company. So as an analyst, what can you do? You'll be provided with the raw data. Now you'll have to analyze the raw data and come up with visualizations, which you can show it to your team or your manager and get insights from them. So basically, we need a dashboard to have an overview of the company's data and performance. Now, dashboards can be used to help business managers make informed decisions that dramatically impact business performance. Now let us understand what are Tableau dashboards. A dashboard is a collection of several views letting you compare a variety of data simultaneously. For example, if you have a set of views that you review every day, you can create a dashboard that displays all the views at once rather than navigate to separate worksheets. But now if you're getting confused between dashboards and worksheets, like what are dashboards and what are worksheets, then let me break that for you. So let's quickly discuss the difference between Tableau worksheets and Tableau dashboards. So Tableau worksheet contains a single view along with shells, cards, legends, and the data and analytics panes in its sidebar, while a Tableau dashboard is a collection of views from multiple worksheets, and in its sidebar you will find the dashboard and the layout. So worksheet is where you build views of your data by dragging and dropping fields onto shelves, while a dashboard is a combination of several views that can arrange for presentation or to monitor. Now coming to how to access worksheet and dashboard separately. So the steps have been clarified in these points. So like for creating a new worksheet, we have to go to worksheet, select new worksheet, or we can right click and open any tab in the workbook and select new worksheet from the menu. Or we can choose from the drop down menu of new worksheet and select new worksheet. Or the shortest way to make a new worksheet would be to press Ctrl M on your keyboard. While for creating a dashboard, you have to go to dashboard and select new dashboard. Or you can click the new dashboard button at the bottom of your workbook. Or you can also right click on any tab in your workbook and select new dashboard from the menu. And like creating a new worksheet, you can also click the drop down arrow from the new worksheet button and select new dashboard. So now let us quickly discuss a few tips before creating our first dashboard. So before we get started with our dashboard, you should know a few points. Like you should be creatively inspired, like you should have a mind like an artist and take inspiration from as many places as you can see and reflect that in your visualization. Next point would be to know your audience correctly. So it's very important to understand your audience and who you're making the dashboard for in order to get the right visualizations. Third point would be to get relevant data sets. So we might have to choose from a vast range of data and understand our data properly and analyze it in order to get it in our visualization. So for that, we need relevant data sets for making our dashboard more presentable. And lastly would be choose right analysis and right charts. So it is very important to choose the right analysis and right charts in your visualization for creating an impact in the data visualization. So next, let us discuss the steps to create a dashboard. So to begin with, the first step would be to import our data. So you have to select the data source from where you will import your data. Next, you will have to create a new worksheet where you will start your visualization with graphs and bars. Then you'll have to add more worksheets in order to make a dashboard out of it. Fourth point would be to add all these worksheets on the dashboard and add more interactions like filters, slicers, and actions in order to make the dashboard more interactive. And the next step would be to view the dashboard And the final would be to share the dashboard across the stakeholders and the company's manager. So without any further delay, let's get started with our hands-on in Tableau. So this is how Tableau Public looks. To get started with, first we have to import our data. So we'll import a text file, global superstore data, open it in Tableau. So now our data has been imported. As you can see, we have the column headers here where we have the order details, the customer details, the region details, and the product details. And we also have measures like profit, sales, quantity, shipping cost, and all of this. So now we go to worksheet. So here let's name our worksheet as region-wise profit. So here we get the labeled view. Now for region-wise profit, we'll have to drag region that we have in here to rows and profit in columns. So this is how our visualization looks. This is a horizontal bar chart which shows sum of profit on the x-axis while the name of the regions in the y-axis. So we can also add labels to these bars. For that, we need to drag profit to label. Here we can see the labeled bars now. And we can also add color to this. If we drag profit to colors, then the color changes. So this is how our region-wise profit looks. Now the central region has the highest profit, so it's like dark brown, while the lightest shade of blue is indicating the lowest profit. So this is a region-wise profit where we have the region-wise values of profit in a horizontal bar chart. So if we want to see the state-wise profit, but in a geographical view. So for that, we have to drag state to views, and we can drag profit from measures to the view. So this is how it looks like. The sizes of these circles tell us how much profit has been made. But for a better view, we can add colors to these. So for that, we'll have to drag profit to colors and profit to label. So from here, we can change it to colors. Now in this graph, the ones with orange shows loss, while the ones with blue shows profit. These colors also we can change by clicking color, then go to edit colors. Then from here, we can select red and green, where red will signify loss and green will signify growth. That is profit. So the countries which are red in color have loss, while the countries which are green in color have more profit. So this is a state-wise profit view in a geographical map. So on this visualization, if you select any state, it will show you the state-wise profit. So now we have the region-wise profit in a vertical bar chart, a state-wise profit in a geographical map. Now let us make another worksheet which will have the category-wise profit. So for this, we'll drag category from the tables to rows, and we'll add profit in columns. So this is a horizontal bar chart, but now if we want to make it to vertical bar chart, we can just swap and make it into a vertical bar chart. Now this shows us the category wise profit. Now if we want to add subcategories to these categories, then we can add subcategories in the column section. Now let us arrange it in ascending order. Here we can see which categories and subcategories have the highest profit and negative profit, and we can compare it with which one has the highest and which one has the lowest. Here also we can add colors to it by dragging profit to colors. The ones with less profit are lighter in shade, while the ones with more profit are darker in shade. And the one which is loss, that is negative profit, is marked in orange. So here also you can add labels to the columns, but this looks a little clumsy to me, so I'll rather let it be. So these are the three views that we have gotten. One is the region-wise, state-wise, and one is category-wise. Now let's make a dashboard with these three visualizations. So for making a new dashboard, one option could be go to dashboard, make a new dashboard, or we can also come here and select on this and get a new dashboard. we have this on the left pane, that is the dashboard, the layout, and the sheets that we've already created. While in a worksheet, we have data analytics and the table names and measure names. So that's the difference between a worksheet and a dashboard. So here in the dashboard, first we'll have to choose what size to select. So this is a very important step as it decides how it will be viewed in the front end. So here we have this option as default phone or default. So we are going to choose default because we are not going to visualize in phone. And then this is the size of the dashboard. This is the default size that is there. I can fix the size as well, or I can make it automatic. So I'll make it automatic. So it extends, like size of the dashboard is going to adjust with the visualization. So if we are making tiled, then our worksheets are going to be in tiles. Like we add this, these are getting added in tiles. Now if we make it floating, then we can just drag it and size it according to how we want it. Like there's no fixed. So I prefer using tiled because it gets arranged on its own and fits in the dashboard perfectly. So first we'll name the dashboard as profit performance. So to start with making the dashboard, we have to drag our visualization. Let's make it to tiled as that I find easy to work with. So we'll drag region-wise profit, then we'll drag the state-wise profit, and the last one category-wise profit. So now this is our dashboard. So in this dashboard, you can add filters for individual visualization. Like if we select this filter, then if we select central, it's going to show me the data for central for all the other visualizations. And we can also add filters and slices, like we click on this drop down and we choose filters. Now we can choose what kind of filters do we want. Do you want region-wise filters or sum of profit? I'll add region-wise. So here you can see the region-wise filter. So now from here also you can choose what kind of slicer you want. So you select on this visualization, you select on this drop down. Then you can see multiple values from list, multiple values from drop down. I'll choose multiple values from drop down. So here if you select, then you can select all, or you can select just one, or you can select two, and the visualization is going to change for just region-wise profit. So now we can similarly add filters for all the other visualization. Like from category-wise profit, we can add categories in the filter section. So here we go to filters, we select category. Then the categories got added. So we'll keep it as a list because it's a small list anyway. So if you want to select furniture, then it shows just for furniture like that. And similarly, if you want to visualize a state-wise filter, then from this state-wise profit worksheet, we can go to filters, select state, and you'll get the name of all the states. So here the visualization is that I have to type the name of the state. I'll rather change it to multiple values drop down. So where you can select all or just search which state you want and then select the state. So this was a basic dashboard. You can play around in a dashboard using your creative skills, analytical skills, where you can add more visualizations or more charts like a pie chart or a waterfall chart, and use actions between the worksheets to notice changes across every visualization. And there's a lot of things that you can do in Tableau. This was a basic dashboard that was discussed in today's session, but we'll have more content on Tableau dashboards where you'll get to learn more about making advanced Tableau dashboards.
Now Tableau generates some fields which can be visible in the data pane. Now these fields are generated in addition to the fields that are present in the data set. Now the generated fields are measure names, measure values, the number of records, and latitude and longitude. Now, measure names and measure values are two fields created in Tableau by default. Now these fields are created when a data set is imported into Tableau. So you can go into the data pane of the worksheet and view the fields, as I'm going to show you in a little while. A measure name consists of all names of a measure present in a dataset and is always present at the end of the dimension. Whereas all the measure values present in a dataset are kept together in the field called measure values, and it is also always present at the end of the measures list. It consists of all continuous values of all measures. And if we talk about number of records, for those of you who have worked with Excel sheets and Power BI before, your number of records is basically like a count variable. It shows the count of records present in a dataset. It is also an auto-generated field in Tableau which assigns the value of 1 for each record present in the dataset. It can be used to verify the count of records when joining multiple tables as well. Apart from that, we have the latitude and longitude, which are basically associated with geographical detail present in a data. A dataset should consist of geographical details like city, country, or state for this particular generated field to be used. Alright, so let's see how we can use them. Now I'm going to be opening a new sheet in Tableau. Alright, so let's see how measure names and measure values work first. So I'm going to pick up the highlighter to show you where you can find these. So here I have my highlighter. So here at the dimensions shelf you can find the measure names, and here at the measures shelf you can find the measure values. Alright. Now in the first case we're going to be using measure names and measure values, which can be used to see the aggregation of all measures present in a dataset. Now these fields can be shown as different types of visualization in Tableau as well. So what we're going to do first is we're going to drag the measure names into the columns and drag the measure values into the rows. Alright. Now if we turn the marks shelf into automatic, Tableau automatically gives us a bar chart, and if not, you can go into the marks card and select a bar chart. Now this visual is created for all measures present in the dataset. As you can see, we have discount, number of records, profit, profit ratio, quantity, and sales. Same thing we can see here. Alright, here we can see all the measure names and measure values. Moving on. Now you can do a bunch of things with this particular measure. For example, if you suppose want to delete a measure value, you have the option right here. I don't want to delete any. And also you can create an alias for measure names. It can be shown in the visualization for better identification. So if we go to measure names, there's an option known as edit alias. I'm going to select that. And in this example, I'm going to give the quantity volume sales and then click on OK. And as you can see, the name has changed right here in your graph. And these are just a few basic things that you can do with this. If you want to analyze multiple measures in a single visual, this can also be done using measure names and measure values. Alright, with that, let's go to our other generated fields. I'm going to create a new sheet for this, new worksheet, and we're going to talk about the number of records. So again, for this, I'm going to drag the number of records from the measures pane up to rows, and this basically gives us the number of records, which is 9994. Pretty basic. There's nothing much you can do about it. But when we are going to aggregate on the bigger numbers in the bigger data set, this is something which will be very useful to us. Alright, let's add another sheet and we're going to see how we can use the latitude and the longitude. Now, as I had mentioned before, these fields are associated with geographical detail present in the data. So you should have something like a city, country, or state in your data set so that you can use them. Now, unlike other BI tools like Power BI, where sometimes you have to mention that a latitude or a longitude is in fact geographical data, here Tableau is smart enough to auto-generate these measures. So I'm going to take the latitude here and the longitude here. Okay, let's just switch it up. Let's put the latitude here and the longitude here. And you can already see a map appearing. Our second step will be to drag the state from the dimensions and put it on this detail present in the marks card list. And this creates a geomapping visual as you can see on your screens right now. You do not have to select any visualizations. Just by dragging and dropping your latitude and longitudes, Tableau is smart enough to understand that it has to create a map. Now that was all about generated fields. With that, let's move on to understanding how and when to build different types of visuals. Now Tableau is known to create interactive visuals for easy data interpretation. So you can create various types of graphs in Tableau based on the purpose. Now the different charts that can be created using Tableau and their specific purposes is something that I'm going to show in the next segment of this session. So we're going to start with the bar chart. Let's go back to our Tableau desktop, create a new sheet for this and name it bar chart. Pretty basic. Now this is one of the very basic charts. All you have to do is take something on your x-axis and take something on your y-axis, and by default it is going to be made into a bar chart using Tableau. So I'm going to take category of product in my columns, and I'm going to take, say, the profit into the rows, and as you can see, the automatic feature will turn it into a bar graph. And if it doesn't, you can just go to the marks card and select bar graph. All right. The next basic chart we're going to see is the line chart. Again, I'm going to name this sheet. It's always good to be organized because in the end, we are going to use BI tools for organization and analytics, right? So here's my line chart. So a line chart basically is used to compare the data over different periods. A line chart is created by basically connecting a series of dots. Now these dots represent the measured value in each specific period. So again, this is pretty simple. I'm going to take the order date as I just mentioned. It shows data for a fixed period of time. So I'm going to take the order date in the columns and I'll be taking sales this time as my measure, and it automatically creates a line graph. Now Tableau is smart enough to figure out what kind of graph would you need for certain data, but even if it does not, you can always go into the marks card and select the kind of graph you want. Next is a kind of complicated graph, which is the Pareto chart. This is basically a combination of both the charts that I just showed. So Pareto chart consists of both bar and line graph. The same measure is used to create the graphs, but the measure values are manipulated differently. Now, the purpose of using a Pareto chart in Tableau is to identify the contribution of members that are present in a particular field. For example, the profit contributed by different subcategories of a product in a retail store can be analyzed using a Pareto chart. It can be used to show the top members and their contribution as well. So let's try doing that. I am going to be taking the subcategory of products, putting it in my columns. Then I'm going to take profit and put in my rows. Now stay with me because this is kind of a longer process than the other graphs, but it's pretty useful, I assure you. Now I'm going to right click the subcategory and select the sort option. It is going to open this sort of a window. I'm going to select the descending order, and then I'm going to go to the fields, and my field name is profit, aggregation sum. Okay. Then I am going to drag the profit measure again into the rows. It's going to create two separate graphs like this. But if I right click here, you can see an option called dual axis. I'm going to select this and it's going to turn this into circles. It's basically merged the x-axis of both the measures and has converted it into the visualization that you can see right now. Now, next, you have to go to the marks card and select sum profit. And as the drop down appears, I'm going to select bar here and I'm going to go for the color a lighter blue. Okay. Now I'm going to the other profit and I'm going to select the line graph here and I'm going to go for the color orange. Okay, maybe a darker orange. All right, this looks better. Now I'm going to select the sum of profit and the second one right here. And I'm going to right click here and choose add table calculation from the list. Now it opens this primary calculation type of a window. I'm going to select running total from the calculation type because that's what we want, right? We want a running total. And then select sum as the aggregation, which is already selected, and compute using table across. All right. Now I'm going to add a secondary calculation, and this is for our second graph. And here I'm going to select % of total. All right, table across as we have done before. Now I'm going to be closing this window. As you can see, the line graph has changed and it's not on top of the bar graph anymore. That is because we have separate primary and secondary calculations. The line graph here is showing us the total running sum of profit as we had calculated, and as you can see here. And now you can basically select and change colors that you want to make the graph look as you like. I'm going to keep it as it is. And this is the procedure to create a Pareto chart in Tableau. Next in our list, we have a bullet chart. I'm going to rename it. Now, a bullet chart can be used as a gauge or an indicator to show the performance of measures. Now, two measures can be compared to each other using the bullet chart. For example, if we are having to estimate, say, actual profit versus estimated profit, we can compare both of them using the bullet chart. Now, this is going to be slightly different from the three charts that I showed before. Here, we're going to start with the analysis option present in the menu bar. All right. Select Create Calculated Fields. It opens this sort of a field window, and I'm going to just name it as Estimated Profit. We're going to type an estimated value. In this example, the profit is taken as the measure, so the calculated field is created for estimated profit. So I'm just going to type in a number. Let's just keep a 300,000. Now, the good part about Tableau is that till your expression is valid, it is not going to let you apply the changes you have made in a calculated field, which is great for beginners because then you will know exactly where you have gone wrong. For example, if I remove this, you can see the field shows that the calculation contains errors. Not just that, it will even show you the syntax of what your expression should be. So here when I type a number, it shows that my calculation is valid and I can apply this, and there you are. Now go to the measures in the data pane, and you have to hold the control key on the keyboard because you have to select two different measures. So estimated profit and profit. Now click on this option called Show Me, which will show you the various graphs that you can apply here. Top right corner, this is the option. This is the option I'm talking about. And you can see the bullet chart option also being highlighted, which means we can use this particular option for the measures that we have input. So I'm going to select this and you have your bullet chart. Next in our list, we have text tables. So let's just add another sheet. Going to a new worksheet, going to do the same thing. So a lot of this is going to be dragging dimensions and measures and dropping them into columns and rows. Don't mind me not repeating it again and again. So after we've gotten a table like this, I'm going to drag this profit into the text box present in the marks card. And here you have it. It creates a text table by default. Next up, we have a heat map. Now, this is basically a graph which can visualize the data in the form of size as well as colors on different measures. Now, two different measures can be visualized simultaneously using a heat map. So one measure can be assigned to size, whereas another measure can be assigned to the color of the heat map. So let's go ahead and create one. Now, again, I'm going to be holding the control key on the keyboard and select subcategory and sales from the data pane. So let me just select these two. I'm going to go back to the Show Me button on the top right corner of the worksheet and select the heat map. And it's going to look something like this. It does not have any color now. I'm going to take this profit measure and drag and drop it in the color. And now I'm going to drag, let's say, region. Where did the region go? Yeah, all right. I'm going to drag the region and put it in the columns. And now this has created a heat map which can be used to visualize sales and profit across different dimensions in different regions. Next, I'm going to show you how to make a waterfall chart, which is also one of those charts which requires a little more work than the others. So let's see how it's made. Oh my God, we've got like 13 sheets right here. Let's rename this. All right. Now, waterfall chart is a chart that visualizes the cumulative effect of a measure over a dimension. It basically shows the contribution of growth or decline by each member of a dimension. Now, let's take for example, you can see the contribution of profit by each subcategory by using a waterfall chart. All right, so we'll start by making a basic bar chart. So we go to a new worksheet. What we had done for the bar chart thing, take the subcategory, put it in the columns, take profit and put it in the rows. By default, it creates a bar chart, as I had mentioned earlier in this session. Now I'm going to right click on the profit present in the measures pane, and I'm going to choose create and then go to the calculated field option, which opens up a window like this. Now you're going to take this and do exactly what I'm doing. So I'm going to name this negative of profit, and I'm going to put a negative sign right here. I'm going to apply this. Now we're going to use this newly created calculated field negative of profit into the size option present in the marks card. Let's just drag and drop it. Now it shall give you a graph like this, after which you need to click on this sum of profit present in the rows and select quick table calculation and take a running total option. Now the reason why we are taking this negative ad hoc calculation is to fill in the gaps in our bars when we are going to turn it into a Gantt chart. So basically we're going to turn it into a Gantt chart right now in the marks card. And now this will create a waterfall chart, as you can see on your screens. Now talking about the Gantt chart, let's see how we can create a separate Gantt chart. Now a Gantt chart is the one which shows comparison between data in different categories. So it's basically used to identify the time taken for each process. So let's try to make one. Now we're going to take the drop down button in the marks card and select Gantt bar from the list. Now we're going to drag order date and put it in our columns, and then right click on it and select day. Now let's click on analysis on the menu bar and create calculated field like we had done earlier in the session. I'm sure all of you might be familiar with this window right here. We're going to type time for shipment, and we're going to use this formula called date difference. Now, as most of you might have noticed before, shows the syntax right here. We're going to put in a date part, a start date, an end date, and start of the week. So I'm going to put the date part as day in single quotes, comma, in square brackets, order date, which is a dimension, so it appears automatically. Next, I'm going to have ship date. Now the last start of the week you may or may not put, because now that is an optional part of the syntax, so I'm going to choose to not put it and I'm going to apply it as is. Now I'm going to drag this time for shipment into the size part, and I'm going to take ship mode and put it up in rows. And now this has created a Gantt chart. It shows the time taken for each shipment across different ship modes. Alright, now let's go back to something a little more old school, presenting the pie chart. Now a pie chart is something, as most of you might be knowing, it basically shows segment-wise data. It can show the contribution of measure over different members in a dimension, and the angle of the pie determines the measured value. And basically it's one of the most colorful charts. Different colors can be assigned to the pie to represent different members in a dimension. Now we're going to do this on a fresh worksheet. Not going to spend too much time here. We're going to just select segment and sales from the data pane, and then go to the show me button and select the pie chart. And there you have it, pretty simple. Let's move on to another very useful chart, which is a scatter plot. Now the relationship between two measures can be visualized using this particular plot. A scatter plot is designed by adding measures in both x and y axes. This basically shows the trend or the relationship between the measures that you select. Now we're going to try doing that. We're going to drag discount into columns. Here's the discount, put it in the columns. And we'll take sales and put it in the rows. Now this basically creates a scatter plot by default, as you can see. Now I'll be taking the subcategory into the color icon I'm dropping it right there. Now this basically has created a scatter plot showing the relationship between the discount and the sales for each subcategory. As you can see, multiple bubbles. With that, let's move on to the area chart. Now an area chart can represent any quantitative data over a different period of time. It's basically like a line graph where the area between the line and the axes is generally filled with color. Now we're going to hold the control key in the keyboard and select order date and quantity. Next, we're going to click on the show me bar right here and select the area chart icon. Now we're going to drag the region from the dimensions pane so that you can add it in the color icon here in the area tab, and this creates an area chart as you can see. Pretty simple. With that, let's move on to another very basic chart called a dual axis chart. It's basically a chart which can be used to visualize two different measures in two different chart types. A date column and two measures are kind of a basic necessity to build a dual axis chart. The different scales in this chart help the user to understand both measures. So again, I'm going to hold on to the control key and select order, date, sales, and quantity. So order date, sales, and quantity. In the show me tab, I'm going to select the dual combination. And this creates a dual axis chart as you can see. It's pretty simple. Now you can change the color, do anything you want with this chart. Me personally, I would like to keep it as is. I think blue and orange create a very good contrast, which makes your data visible and clear. Next, and the penultimate chart I'm going to talk about is the bubble chart. Now a bubble chart visualizes the measures and dimensions in the form of bubbles. It's kind of like the scatter plot, but it contributes to a more effective visualization. It's as simple as that. All I had to do is click on the packed bubbles option, and it has created a bubble chart as you can see. And finally, we have a very important chart, but also a very basic chart, which is a histogram. Now a histogram shows the values present in a measure and its frequency. It basically shows the distribution of numerical data. As it shows both frequency and measure value by default, it can be used in many cases. For example, if you want to analyze the discount given by a retail shop, you can visualize the amount of discount and its frequency using a histogram. So we're going to go to a new worksheet, select discount from the measures and click on show me. And this is the histogram option. And this is our histogram. It was as simple as that. With that, I've come to the end of all the charts that I had to show. Let's move on to the features of Tableau. Now, as discussed before, Tableau is one of the most comprehensive business intelligence tools in the market right now. Since its inception, it has already witnessed a steady growth and has gained a wide market share in the BI and analytics space. So it's clearly one of the top choices in the BI space. So let's talk about a few features which has made it gain its wide market share in BI and analytics space. So first of all, it's amazing data visualization. Tableau BI is known to offer the most advanced data visualization options and is definitely a market leader. The users can easily perform complex data visualizations by using the drag and drop feature, and it has a slick interface which is both intuitive and fast for creating customized visualization. It is easy for any business user to create customized dashboards using the complex data and sources, which makes Tableau a preferred choice for business users. We have quality customer support, and since Tableau is a fast-growing company with very high customer retention ratio, most of Tableau BI users are satisfied with the product and the technical support provided. According to a survey conducted by Gartner, Tableau is ranked amongst the best BI tool with respect to customer satisfaction. Next up, and very important, it is very easy to implement. Tableau, though rich in features, is easy to deploy and upgrade. As per a survey conducted, more than 90% of Tableau users have the latest version installed, and running it clearly indicates the ease of use and upgrade. Next, we have data source integration. Now, Tableau offers a simple out-of-the-box solution for integrating with the most popular data sources and analytics languages like R and Python. They're also constantly adding support for new data sources. as and when the need emerges. It also supports Hadoop and Google BigQuery API for robust data analytics. Next, let's talk a little bit about its excellent mobile support. Tableau has clearly understood the requirements of mobile users and has developed a robust mobile app which has a very rich user interface. It is a challenging task to showcase complex graphs and visualizations on a small mobile screen, but Tableau has mastered this art, and the visualizations adjust itself based on the screen size of the device which is being used. And finally, let's talk about the rich online resources and community. Now, Tableau has got an active and engaging user community which will help the fellow users to learn and master Tableau. Now, the community is so huge and is so always buzzing with ideas and solutions that it has a vast vendor base who also offer installation and customization services. So what exactly is a parameter in Tableau? Think about it like this. What if you need a component for your visualization that is not exactly in your dataset? Parameters in Tableau will allow you to provide that value which you're going to pass to Tableau. Now, this particular feature will allow you to use aggregated values that aren't readily available in your dataset. It will help you incorporate these values into your dashboards and reports directly. Now, after creation, end users can control the input to see the results of the effect of the parameter. Easy, isn't it? So what exactly is a parameter? Now, any value that is passed to your program in order to customize it for a specific purpose is called a parameter. Now, it could be anything, say a string of text, a range of values, or any amount in rupees or dollars, just to name a few. Parameters will help you experiment with some what-if scenarios. Suppose you are unsure which fields to include in your view and which layout to not. What layout would work best with your viewers, giving them the choice. You can incorporate parameters into your views, your charts, your graphs, and your calculations to let your viewers choose how they want to look at your data. Now, when you use parameters, it is of utmost importance that you need to tie them to the view in some way. One way to do this is via calculations. You can use calculated fields which are incorporated in your visualizations in Tableau. Second, you can display the parameter control in the view for your users to select from the parameter. Now, finally, you can reference parameters in parameter actions, which basically means you can use them in your graphs and see the effect it has on your data. So now that you know a little bit about what parameters are, just theoretically knowing about this concept wouldn't obviously do you much good. So in the next few segments, I shall carefully guide you through the process of creating and using these parameters in Tableau. From this point onwards, we are mostly going to be on our demo machine, which is Tableau Desktop. So let's get started. So when you open your Tableau, it kind of looks like what you're seeing on my screen right now. What I'm going to do is I'm going to connect to the sample superstore that is already provided by Tableau. Now, why I'm doing this is so that you guys do not have a difficulty in finding the dataset that I'm using. You can directly go connect here and follow along. Now, this is what my dataset looks like. I have the sample superstore, which is basically a collection of many stores spread across the United States. It gives you the country, city, and state, the customer name, your shipping details, your order details, your categories and subcategories of your products. Basically, all your sale information, sales, discounts, profits, profit ratio, so on and so forth. This is what your data looks like. Now let's move on to our sheet. So by no means am I going to give you like a full beginning with Tableau tutorial. We already have a few of those kind, and we have one coming up pretty soon, an updated one. So you can go ahead and look at that in our playlist. So basically what I'm going to start out doing is I'm going to create a basic graph. So let's see, I want to create a sales according to the order date sort of a graph. It's going to be a line graph. So I'm going to put the order date in my columns, and there's a measure called sales that I'm going to put on my rows shelf. It gives me a graph like this, but this isn't very informative as we just have 4 years. Now I want a more elaborate graph, so I'm going to go ahead and click on this pill which says year. I'm going to go to the options, select more, and then go to custom. Okay, now this is the custom date dialog box. As you can see, it only has the option year selected. I'm going to go down and I'm going to go select month/year. So it's going to show me all the months through these 4 years. All right. So now, as you can see, we have all the months from 2015 through 2018. We have a much more elaborate graph, something more to work with. You shall basically end up with a graph along the lines of this. It should look something like this. Now we are going to be creating a parameter in Tableau. So basically, the scenario I am trying to create is a what-if scenario, like I had mentioned before. So I'm going to say, for example, what if the sales has been hiked up by 3%? Now, this detail is not given readily to me in my data set. So I obviously have to create a parameter for it. So basically, this is a parameter which I'm going to be using in a calculated field. To create a calculated field, you go to Analysis and create calculated field, or alternatively, you could also go to this down arrow key near Dimensions, and the first option you get is a calculated field. Now, before we make the calculated field, let us create the parameter that we are going to be using in the calculated field. So the second option from that was create parameter. So I have my dialog box. So I'm going to go ahead and name this like if, because it's an if scenario. If sales parameter. I'm going to move the data type to integer from the drop down menu. Current value I am going to keep as 0. Trust me, there's a reason why I'm doing this. Display format is automatic. Now I'm going to go ahead and select the range. Minimum I'm going to be keeping 0. Maximum the default is 100. And step size I am going to keep as 2. So with that, I have created my parameter. It's going to be an integer type parameter ranging from 0 to 100. Now, as you can see, in the bottom here in the parameters set, you can see an if sales parameter, the one that we have just created. Remember that I had told you that you have to use your parameter and tie it to your view in some way. And the first way that I had told you was to use your parameter in your calculation. And that is exactly what we are going to do. Now, in this scenario, we want to use our parameter and a few Tableau functions to create a calculated field to add to our graph. And then we are going to see its effect on our data. So we're going to go ahead and create a calculated field. Now I'm going to name it the same as my parameter, except for I'm going to name it calculation. And here I am going to be throwing in a formula, which if you want to know more about, you can go ahead and check a tutorial that we have on functions in Tableau so you understand what these functions do basically. So I'm putting in this formula here, and at the bottom it says calculation is valid. Now I cannot stress enough, so I'm going to say it one more time in this video. I've mentioned it many times in many videos and lives before, that this is something which shows that Tableau is a really, really smart software. If suppose I remove a parenthesis from here, in the bottom it is going to show the calculation contains errors. And if you hit the arrow button here, it's going to tell you what error it is. This way it prevents you from making mistakes right from the get-go. You do not have to go much further in your process. This is going to be a small process for demo purposes, but usually Tableau is used in an industry level, and there, once you have gone much further in your procedure, coming back and correcting mistakes will be troublesome. So I'm going to hit OK. And in your measures section, you can see your if sales calculation is here. Now what I want you to do is notice how your calculation, the parameter that we created, is going to interact with your sales measure in the segments that follow. Next, what we're going to do is parameter control. Now, coming back to the Tableau main menu, as I had just mentioned, you can see your calculation field in the measures pane and your parameter in the parameters pane. This is your data window. So I'm going to click on this and click on the option Show Parameter Control. On the right, you see this particular option, which is your if sales parameter. This is your parameter control. Currently, it is there in this slider form, giving you your range 0 to 100, which we had selected. You can always go ahead and change it from slider form to your type and form. I prefer the slider form over the type and form. It's easier to operate for me. You can go ahead and make your choice. This is the top right of your view, and this is where by default your parameter control filter is always displayed. Now, I'm not going to show you how it is used right now. In the next segment, you will see what its use is. Now, finally, we are going to be using Tableau parameters in our visualization. This is the part most of you might already be waiting for. Okay, so starting out, what I want to do is I want to switch this for measure values. And I am only going to be keeping my if sales and the regular sales, which we had made the graph with before. Okay, now I have my calculated field if sales right here, and so I have my sales also right here. Okay. Now, because on your right, you can see your parameter control is at 0, you might be able to see just one graph. But as we start moving the slider up, suppose I keep mine at 30, you instantly get 2 of your graphs. One of them is your if calculation, your if sales calculation, which is your calculation grown by 3%, your sales grown by 3%, right? And the other one is your regular sales. You see the difference. Once you click on your parameter control and set it to any number which is visible, like I would suggest go above 10, I have set it as 30, you can see your dual axis graph. You can go ahead and change the color if you want to, but I'd like to keep them in blue itself because I think it's pretty visible. But you can always go ahead and change the colors if you like. Now, these lines represent the running values of sales from your data set and the calculated sales simultaneously. And you've successfully incorporated your parameter in your visualization, along with your control that you have on your right. And that is how you create and use parameters in Tableau. Now, parameters are dynamic and useful elements for you to add interactivity and flexibility to your dashboards and reports. It is a very versatile tool and can be used in way more than what I showed you in this demo. It can be used in various calculations, sets, equally well. Now, this is one of the many smart features that are there in Tableau, which is emerging as one of the hottest trends in business intelligence in 2019. And also, if I might add, it is one of the easiest data visualization tools to learn, one of the most interactive and smart softwares. And if you look at Google Trends, it seems like there can be no better time than right now to get certified in Tableau, to start learning Tableau. So first of all, we have number functions. Now, number functions allow you to perform computations on your data values in the fields. So these functions can only be used with the fields that contain numerical values. Pretty obvious, right? On your screens right now, you can see all the number functions that I'm going to be covering in this segment. We will start with the absolute function or the ABS and close using the ZN function. each of which I'm going to demonstrate to you using the Tableau desktop. So let's get started with our first function. So the first function in the number functions category is ABS, or the absolute function. On your leftmost column, you can see the name of the function. In the column in between, you can see its syntax, and on the right, you can see the description. So what your ABS does is it returns the absolute value of the number or the parameter that you put in the bracket. So if I give like a negative number in there, like a -5, then an absolute function is going to turn it into a 5 and return it back to you. It's kind of like the mod of a number. In the example that I've given, you can see we are trying to get the absolute value of budget variance. So suppose you had a field called budget variance. The ABS function will return the absolute value for all the numbers that are contained in the field. So let me go to my Tableau desktop and I'm going to demonstrate how this works. So this is my Tableau desktop, and currently I'm using the 2019.1 version. This is the Show Me bar. If you want to know more about this interface and how to use Tableau desktop, we already have a few videos, a few tutorials in our YouTube playlists. Please feel free to go ahead and check that out. This tutorial is specifically for functions in Tableau, so we are going to dive straight into that. So as you can see, I have already pulled in the data from the sample data set that is available in Tableau. It's called the Sample Superstore. Now this is only available in the desktop version and not in the public version. So make sure if you're trying to follow through with this tutorial, you are using the actual Tableau desktop. So what I'm going to do is I'm going to navigate to analysis and create a calculated field. This, what you see, is the calculation editor that opens. You're going to name it absolute, as we are going to try the absolute function right now. And I'll show you something simple in the beginning. It's as simple as this. You're going to go ahead and do ABS. And suppose I put in -5, which is the number. At the bottom, it shows my calculation is valid, which is a great thing about the calculation editor in Tableau. It prevents you from making further mistakes, helps you correct them immediately, because at the bottom, it is going to prompt you whether your calculation is valid or not. Then I'm going to apply it and OK. So basically, if I bring this here, let me do the attribute. Yes. So it'll give me the absolute number. Instead of -5, it's going to give me 5, because absolute is kind of like your modulus. It's going to give you the absolute value of the number that you have produced. So let's try it with a field that we have here. So let's go down. So we have this sales field here. So let me remove this and we can go make some changes. So I'm going to edit this field, and instead of placing just the number, I'm going to put in sales. It's automatically going to appear to you. That is how smart this tool is. All right. So when I bring this here, it's going to automatically show a number here. Now what I'm going to do is I'm going to divide this by state. All right, so we can see all the absolute values over here. Now what I'm going to do is I'm going to go to Show Me and put it into a map. So now we can easily go to each state and see the absolute sales in all of these states. We have South Dakota, North Dakota, Montana, and all the other states. As you can see, it shows us the absolute value of the sales in that particular state. All right. And as you can see on your right, it will show you the gradient of color, which basically means that the lighter the colors, the lighter blue there is, the lesser the sales are in that particular state, as opposed to the darker the color, as you can see in the state of California, or it may be New York, the sales are the maximum. No rocket science there. Let's go back to our presentation and look at our next function. So our next function is the arc cosine, or ACOS. It basically returns the arc cosine of the given number. And the result will always be in radians. So if you give an arc cosine of -1, you're supposed to be getting something in lines of 3.1415926. As simple as that. So let's go back to our Tableau desktop and run this and see. Again, we're going to go to Analysis and create a calculated field. You go and type a cos -1 and apply it. And like the absolute measure that we had discussed about the previous time, this also appears under measures in the data pane, just like your other fields, and you can use it in one or more visualizations. So I'm going to bring this here, and it shows 3.142, which is just the rounded off version of 3.14159, and that was all about arc cosine. Next, we have arc sine, which, as the name explains, returns the arc sine of the given number in radians. I'm quickly going to show that here again. And it gives you the answer 1.571. Next, we have the arc tangent, which is given in radians again. It is atan, which is the number function. I will go through this section pretty quickly, as these are not the functions which are used very regularly in Tableau, but they were kind enough to provide us with these functions, so we are going to use them. So I'm going to make an edit in this again. Just quickly going to go through. And you're supposed to be getting 1.565. Next, we have ceiling. Now, basically what it does is when you pass a decimal number to ceiling, it is going to round it off to the nearest integer of equal or greater value. So if I give it 3.26 or something, it's going to round it off to straight up 4. Now, these are available in a couple of data sources, like Microsoft Excel and text file and statistical files, but they are also not supported by a few popular sources such as Microsoft Access and Action Vector or Amazon Aurora, so on and so forth. So here again, I'm going to go to create calculated field and I'm going to name it ceiling, and then I'm going to put on 9.1265, just any number. So as you can see, the ceiling, what it did was it rounded off that number to 810, right? Let me try to. Okay. So that's all about ceiling. Next we have cos. Now cos or cosine of an angle, it's pretty self-explanatory. Most of you, I'm sure, would have studied this in school. It basically returns the cosine of an angle if you give your angle in radians. So what I'm going to do again, so as you all might have studied in school, cos pi by 4 is 1 by root 2 or 0.707. So we're going to apply this. Alright, so as you can see, it gives you 0.7071, which is 1 by root 2, which is again cos pi by 4. Next you have cot or cotangent of an angle, same as cos, that you're going to, I repeat, next you have cotangent or cot, and we are going to implement it the same way as we did cos. I don't think these trigonometric functions need a lot of explanation. We've all done these in school, so let's just get this over with. So again, I'm going to go with a pi by 4 because I'm lazy and I'm not going to think of any new angles. So as we all know, cot pi by 4 is 1. And as you can see, the value immediately changed to 1. The next function we have is degrees. Now what this does is it converts a given number in radians to degrees. And as you can see, pi by 4, as we all know, pi is 180. So your pi by 4 naturally is 45 degrees. And that's what it was supposed to do, and that's what it did. Moving on, we have div or division. So what it does is it's going to return you the quotient, where your integer 1 is basically your dividend and your integer 2 is your divisor. And it's going to give you the integer part of your quotient. So if I do 11 by 2, it's not going to give me a 5.5, but only a 5. As you can see, your quotient is 5. Next, you have the exponent or exp. Basically, it returns e raised to the power your given number. So basically, if we start with something simple, like we'll just put on a digit, say e raised to 2, it's straight up going to give you e raised to 2, which is 7.3. But you can also use these to put in fields and formulas, such as your growth rate into time, so on and so forth. Next, you have floor. Now, this is kind of the counterpart of the ceiling function, where it rounds a number to the nearest integer of the lesser value. So, like in ceiling, if I had to put in 3.1415, it would give me a 4. A floor, on the other hand, would give me a 3. So as you can see, I have used ceiling right here. So let's see, what had we done for ceiling? Okay, so I had put in the number 9.1265 for ceiling. Now let's try putting in the same number for floor. So I'm just going to make an edit in this. I'm going to put floor. Okay, apply and okay. And as you can see, immediately it went from 10 to 9. Our decimal has been rounded off to the lower number. Now again, like ceiling, it is not supported by Microsoft Access, your Action Vector, and your Amazon Aurora, Redshift, so on and so forth. But it is supported by your Microsoft Excel and text file and statistical files. There are many other files which support and also do not support ceiling and floor, but popular ones like Google Analytics and Google BigQuery support both of these functions. Next, we have hex bin. Now, basically what it does is it maps an x and y coordinate to the x coordinate of the nearest hexagonal bin. Now, these bins have side length 1, so the inputs may need to be scaled appropriately. Now, the hex bin x and the hex bin y are binning and plotting functions for hexagonal bins. Now, these bins are efficient and elegant options for visualization of data in the XY plane, such as your maps or visualizations dealing with geographical data, your scatter plots, your hex plots. Now, because these bins are hexagonal, each bin is closely approximated to a circle, and hence it minimizes variation in the distance from the data point to the center of the bin. This makes clustering both accurate and more informative. Next, we have the natural logarithm of a number. Basically, you type ln and then your number, and it's going to return the natural logarithm. If your number is less than or equal to 0, it's going to return a null value. As we know that the natural log of 1 is 0, so that is what we get. That's the only one I remember from school, and that's the reason I put that in as my input. Now, something very similar is logarithm with a base, which we usually take as 10. So if the base value is omitted, you decide to not put in a base, it's by default going to use base 10. So we're going to put in, say, 100, and ideally we're supposed to get 2, and that is it. Log 100 base 10 is 2 because 10 raised to 2 is 100. Pretty simple. Next, we have max, which, as the name suggests, it returns the maximum of the 2 arguments which are passed. Now, the arguments must be of the same type, and this function returns null if either of the argument is null. So, max can also be applied to a single field if it is used as an aggregate calculation, which I'm going to cover in the later segment of this particular session. So, it can be as simple as, say, 2 numbers. So if I put it right here, show by attribute, 7 is larger a number than 4, so here you have 7. Or you could go ahead and put in 2 fields over there. Let's say profit and sales. And when we take the sum of it, now this I remember is the value of sales. Obviously, sales is going to be more than the profit. The sales field is going to have a higher number than the profit. So that's about it. Now the other half of this particular set is the minimum function, which is like the maximum function, but it returns the minimum of the 2 arguments of the same type. So if I just went ahead and edited this particular function, instead of max, let's name it min. And here again, instead of max, let's name it min. Let's put in the min function. I'm going to apply it, and this, I'm sure, is the profit field. As you can see, the number has changed. Next, we have pi. As the name might suggest, it is going to return the value of pi. .142, which is the rounded off value of pi. Next, we have power. So again, we're back at our Tableau desktop, and we're going to try and create a power field. So here, I'm going to just go for power and then our base, which let's take 10, and then the power, so we'll take that as 3. And ideally, our answer should be 1000. So if I drag it to rows, bring it to its attribute, we can see powers is equal to 1000. Next, we have radians, which basically does the opposite of degrees. It converts the number given in degrees to radians. So I'm going to go here again. So earlier we had converted pi by 4 into 45 degrees. So here I'm going to put 45 degrees, and let's hope we are getting pi by 4. So I'll take this rad calculation, put it here, and we get 0.7854, which is also pi by 4. You can do the math, use the calculator, take this moment, pause this, you can go check. Then we have round. So basically what this does is it rounds a particular number that you put in to a specified number of digits, right? The decimals argument specifies how many decimal points of precision to include in the final result. Now, if that part you decide to not fill anything in, the number is rounded to the nearest integer, right? Now, before I move on to my Tableau server, some databases such as SQL Server allow specification of a negative length where -1 rounds to the tens place, -2 rounds to the hundreds place, and so on. This is not true for all the databases, of course, such as Excel and Access do not follow through with it. So with that, let's go to our Tableau desktop and see how this functions. So what I'm doing here is I'm going to round up every sales value to an integer. That's why I did not put anything in the decimals place. If I take a subcategory, all right, as you can see, everything has been rounded up to an integer. No matter what the sales in dollars is, there might be some decimals in there, but all of it has been turned into integers using the round. Next, we have sign, which returns the sign of a number. Now, the possible return values are negative of 1 if the number is negative, and 0 if the number is a 0, and 1 if the number is positive. So I'm going to run this particular example, which I have given here. I'm going to run that itself on my Tableau desktop. So I'm going to be taking the average of the profit field, profit, and apply. Now, because the profit is positive in our given sample set, okay, this looks better. Now, what was I saying? Yes. Now, because our profit is positive in the given sample set, our answer turns up to be 1. If it were negative, it would have been a negative of 1. All right. After sign, we have sine, which is the trigonometric sign again. So it basically returns to you the sine of an angle. All we have to do is specify the angle in radians. So let's just So again, I'm going to take sine pi by 4, which is 1 by root 2. So it comes up to be 0.707, same as your cosine. Then we have the square root of a number, which, as the name suggests, returns the square root of a number. So as we can see, the square root of 100 is 10. Next, we have the opposite of square root, which is the square of a number. Pretty self-explanatory. I'm just going to edit this, name it square. I'm going to do the simplest thing, and you might just think this is a lazy woman, which you're right, my friend. So I'm going to square 10 so we can get 100. And there you have it. It's 100. No big surprise there. With that, we have tan. Okay, so here we have the sign. What I'm going to do, I'm just going to edit this. Not going to create any extra sheet here. Just going to put tan and change this into tan. Tan pi by 4 is 1 for those of you who do not remember from school. And here we have the answer as 1. And with that, it brings me to the final of the number functions. We have Zn, which returns the expression if it is not null. Otherwise, it returns 0. Now, we basically use this function to use 0 values instead of null values. So this is how it works. I'm going to put in a field which I know does not have a 0 value. So I'm going to put in profit. So here I'm going to put in the average of profit. It's in the sum mode now. I'm just going to take the average. And I know for a fact it's not a non-zero value, and it's returned to me the average of profit, which is 28.66. With that, we come to the end of this segment. Let me head back to the presentation to start with the next module. The second segment is string functions. Basically, string functions allow you to manipulate string data. Now, you can do all sorts of things with it, like pull out all the last names from your customers into a new field. One member might be, say, Shubham Sinha, and then you can pull out all the customers with the surname Sinha and then put them in a new field using the string functions. So again, on your screens are all the string functions that I'm going to discuss, which is all the string functions that are available in Tableau. This by no way is an advanced tutorial. I'm just going to show you how each syntax works. So let's start with the first one. We have ASCII. As most of you know, there is an ASCII code for every character of the string, and what this function does is it returns that ASCII character. Now, as we all know, the string A has the ASCII code of 65, and that is what this returns. Next, we have char, which is kind of like the counterpart of ASCII. Here, it's going to return the character that is encoded by the ASCII code. Here, you have to put in the number, and it will return to you the character. And as you can see, it returns A. Next, we have contains, which basically returns true if a given string contains the specified substring. And as you see, it returns true. Next, we have ends with, which returns true if the given string ends with a certain substring. Next, you have find, which returns the index position of the certain substring that you're trying to search for in the string, or 0 if the substring isn't found. If the optional argument, which is start, as you can see at the end of this argument bracket, is added, then the function ignores any instances of the substring that appear before that index position start. The first character in the string is position 1. As you can see, it said that the substring EKA that I was searching for starts from index number 5. Now let's see what happens if we put in our last argument. Let's put a 7. As you can see, because till the 6th index it was not asked to search, it returns a 0, which means it could not find the substring. Next, we have find nth, which basically returns the position of the nth occurrence of a substring within a specified string. So n is where the argument has occurred. So here in find nth, I've changed the word. I've put in learning here, and I'm going to search for when does n, the alphabet n, occur for the second time in the word learning. All right? So if I bring it to text, you see the answer is 7 because Learning, it's an 8-letter word where the second time n occurs is at the 7th position. Now, left returns the leftmost number of characters in the string. So you put in the string and then you put in the number till which you want your substring to be. Let's see, what do I like? I'm going to put it in Matador and then 3. So it's going to print the leftmost 3 characters from the string. Then we have a pretty common one called length. If either of you have used Excel or Word or Access or any of these common databases and apps, you know what len does. It returns to you the length of the string. So what I'm going to do is, there you go, it returns the length of Matador, which is 7. Then you have a function called lower. Basically, you put in a string here and it will return you the string with all characters in lowercase. So I'm just going to randomly capitalize. Okay. So next we have ltrim. Now this basically returns the string without any spaces on the left. So if I try to ltrim space matador space, it is going to remove the space at the left hand side of your string. And here you can see the space on the right is there, but the space on the left is gone. Then we have max, which returns the maximum of A and B, which must be both strings. Now this function is usually used to compare numbers, but it also works with strings. Basically what it does is it finds the value that is highest in the sort sequence defined by the database for the column. It returns null if either argument is null. So I'm going to put apples and bananas, just expression 1 and 2. You can put anything. And then it returns bananas because obviously more number of characters. Next we have mid, which returns the string starting at the index position start. So the first character in the string is position 1. If the optional argument length is added, then the returned string includes only that number of characters. So what I'm going to do is I'm going to use the word learning. And then I'm going to start with the second index number, which is supposed to be E. And then I'm going to give a length, say 5. So 5 characters. Then I'm going to apply it and OK. And as you can see, 5 characters starting from position 2. Next we have min, which is the counterpart of max. It basically reverses what we got in max. It's going to give you the string with the minimum number of characters. So we're going to do the same thing, apples and bananas. You can also put in a field in here and it'll give you the least value from that certain field. So as you go, apples having the minimum number of characters. Then we have right, which returns the rightmost number of characters that you have specified in your syntax. So if I put in learning and for, it should ideally give me ning. And there we have it. Then we have the rtrim, which is kind of like the ltrim but from the right. So if I put in a string with spaces on the right, it's basically going to clear out the spaces. You're going to type the same word, spaces on the left and right both. And when we get it, you can see there is a space on the left, but not on the right, which is the opposite of ltrim, where we deleted the space in the left and we kept the space in the right. Next, you have space, which basically returns a string that is composed of the specified number of repeated spaces. So space 1 is going to give you 1 space, 2 is going to give you 2 spaces, so on and so forth. Then we have split. Now this is an interesting one. It returns the substring from a string using a delimiter character to divide the string into a sequence of tokens. Now the string is interpreted as an alternating sequence of delimiters and tokens. So let's see how this works. And I am going to C and D. Let's put these quotes on both sides. And then I'm going to put in what my delimiter is, which is the hyphen. Now I could have also used slash. The only thing you had to do is specify it in the delimiter part of the syntax. And then I'm going to put in the token number 2, which otherwise should have been my delimiter, this one, the hyphen. But because we've specified the delimiter, it's supposed to be returning a B. And as you can see, it returned B. Now the split and the custom split commands, which are kind of the same commands, are available for a few data types and they're not available for a few data types. So Tableau Data Extracts, Microsoft Excel, text file, PDF file, Salesforce, all of these support the split, and some data sources impose limits on splitting string. And there are These ones which support negative tokens, where there is a limit on the number of splits that is allowed per data source. Next, we have trim. Now, basically, trim is the combination of ltrim and rtrim. It is going to remove spaces from both left and right. So I'm going to again use, as you can see, space and Matador and another space. And as we can see, it has no spaces in the beginning or the end. And here we are at the final string function, which is upper, which returns the string with all characters in uppercase. So I'm going to go here and go with upper and randomly capitalize like I had done earlier. Let's see. And it returns to us Matador in all caps. So with that, we come to the end of string functions. The next segment is on date functions. Now, as the name suggests, the date functions allow you to manipulate dates in your data source, such as year, month, date, or time. So let's go to our first function. We have the date add. Now, the date add returns a specified date with the specified number interval added to a specified date part of that date. For example, if I put in month as the date part, 3 as the interval, and a date as the date, this expression would add 3 months to the date 15th of April 2004. So let's try this. Now this expression adds 3 months to the date. So we had 04 as in April for this date, but if I change this to month, it has July, which is May, June, July, addition of 3 different months. Next we have date diff, which returns the difference between the 2 dates that you have input into this function. The start of the week parameter is the one which you use to specify which day is to be considered the first day of the week. It is optional, of course, but in a lot of countries, you consider Monday as the first day of the week, whereas in the other part of the world, you consider Sunday as the first day of the week. If this part is omitted, then the start of the week is determined by the data source. So let's see how that works. So as the date part, I am putting in week, then I'm going to put in 2015, say 2015 October, and let's say 23rd. And then I am going to put 2015 and the same thing on the 11th month, November. I'm going to put in the start date as Sunday. All right, I think with that we're done. And we're going to change this and it shows that the difference is 5 weeks. Next we have date name, which returns the date part of the date as a string. And the start of the week parameter, again like the previous function, you can use to specify which day is considered the first day of the week. It could be Sunday or Monday or Tuesday, depending on what you like. So if I put in the date part as year, and I put in the year and the starting date of the week, which in this case is not really necessary, it returns a string 2004, which is the name of the year that we had put in. Next we have date part, which kind of does the same thing as the date name, but it returns the date part of the date as an integer instead of a string. So if I made that edit here, It will return to me the same thing, but it is not a string, but an integer. Next, we have date trunc. Now, as a lot of you might have guessed, this basically truncates the specified date to the accuracy specified by the date part. So basically, this function returns a new date. For example, when you truncate a date that is in the middle of the month at the month level, this function will return the first day of the month. Again, this has the start of the week parameter, which you can use to specify which day is considered to be the first day of the week, so on and so forth. So I've put in this date and I've specified quarter. So it's supposed to truncate this part of the date completely and bring me to the beginning of the month. So when I bring this here, so as you can see, it has brought me to the beginning of the month July and has truncated that part of the month from half the month, 15th of July, to the first part. Then we have a day, which returns the day of the given date as an integer. As you can see, it's 15. Next we have isDate. Now this returns true if a given string is a valid date. So if I put in February 30th, 2015, it returns false because there is no 30th in February. On the other hand, if I go ahead, edit it, and put in like a 28th of Feb, it returns true because 28th of Feb exists in every single year. Next, we have a makeDate, which returns a date value constructed from the specified year, month, and date. So if I make date with 2015, 3, and 15, I'm supposed to be getting 15th of March 2015. This is a slight derivative of the previous function. Now this is basically an extension of makeDateTime, and along with the date it adds the time as well. Next we have makeTime, which is exactly like makeDate except for it's for time. So it returns an hour, minute, and second of the time that you put in. Not going to spend much time here as they're all pretty similar in nature. Next we have max that we have used 2 times before, so I'm not going to demo this as well. Again, you will put in 2 dates and it is going to return the maximum of the 2 dates. Next we have min. Again, you're going to put in 2 dates and it's going to return to you the minimum of those 2 dates. Next we have month, which returns the month of the given date as an integer. So if I put in 2005-09-23 and close this, it gives me back 9, which was the month I'd put in. So this is an interesting one. This is called now. This returns the current date and time. Now what it returns varies depending on the nature of the connection. So for a live unpublished connection, now returns the data source server time, and for a live published connection, now returns the data source server time. So I'm assuming that it is going to give you my system time. So just going to go with now. It gives you 2019. If I bring it down to the date, it's going to show 7th of May 2019, which is the day in which I'm recording this video. Another one like now is today, and basically what it does is it returns to you the current date. So instead of now, we're going to put in today, and it gives you today. Nice, isn't it? And finally, the last date function we are going to do is year. So basically, it returns the year of the given date as an integer. And if I bring this here, it gives me 2014, which is the year I had put in, and it's given it back to me as an integer. Next, we have type conversion functions. Now, why do you use these functions? Now, type conversion functions allow you to convert fields from one data type to another. So basically, you can convert numbers to strings, such as age values, so that your Tableau will not try to aggregate them. So let's move on to our first type conversion function. The first one is date. Now basically, this returns a date given a number, string, or date expression. So if I go in and put an order date, basically has given me a list of all the order dates that are there in the data set. Now I can obviously filter this by year. And bring it down to these many dates. Next we have date time, which is kind of like date, but it returns a date time given a number or string. Now, this I'm not going to show you the demo because it is very similar to the date function. Now we have date parse. Now what this does is it converts a string to a date time in the specified format. Letters that appear in the data and do not need to be parsed should be surrounded by single quotes. And for formats that do not have delimiters in between them, suppose hyphens and slashes and dots, verify that they are parsed as expected. So the format must be a constant string, not a field value. And this function returns null if the data does not match the format. So let's see how this works. So this is my format. And this is my date, 15 September and 2005. And this is exactly how it's going to show it to me. This is the same in the table. Next we have float. So basically, if I enter a float 3, it is supposed to give me 3.00. Next we have int or integer, which again, opposite of float, is going to cut down the decimal part of the number and give me only the integer part. And finally, we have a string expression. Basically, you're going to pass in an argument through it and it's going to convert it into a string and give it back to you. So that's all about type conversion. Now let's go back here. For the string, I'm going to give you a demo. Rest all is kind of the same how we had done before and how you do it with other tools. So basically what I'm going to do is I'm going to edit this and str and I'm going to put in the postal code. Now as we all know, postal code is in numbers. So as you can see, this is our postal code and it comes under dimensions. Why? Because it is currently number. As we can see, it's a whole number. Now what we're going to do is we're going to edit this str string and put in postal code and OK. Now, as you can see, the type conversion, which is basically the same thing as the postal code, has a string data type. The postal codes will remain the same, but their data type is going to change. That's what the string function does. And with that, we come to the end of type conversion functions. Let's move on to aggregate functions. There are a few more than the type functions here. So basically what aggregate functions let you do is that they allow you to summarize or change the granularity of your data. For example, if you want to know exactly how many orders your store had for a particular year, you can use the count_d function to summarize the exact number of orders your company had, and then break the visualization down by year. So there are a bunch of aggregation function out here, most of which we have already used as number functions before. And if we haven't used them as number functions before, while we have dragged it to our marks panel, most of you have seen how they work. So let's start with the first one. The first one is attribute. You might have seen through the course of this video how I have changed the default aggregate from sum to attribute many times over in this video itself. It basically returns the value of the expression like it has a single value for all the rows. So it is like one standard value. The null values hence are ignored. Next, as the name suggests, this is the average expression. It returns the average of all the values in the expression. Since I haven't used it before, I am going to show how this works. So suppose I bring in my sales here. As you can see, the default measure is sum. I can break it down to the average and it shows average sales. Nothing new, no rocket science. Next, we have correlation coefficient, which basically returns the Pearson's correlation coefficient for two expressions. Now, the Pearson correlation measures the linear relationship between two variables and results range from -1 to +1, where 1 denotes an exact positive linear relationship, as when a positive change in one variable implies a positive change of the corresponding magnitude in the other. Now, 0 denotes no linear relationship between the variance, and negative of 1 is the exact negative of a relationship. Now, what I'm going to do is I'm going to use a table scoped level of the detail expression. So I'm going to go ahead and this is what it gives. It's between negative of 1 to positive of 1, and this is how far the relationship is linear. So you can say that the relationship between profit and sales is fairly linear because it's on the positive side. And with a level of detail expression, the correlation you can run all over the rows, and the view would show the correlation of each individual point in a scatter plot. If you want to do that. Next, we have count, which returns the number of items in a group. Null values are obviously not counted. And then we have count D, which returns the number of distinct items in a group, which basically means that if a certain item is there twice in a certain group, count D is going to count it as one item. Then we have the covariance expression. This basically returns the sample covariance of two expressions. Covariance basically quantifies how two variables change together. A positive covariance indicates that the variables tend to move in the same direction, when a larger value of one of the variables tend to correspond to a larger value of the other variable on an average. Now, the sample covariance is the appropriate choice when data is random and it is being used to estimate the covariance for a larger population. Like we found out the correlation between sales and profit, we can also find out the covariation between sales and profit. Next, we have covariance of the population. It basically does the same thing as covariance, but this time of the entire population. Next, we have max, which we have tried thrice before. It returns the maximum expression across all records. We have median, which returns the median expression across all records. And then we have the min, which returns the minimum expression across the records. Next, we have percentile. What it does is it returns the percentile value from the given expression corresponding to the specified number. Now, the number must be between 0 and 1, obviously, and this function is available in Microsoft Excel and text file connections, Google Analytics or Salesforce, Cloudera Hive, Oracle 10, and the later data resources of Oracle, Exasolution 4.2 and the later versions, and Sybase. Next, we have standard deviation, which returns the statistical standard deviation of all values in the given expression based on a sample of population. Now, the same thing for the entire population and not the sample is the standard deviation of population. It basically returns the statistical standard deviation of all values in the given expression based on a biased population. Next, you have sum, which is also the default aggregate, which is allotted to all the measures and dimensions that you use. It returns the sum of all values in an expression, and of course it can be used only with numeric fields, and null values will be ignored. Then you have variance, which returns the statistical variance of all values in the given expression based on the sample of your population. And finally, we have the population variance, which gives the statistical variance of all the values based on an entire population and not just a sample. We're finally at our last segment, logical functions. Now, why should you be using logical functions? Now, this is basically used to calculate Boolean logic. If you don't know what that is, it basically means you give a certain condition and it tells you whether it's true or false. There is no other output than true or false. Now, most of these things we've already seen through the many functions that we have covered today, and the rest are very common logical functions if you are from any coding background. So what I'm going to do for this particular segment is that I'm going to go through all of these functions first and then go to my Tableau desktop to show you a tiny demo. So first of all, AND function. Now basically this performs a logical conjunction of the two functions. So basically it's the logical AND. If you look at the given example, it says if your market equals to Africa and the sum equals sales, both are greater than emerging threshold, then it should give the output well performing. Notice how both of these conditions have to be true for Tableau to give you an output of well performing. That is what logical AND does. For logical AND to work, both of the conditions need to be true. Next, you have case. If anybody of you are from the coding background, you can relate it with the switch case. It performs a number of logical tests and returns appropriate values. The case functions evaluates expressions, compares it to a sequence of values, and returns a result. When a value that matches the expression is encountered, case returns the corresponding return value. If no match is found, then the default return expression is used, and if there is no default return and no values match, then null is returned. Case is often easier to use than if, else, and statements like that. Typically, if you use an if function to perform a sequence of arbitrary tests, you can use a case function to search for a match to an expression. But a case function can always be rewritten as an if function, although the case function will generally be more concise. So many times you can use a group to get the same results as a complicated case function. We'll learn more about if in the later parts of this logical functions segment. Next, we have else. Now, this is the counterpart of if. So, if something, then a condition has to be either fulfilled or not fulfilled. It will give you an answer. Else, it will give you another answer. It's as simple as that. It tests a series of expressions, returning the then value for the first true expression. Then you have else if. If you have a number of if statements before your default else, then you use else if. It tests a series of expressions, returning the then value for the first true expression again. Then you have end, which as the name suggests, it marks the end of an expression. Then you have if, as we have already discussed. If basically tests an expression and then returns a corresponding value. Then we have if null, which returns the expression 1, if not null, otherwise returns expression 2. It is basically like a regular if function, except for it just checks for one condition, if the expression you've put in is null or not. Next is if, which checks whether a condition is met and returns one value if true, another value if false. It's basically like a test case and an optional third value or null if unknown. Next we have isDate, which returns true if a given string is a valid date. It's no big deal. Then we have isNull, which returns true if the expression does not contain valid data, which is if your expression is null. Then we have max, which we have discussed many times before. It returns a maximum of all the records or maximum of 2 expressions for each record. Then we have minimum, which does just the opposite. It returns the minimum of all records or the minimum of 2 records. Then you have the logical not, which performs logical negation on an expression. So basically, if the field you have put in does not fulfill the condition, then it gives you the corresponding result. Then you have the logical or, which basically means that if you have put in 2 conditions, either or of them have to be true, then it will give you a result. Then we have then, which we have discussed before. If a certain field fulfills a condition, the corresponding then part is then fulfilled. Now here we have a when function which finds the first value that matches the expression and returns the corresponding return. It's kind of like if and then case, except for there is no if. Then you have Zn, which returns your expression if it is not 0 or null. We have discussed this before. Now let's go to our Tableau desktop and create a logical calculation to see how you can use this. So now again, come back to our Tableau desktop one last time for this session. So again, I am from the data pane, drag state to the rows shelf. As you can see, a table like this should ideally appear. Then I am going to take category, place it at the rows as well. This is nice. I'm going to analysis, as I've done many times before in this session. Create calculated field. Here I'm going to name this KPI, which is Key Performance Index. Basically shows you how your company is doing internally and externally. Internally as in different departments and externally as in the market. I'm going to do a simple sum profit. We can see this here. Now, this calculation quickly checks if a member is greater than 0. If so, it will return true. If not, it will return false. It's kind of like the if and then statement. So when finished, you can go ahead and click OK. As you can see, this new calculated field appears under the measures in the data pane. Just like your other fields, you can use it on this visualization. So I'm going to drag this to the color on the marks card. And I'm going to turn this whole thing into, so I'm going to take the sales and put it in the columns. You can now see which categories are losing money in the states. So all these orange ones are the ones in profit and the blue ones are the ones at loss. And that's the simplest use of the logical functions. You can use this for way more because Tableau is capable of not just pretty graphs, but a good drill down of data.
When we should use calculated fields. So you can use calculated fields to create a new data from an existing data in your data source. When you construct a calculated field in your data source, you're essentially adding a new field whose values or members are determined by a calculation that you control. This new calculated field will be saved to your Tableau data source and can be used to build more complex visualizations. But don't worry, your original information is going to be saved. So calculated fields can be used for a variety of purposes. Here's a few examples, like to easily segregate your data in new ways, to test a notion such as a new dimension or metric before making it as a permanent field to the underlying data. Other than that, it can also help you aggregate the data using aggregation formulas, exclude unnecessary data in order to conduct more thorough analysis, to save database processing and storage resources by calculating ratios across several different variables in Tableau. So let's go ahead and understand with an example. So the manager of the store wants to know the region-wise sales data, which is not clear from the available data set, as we don't have a column for total sales. So as we can see the data, we can see that we don't have a column for total sales. Instead, we have per unit price and quantity of units sold. So now looking into the data and while visualization, we can see that we'll be needing another column called total sales, which will have the product of per unit price and quantity. But adding a new column in the data set and again importing the refreshed data set can be cumbersome and time consuming. Also, it is going to change the raw data set. Rather, if we can make a new column in Tableau itself without making any changes in the raw data and add that in our visualization instead, it can ease our task. So for that, we have to use a calculated field in Tableau. So in calculated field, we can calculate any extra column or any extra calculation that we require. So here we need this total sales value, for which we need to multiply the per unit price with the quantity. So here we have named the calculated field as total sales, and the calculation is the multiplication. But you should get questions on how it was done on Tableau, right? For that, you need to stick around and we will get to learn how it is done as we get ahead in this session. But before that, let's understand what are calculated fields. So by definition, a calculated field does one of these two things. It either calculates database fields to produce a value that isn't directly recorded in the database, or it selects values in database fields based on some customized criteria. So now let us see how we calculated the total sales using calculated fields as we discussed in the example before. So for that, we need to go to Tableau. So here we have imported the global superstore data. But in this data, we don't have the total sales value. We have the per unit price, profit, and quantity. But we require the total sales value. For that, what we can do is multiply the quantity or the number of units sold with the per unit price. But how to do that? We can do that using calculated fields. So for using calculated fields, either we can go to this arrow where we have this create calculated fields, or we can also go to analysis and here we have create calculated field. Here we get this pop-out box where we can write the name of the calculation. So here we are calculating the total sales. So that's the name of the calculation. Now for the calculation, what we are doing is multiplying the per unit price with the quantity. Now we'll select OK and we can see there's a new field added in the measures list. So we'll drag the total sales and we need to see the total sales according to region. So from dimension, we'll choose region. And now we can get this bar chart which shows us the region-wise total sales. And now if we want to add labels according to the number of sales, we can just drag total sales to labels. And there we can see the labeled bars in our bar chart diagram. So that's an easy calculation with calculated fields in Tableau. Now we'll see the different types of calculated fields that are there. So there are mainly three types of calculations you can use to create calculated fields in Tableau. So the first one being basic calculations. Basic calculations are aggregate calculations where you can transform values or members at the data source level of detail. That is a row level calculation or at the visualization level of detail. Whereas in LOD expressions or level of detail expressions, on the other hand, can be carried out at a more granular level with syntaxes like include or a less granular level like exclude or a completely independent level like fixed. And the third one being table calculations. Here you can only transform values at the level of detail of the display using functions like window max, window sum, index, etc. Now let us get started with the next hands-on where we'll see different types of calculated fields. Since we do not live in a perfect world with a perfect data source, our data sources are often unfinished and disorganized. Or sometimes you need a few additional data points for better understanding of the data derived from logic or business ideas. So here comes the role of calculated fields. Calculated fields help you create new data points, or it helps you to clean existing data without making any changes in the original data. So here we will look into a few more examples of Tableau calculations. In our previous example, we used a basic row level calculation. Now we will see another example of the same. Row level calculation means that a value is going to be derived from every value in every row in the same data source. So in our data set, we have a customer ID, which starts with the initial of the customer name. Like we can see Rick Hansen, it starts with RH and then the ID. So we want a new column which will have only the ID. So for that, we can create a new calculated field called ID. So for that, we go to this drop-down arrow, create calculated fields, and we want to name it as ID as we are deriving the ID from the customer ID. So we'll use the split function, and for string, we are deriving it from customer ID. The delimiter, we have to write it within single quotation. So we are writing hyphen within single quotes. And for token number, we are writing 2 since we want the second part after the delimiter. So now let's press OK. Now we want to see the ID against each customer ID. So here we can see that we have the unique IDs without the initials of the customer name. So this is one way to use row level calculation, that is split. Next, we can see how to use calculated fields so let's name this sheet as IT. Now let's make another sheet called average profit. So in our data set, we don't have a column for average profit, but we do have profit. So we want to see the category wise average profit. So we'll drag the profit here. But here we'll write average. So we can see the change in the chart. So if you open this calculated fields box, then here you can see all the different syntaxes available. So here you can also see the aggregate calculations where you have average or collect, count. You can count the number of sales. We also have calculations for different dates. Let's try using the logical calculation as well here. So let's have a new sheet called profitability. Let's make a new calculated field called profitable to know whether it is profitable or not. So for that, the profit has to be greater than 0. And if the profit is greater than 0, then profitable, else not profitable. And we end the syntax with end. Okay, now let's see for each order the profitability. So here we can see against each order if it's profitable or not. So this way you can keep adding new measures and new fields and new columns in the data set using calculated fields. So let's see, when do we use bins? So when we make a histogram, we need to distribute our data in equal parts. These equal parts are known as bins. The data set gets distributed in its designated bins and is visualized in the histogram. The total number of observation present in a bin is known as the frequency of the bin, and there's no overlap of observation in a given bin. So in short, the purpose of bin is to convert a consolidated data into equal sized buckets called bins. So as we can see in this infographics, we have a consolidated data, and when we distribute it in equal parts of data, these equal parts are known as bins. So let us understand the concept of bins with an example. So let's consider a team of 11 players. Here in the first column, we have the name of the cricketers. Then in total runs, we have the total runs secured by each cricketer. And in highest run, we have the top score of each individual cricketer. Then we have balls and wickets. In balls, we have the number of balls bowled by each player. And in wickets, we have the number of wickets taken by each player. So in our analysis, we are going to use only the cricketer name column and the highest run column. So our problem statement is, how is the team's batting performance and how we can make it better. So let's look into the analysis. When we put our data in Tableau, we can get a visualization like this. Here in columns, we have the count of the cricketer, that is on x-axis, we have the number of cricketers, and in rows, we have the bins of the highest run. So here we have the bin size as 10, that is from a range of 0 to 100, we have distributed the data in 10 bins. From 0 to 10, there's only one player who has scored from 0 to 10, which is Zahir Khan from the color index. Then from 10 to 20, we have this bar where we have two players scoring from 10 to 20, which is Sachin Tendulkar and Srishant. From 20 to 30, we have Harbhajan Singh. From 30 to 40, we have Irfan Pathan. Similarly, we can see all the other players. So we can see who is the highest scoring player, which is Suresh Raina, and we can check the lowest scoring player. So from this graph, we can understand the individual performance of the cricketers, and accordingly, we can work on it to make our overall batting performance better. So this was an easy example to make you aware of the concept of bins. Now let's look into a bigger problem and learn how to get this done in Tableau. But before that, let's look into the definition of bins. So as we have already discussed the concept, it will be easy for you to understand the meaning of Tableau bins. So Tableau bins are basically equal sized containers which store the data values from a consolidated data set, and it helps us to organize the data in a more systematic pattern and understand the trends easily. So it is useful in grouping a large data set.
Now let us consider a large data set and understand the hands-on in Tableau Public. So here we have a data set of a credit card company which wants to expand their business by looking into the customers. So here we have the customer details as well as the activity details of each customer, like the gender and age and education level and marital status of the customers, and even the number of products they have bought, or the credit card limit of each individual customer, or the number of dependent accounts that they have, etc. So we will have a age-wise analysis and focus on which age group is performing in which way, and accordingly take a step to expand the business according to the target audience. So for the target audience, we need to look into the age of the customers. So for that, we are making a bin on the customer age. So we'll right click on customer age, then we go to create. From create, we'll select the bins option. So here we have a suggested bin size by Tableau itself, but you can choose your own bin size from 0 to any number. So here we will go for 5. We'll keep the bin size as 5. So now we'll drag the customer age bin to columns and we'll look into the number of clients that we have. So this is client num, that is the number of clients, and we'll take a count of it. So we right click on client num and we go to measure, we change from sum to count. So this gives us the number of customers that we have from a age range. So from 0 to 25, we have 195 customers. From 25 to 30, we have 540 customers. And similarly, we can see the individual numbers. But from this histogram, we can check which age group has the highest number of customers, which is 45. That is 40 to 45. So this visualization, we can label it as well. So if we want each bar to have a label, we'll take the client num to label. And since we are working on the count of client num, we'll change the measure to count. So here you can see the numbers, like when we are going to one bar, the number which shows is showing on the top. Similarly, if you want to add color to the bars, then you can add colors. If you want to change the size of the bars, you can change the size of the bars from here. So from this graph, we can understand that the highest number of customers are aged from 40 to 45, this age group. So to expand our business, we can focus on the age groups which are less in number, like from 0 to 25, 25 to 30. We can expand this number by offering credit card offers like discounted price or no down payment options, or even give coupons like if you purchase our credit card, you're going to get 50% off on different other shopping portals. Or if we want to focus on age group 55, we can focus on different offers which would attract this age group. So this graph can give you a clearer visualization to how to deal with the data and how to come up with more ideas to expand the business. So that's it from today's video. I hope you've understood what are bins in Tableau and you can use it in your daily analysis, and it should help you get a clearer idea of how to present your data in histogram using bins.
What are context filters? You can think of a context filter as being an independent filter. Any other filters that you set are defined as dependent filters because they process only the data that passes through the context filter. Now, you can create a context filter for either of these reasons. First of all, to improve your performance, which is the main objective of having a context filter in the first place. If you set a lot of filters or have a large data source, the queries can be extremely slow. You can set one or maybe two context filters or more context filters to improve the performance. Next, to create a dependent numerical or top N filter. Here I'm talking about determining the top 5, top 10 of a certain category. You can set a context filter to include only the data of your interest and then set a numerical filter on top of it. For example, suppose you're in charge of stationery products for a very large stationery shop chain. Your task is to find out the top 10 pencil brands that sell by profitability for all stores. Now, if the data source is extremely large, you can basically set a context filter to include only pencils or products categorized under pencils. Then you can create a top 5 filter or a top 10 filter by profit and net profit as a dependent filter, which would then process only the data that passes through that context filter. If your Tableau desktop version is post Tableau 9.0, the context filter here no longer create temporary tables except for generic ODBC data sources and a few other customized data sources. So now let's directly move on to creating a context filter on our Tableau desktop. So this example basically walks you through how to create a context filter. Now simply put, to create the context filter, you have to select Add to Context from the context menu of an existing categorical filter. The context is computed once to generate the view, and all other filters are then computed relative to the context. Now this example is going to walk you through how to create a context filter, but for that first you'll be needing to filter a view to show the top 10 products by sales. So we are using the sample superstore data source so that it will be easily available to everybody to follow this tutorial. So firstly, we are going to be creating an initial view, which is going to display the sales for all subcategories sorted from the highest sale to the lowest sale. Yes. So we are going to be taking sales measure, and that's going to be our column. And then we're going to take subcategory from our dimension. That's going to be a row. And right now it's in a very haphazard order. We are going to go ahead and order it in a descending order. Yes. So now we know phones make maximum sales and fasteners make minimum sales. So now what we're going to do, we're going to create a top 10 filter to just show the top selling products. You can create this filter by first dragging this subcategory into the filters shelf right here, and then you will get this filter subcategory dialog box where you can go to this top tab and define what you need from the filter. Yes. So what we're going to do is we're going to filter the top 10 by sum of sales. So we are going to select by field, top and 10. All right. You're going to apply this and click on OK. All right. So right now we have our top 10. And now you can see when you click OK that the view is filtered to show the top 10 product subcategories in terms of sales. Now let's go ahead and add another filter to show only furniture products. So what I'm going to do is, where is category? Yes, it's here on the top of the dimensions. So I'm going to drag that to the filter shelf. And here when the dialog box comes up, I'm going to go ahead and check only furniture. When finished, I'm going to click on OK. Yes. Now the view is filtered, but instead of 10 products, it only shows 3. Now this is because by default, all filters are evaluated separately and the view shows the intersection of the results. So the view shows that 3 of the top 10 overall products are furniture products. Now to find out what the top 10 furniture products are, we need to make the category filter a context filter. So what I'm going to do is I'm going to right click the field on the filter shelf, and here I have the option of adding to context. So I'm going to click on add to context, and now as you can see, this filter is marked as a context filter and the view updates to show the top 4 furniture products. Now why not 10? Because only 4 of the subject categories contain furniture. But we now know that the top 10 filter is being evaluated on the results of that particular context. Now here's a couple of tidbits you need to know about context filters. Firstly, they're going to appear at the top of the filters shelf, as you can see, and are identified by a gray color, as again you can see. Now see if I try to rearrange this. It cannot be rearranged in the shelf. In our scenario, the furniture dimension is set to be the context for the view, and the subcategory filter is computed using only the data that passes through the furniture category. Next, let's look at a few ways to improve the performance of context filters. Let's look at a few ways to speed up our context filters. Now, especially on large data sources, there are a few general rules that we usually follow. First, using a single context filter that significantly reduces the size of the dataset is usually much better than applying many context filters. In fact, if a filter does not reduce the size of the dataset by 1/10 or more, it is actually worse to add to the context filter because of the performance cost of computing the context. Next, remember to complete all of your data modeling before creating a context. Changes in the data model, such as converting dimensions to measures, will require recomputing the context, which again will slow down the performance of the view. Next is to set the necessary filters for the context and create the context before adding the fields to the other shelves. Doing this work first makes the queries much faster that are run when you drop the fields on other shelves. And finally, if you want to set a context filter on a date, you can use continuous date. However, if you're using date bins like year of date or context filters on discrete dates, these are usually very effective. Now understand that if your data is heavily indexed, context filters may not provide the best performance improvement and may actually cause slower query performance. Context filters can adversely affect any query performance improvements when you use the Assume Referential Integrity option in the data menu of the data source. Now that we got a knowledge overdose, let's go back to our demo machine and look at how we can modify a context filter. Now there are two ways in which you are going to modify your context filter. One of them is if you want to edit the filter, and second one if you want to remove it. But both of them are done exactly the same way. Now it's fairly simple. All you have to do is go to the filter shelf, check your context filter, which is in gray. You're going to click on this little drop down arrow right here on the right, and there you get a drop down menu where you have options such as edit filter, show filter, clear filter, remove from context, so on and so forth. Now if I go on edit filter, here instead of furniture, I can choose office supplies. And on applying, you can see it basically edits my context filter. Okay. Now the second thing is removing from context. In such a scenario, the filter remains on the shelf as a standard filter. And if there comes a situation where other context filters remain on the shelf, a new context is computed. But this category no longer is a context filter. It's a simple filter. And finally, you can remove the field completely from the filter shelf by again clicking on the same arrow and then clearing the filter. Yes? With that, you know all the three ways in which you can modify a context filter. So what are table calculations in Tableau? Table calculations are basically this special type of field that computes on local data. They are transformations you apply to values in a visualization. They're calculated based on what is currently in the visualization and do not consider any measures or dimensions that are filtered out of the visualization. You can use your table calculations to transform values, including but not limited to rankings, running totals, and percentage of total. Now, for all charts in Tableau, there is a virtual table that is determined by certain dimensions in the view. This table is not the same as the tables in your data source. Specifically, the virtual table is determined by the dimensions within the level of detail in a Tableau worksheet. Now that you know what table calculations are, let's move on to the fundamentals of table calculations. Now, when you add a table calculation, you must use all the dimensions in the level of detail, either for partitioning or scoping, or for addressing or direction. Now, to do so, you need to understand what partitioning fields are. Now, the dimensions that define the scope of data it is performed on are called partitioning fields. The table calculation is performed separately within each partition. Now, partitioning fields break the view up into multiple subviews or subtables. And then the table calculation is applied to the marks within each such partition. Now, the remaining dimensions upon which the table calculation is performed are called addressing fields. These determine the direction of the calculation. Now, the direction of the calculation is slightly tricky to understand, which we shall also cover in the later part of this tutorial. Basically, the direction in which the calculation moves, for example, in calculating a running sum, that direction is determined by addressing fields. So when you order the fields in the specific dimension section of the table calculation dialog box from top to bottom, you are specifying the direction in which the calculation moves through various marks in the partition. Basically, you add a table calculation using the compute using option, and Tableau identifies these dimensions automatically as a result of your selections. But when you want to determine which dimensions are for addressing and which are for partitioning, you need to use specific dimensions. Now, if the whole table calculation and the direction in which your calculation moves part has confused you a little, I know for sure it confused me for the first time, the next segment is going to clear that section out. So let's understand how does computation work in table calculations. First of all, there are a couple of different directions in which these calculation moves, starting out with across table. In this particular table, the calculation moves across the length of the table and then restarts after every partition. In the table that you see in front of you, the calculation is computed across columns, year order date, and for every row, which is the month order date. Next is similar, but it goes downwards. We have table down. Now, this particular calculation moves down the length of the table and restarts after every partition. In the table that you see in front of you, again with the same measures and dimensions, the calculation is being computed down the rows for every column. Next, we have across then down. It's as the name suggests, this table calculation happens across the length of the table and then down the length of the table. If you see the table in front of you, calculation is being computed across the year column and then down a row, and then across the columns again for the entire table. Here your partition is basically your entire table. Similar, we have down then across, where you might have guessed it, the calculation goes down the length of the table and then across the length of the table, as you can see in the table in front of you. Then you have something known as a pane, and here the calculation goes down an entire pane. In the table in front of you, for example, the calculation is computed down the month rows for a single pane. Then again, even in panes, we have something known as across and down, and here it goes across the entire pane and then down the pane. The likes of which you see in the table in front of you, the calculation is computed across the year column for the length of the pane and then down the month row and then across the column for the length of the pane again. The same thing you have with down then across. Here the calculation goes down an entire pane and then across the pane, like you see in the table in front of you. I don't think that requires much explanation as I've done it around a couple of times before. Then you have one which goes within a single cell, not very difficult to understand. You can see the calculation, the orange box surrounding one cell only. Apart from that, you also have a few wildcards. One of them is specific dimensions. Here the calculation occurs only within the dimensions you specify. In the visualization that you see in front of you, the dimensions month of order date and quarter of order date are the addressing fields, and we have selected them. And the year of order date is the partitioning field since it is not selected. So the calculation transforms the difference from each month across all quarters within a year, and then the calculation starts over for every year. Also, if all the dimensions are selected, then you can understand that the entire table is in scope. Apart from this, you also have the add the level option, which is only available when you select specific dimensions in the table calculations dialog box. And when more than one dimension is selected in the field immediately below the compute using options. Basically, this is the option you get when more than one dimension is defined as an addressing field. With that, let's move on to building, editing, and removing a table calculation in Tableau. For that, we'll have to go on to our demo machine, which is the Tableau desktop app. Here we have our Tableau public desktop app. It's a great way if you're just, dabbling into various BI tools and you don't want to invest in something already. This is also a great tool to learn how to use Tableau, as this has a capacity of computing on 1,000,000 rows, which is not all that bad for a free application. So let's get building a table calculation. So I have already opened the Tableau desktop and connected to the sample superstore. The dimensions and measures to which you can see on my left or on your left, and I'm already on a new sheet. Now this sample superstore is available to you if you download any version of Tableau desktop. Apart from this, you also have a dataset known as global indicators. You can try this with that as well. In the data pane under dimensions, what I'm going to start out with is I'm going to drag order date to the row shelf. All right. As soon as I dragged order date into the row shelf, you might have seen it automatically updated to the year of order date. On the row shelf next, I'm going to right click on this and select quarter. On the same shelf, I'm going to click on this plus icon over here on quarter of order date, and the month of order date is added on its own. Now from under the dimensions, again, I'm going to drag order date to the column shelf. Okay, let's do that. The dimension automatically updates to the year of order date as it had done before. Now we're going to go to measures and drag, let's see, sales to this text marks card over here. And now your screen should look like mine right now. You have your rows and columns of quarter versus year of order date. Now step 2 is adding the table calculation. Now on this marks card that you see right here, I'm going to right click on the sum of sales and select add table calculation, which will be an option at the bottom right here. Something like this is going to appear on your screen. This is the table calculation dialog box. For calculation type, I'm going to select difference from, which is already selected by default. For compute using, I'm going to select table across. And when finished, I'm going to exit the dialog box and check my work. Now what I can do is I can go around from every year to every quarter, and I can see the difference in sales from the previous along the table. So congratulations, you've built your very first table calculation on Tableau. Now basically to edit a table calculation, we are going to right click here. This is the measure in the view which the table calculation is applied to, and select edit table calculation. Here I can change the calculation type to difference from to percentage difference from, and then compute using across, and then close it. And as you can see, instead of difference in sales from previous year, right now I get percentage difference in sales from the previous year. And all of these numbers have turned into percentages. You can make as many changes or as few changes as you like. Feel free to play along, because that is how you're going to learn how to use this tool. Now, to remove a table calculation is pretty simple. Basically, again, we are going to right click on this measure. This is the measure again to remind you. This is the measure in the view which the table calculation is applied to. And then we can select clear table calculation. Here, this option. This removes the table calculation from the measure, and the visualization updates with its original values. So click on it, and it's back to where we started from. Here, see? No difference in sales, no percentage difference in sales, no nothing. Also, the little triangle right here on the right that you can just go back 5 seconds and notice, which is a sign of having a table calculation, is gone. So what are sets in Tableau? So Tableau sets are basically custom fields which are used to hold the subset of data based on a given condition. In real time, you can create a set by selecting members from the list or from a visualization. You can also do the same by writing custom conditions or selecting top or bottom few records in a measure. So basically, a Tableau set is a field which holds certain parts of your data to which you can apply a certain condition. Simple? Now there are two kinds of sets that you can create in Tableau. Number one is a dynamic set. Now the members of a dynamic set change when the underlying data changes. It basically updates automatically. So dynamic sets can only be based off of a single dimension. Now apart from that, you also have your fixed sets. Now the members of a fixed set do not change. A fixed set can be based on a single dimension or a multiple dimension. Since it is not going to update on its own, you can have multiple dependencies in this situation. Now that you know just enough to begin with sets in Tableau, let's move on to our Tableau desktop so you can understand how to use these things better. Alright, so now in front of me I have opened the Tableau desktop. This is the Tableau public workbook, which is pretty much like your Tableau desktop except for it's free. Now, I have already connected it to the sample superstore, which you have access to if you have Tableau desktop or Tableau public desktop. So to create a dynamic set, which is the first one I'm going to create, I'm going to navigate to the data pane, which is here on the left hand side of your screen. And there I'm going to select a particular field. In my case, I'm choosing country or region. I'm going to right click on it, go to create, and it extends to a couple of options like calculated field, group, set, and parameter. I'm going to select set. It's going to take a while. Now, in front of me and in front of you, those of you who are following, you will find something called the create set dialog box. This is the dialog box and how it looks like. Now you can basically configure your set. So you can configure your set using a few tabs. You can use the general tab, which we are on right now, to select one or more values that will be considered when you are computing the set. Alternatively, you can also select the use all option, which is right here at the bottom, to always consider all the members even when new members are added or removed. So I'm going to go ahead and select all. Now we can move ahead to the condition tab. Here we can define rules that determine what members to include in our set. For example, you might specify a condition that is based on the total sales that only includes categories with sales of over $100,000. So I'm going to go to sales, and then sum is already selected, and let's say $100,000. Now you need to understand that set conditions work the same as filter conditions. So we can also make use of the top tab here. Now this tab we are using to define the limits on what members to include in the set. So for example, you might specify a limit that is based on the total sales that only includes the top 5 products based on their sales. So again, I'm going to go select by field, select sales, and by default it says top 10. Let me go ahead and change it to top 5. Now when you're finished, you can go ahead and click OK. Now in the bottom here, you can see the new set is added. It's here at the bottom of the data pane under the sets section. Now a set icon looks something like this, which is two intersecting bubbles. And now you've created a set. Now this was all about creating a dynamic set. What about fixed sets? So for that, we need a visualization. So what I'm going to do right now is I'm going to drag the measure profit up to columns, and I'm going to drag, say, sales to the rows. Then I'm going to go to profit ratio and bring that to the marks card, add color, then okay. Now that we've created a visualization, we can select one or more marks. You can see all these orange and blue marks. we can select one or more of these marks or headers in the view. So basically what I'm going to do is I'm just going to select a couple of these marks, yes, and then I am going to right click on one of these marks and select to create set, which is the last option here. So here I can see my categories and my subcategories. There are 13 members in total. What I'm going to do is I'm going to add to filters shelf to automatically move the set to the filters shelf once it's created, and when finished I can click on OK. Now optionally what I could do is, by default the set includes all the members listed in the dialog box. So basically I can go ahead and select the number of categories or subcategories that I can exclude. So when we exclude, the set will include all the members that I didn't select. You can also remove any dimensions that you don't want to be considered. So if suppose there is art, I don't want it to be considered, I'm going to just remove it. Binders I'm going to remove, and things like that. When you hover over it, you will definitely get this red cross or the remove option. Now also, if the marks that we've selected represent multiple dimensions, each member of the set will be a combination of those dimensions. So you can specify the character that separates the dimension values, and to do that you can do so by separate members by here and enter the character of your choice. Like the example given here is furniture, chairs, which you can also see here. So when you've finished all of this, you can go ahead and click OK. And here you can see only the categories that you had selected. Now what you need to note is that if you created a set using specific data points, you can add more data to or subtract data from the set using the tooltip that appears. All you have to do is click the Sets drop-down icon and select the Add or Remove option. So basically, I hover on top of this spot, and then you see options such as Keep Only, Exclude, and here is the Sets icon. And then you can add to set to or remove from set to. Yes? And after you create a set, you can see it at the bottom of the data pane of the set section like we saw for the previous one. Here, you can drag it into any visualization that you would like in any other field. So after you create a set, you can see it at the bottom of the data pane in the set section right here. And how you basically use it in a visualization is pretty simple. So here I can see the set. I can just drag it into the visualization and see it has worked. Or I can drag it to the filters. Then I can see the bubbles which are included in set 2. And when I remove it from the filters, I can see my original visualization again. If I select in and then keep only, you can only see the ones which are in set 2. And if I select out, which are the ones in square, I can see only the bubbles out of set 2. Basically, what I wanted to show is that when you drag a set to a visualization into Tableau Desktop, you can choose to show the members of the set or aggregate the members into in or out categories. In Tableau Server, one can only aggregate the members of the set into in or out categories. You can use set actions to give your audience more control over their analysis of your visualization, and that is the purpose of sets. With that, let's move on to something known as set actions. Now, what are set actions? Set actions basically take an existing set and update the values contained in that set based on a user's action in the visualization. So basically, as an author, you can use a set or multiple sets that you have already created to define the scope of a set action. You can use set actions to let your audience interact directly with your visualization, even your dashboard. It gives them more control over the aspects of their analysis. Now you can define the set action to include any of these. First, the source sheet or sheets it applies to, the user behavior that runs the action, basically how you hover, select, or menu, the target set, the data source, and the set that has to be used. And finally, what happens when the selection is cleared. Now, these are the 4 things that you can define the set action to include. With that, let's go back to our Tableau desktop to see how to create set actions. Now, to create a set action, first we are going to go to a worksheet, the option here up top, and select actions. For this, we can also use the keyboard shortcut Ctrl Shift and A. Then you'll be met with this dialog box, which is the actions dialog box. Here we are going to go ahead and click add action and then select change set values, which is the last option. Now, what you're going to do is that you're going to specify a meaningful name for the action in the add or edit section. So I'm going to name it set action demo. Now we're going to select a source sheet or a data source. The current sheet is selected by default. So here, sheet 1 is the one which is selected by default. If you can select a data source or a dashboard, you can select individual sheets in it. So I'm going to go and select sample superstore, and the one sheet I've made is the one sheet that has been selected. Then you can select how your users will run the action. You have three options, as I had mentioned before. Hover, the first one, runs when a user hovers the mouse cursor over a mark in the view. Select runs when your user clicks a mark in the view, and this option works well for set actions in my opinion. Finally, you have menu, which runs when a user right-clicks a selected mark in the view and then selects an option on the context menu. So I'm just going to select because, again, as I said, in my opinion, this works well for me. You can go ahead and select hover or menu depending on your choice. And as you keep using sets more and more in Tableau, you will definitely reach a point where you have favorites. Then you have to specify target set. Here by default it is the sample superstore because that is the one that I've selected. Then I'm going to go ahead and select the set. So I'm going to select set 1. Now the sets available in the target set lists are determined by the data source that you select and the sets that you have created in the workbook. Now these are the sets which are associated with that data source. In this example, I'm using set 1, which was the first set that I created. Then you're going to go ahead and specify what happens when the selection is cleared in the view. You can do it by clicking on any of these bubbles on the right. First one is keep set values, which basically makes the current values in the set remain in the set. Then you have add all values to the set, which adds all the possible values to the set. And finally, remove all the values from the set, which removes previously selected values from the set. I'm going to select keep set values and click on OK. This is going to save my changes and return to the view. After this point, you can test your set action by interacting with the visualization. You can tweak some of the settings for the action to adjust the behavior as needed. A few ways in which you can do it is by proportional brushing, asymmetrical drill downs, color scaling, relative dates, so on and so forth. Next, let's move on to how to combine sets. Now, combining sets allows you to answer complex questions and compare cohorts to your data. You can combine two sets to compare the members, and when you combine sets, you basically create a new set containing either the combination of all members, just the members that exist in both, or members that exist in one but not the other. One thing you need to understand is that to combine two sets, they must be based on the same dimension. This means you can combine a set containing top customers with another set containing top customers from last year. But you cannot combine top customers set with a top product set. Is that clear? So let's go back to our demo machine and let's create another set. So I'm going to duplicate this set and then probably edit that set. Now to combine these sets in the data pane under sets, we select the two sets that we want to combine. Now we're going to right click on the sets and select create combined set, which is the fourth option from the top. And now you will be met with this create set dialog box. So we are going to type a name. Let's name it combined set. Here we have verified the two sets, which is basically one duplicated the other. Now basically, since one is a duplicate of the other, no matter what I share, it is going to be the same result. But still, let's select one of the options for how to combine sets. So the first one is all members in both sets, which basically enables the combined set to contain all the members from both the sets. Now by default, that is the one that is selected. Then you have shared members in both sets, which is the intersection of both the sets. So it enables the combined set to only contain members that exist in both the sets. Now, both of these have an accept shared members option, which basically enables the combined set to contain all members from the specified set that don't exist in the other set. These options are equivalent to subtracting one set from the other. So I'm going to take one of these in random. Optionally, you can also specify a character that will separate the members if the sets represent multiple dimensions. Again, this block, and when finished, you can click on OK. And here you can see the combined set in the sets pane. Okay, with that, let's move on to the applications of Tableau Sets. Now, there are many ways in which you can use sets to answer complex questions and compare cohorts of data. A few of these questions of yours I'm going to answer in my presentation. First, how do members of a set contribute to total? Now, you may have all kinds of questions surrounding how the members in a set contribute to the overall total. For example, what percentage of total sales come from repeat customers? You can answer these types of questions by using in or out mode for the set. Next, you can also answer how many members of a set exist in another set. This is another very common use of sets, basically to compare subsets of data of cohorts. If you wonder how many customers that purchased last year also purchased this year, or if a customer purchased a specific product, what other products did they buy? You can answer these types of questions by creating multiple sets and then combining them. You can also use hierarchical set filters to the selected members of all their descendants. Now, they are unique to the multidimensional or cube data sources and are defined within the data source prior to connecting to Tableau Desktop. Now, when you create sets in Tableau from a cube data source, descendants and any hierarchical structures are automatically included within the selected members. Sets are dynamic and useful elements for you to add interactivity and flexibility to your report. It is a versatile weapon in your arsenal and can be used very well in calculations and visualizations.
Why we use actions? Well, by using actions in Tableau, you bring interactivity in your data. Be it a dashboard or a worksheet, users are redirected to specific actions that you set up by merely hovering or clicking in your visualization. So let's take a use case scenario. Suppose we have 4 different worksheets or reports with 4 different visualizations, like sales data, profit data, revenue data, and demographic data. Now, if we want to see the changes in visualization for a particular parameter, suppose a specific state, then how do we do that? Like if you want to look into the sales, profit, revenue data based on one specific region, how would you do that? So without using actions, the first step would be to filter on each visualization, like to put filter on sales data, profit data, revenue data, and demographic data. So that way, when we put filter on sales data, we'll get the highlighted column for that specific region. And similarly for profit, revenue, and demographic data, we have to individually filter out that region and get the data for that specific region. But alternatively, in Tableau, if we can use actions, we can see the changes across all the visualizations for a particular selected parameter, which is region here we are talking about. So once we select a specific state in sales data, it would show us the highlighted data in all the chosen visualizations. So that's basically the purpose of using actions, where we can see the changes in visualization across all worksheets or in the dashboard for a particular selected parameter. Now let us quickly understand what are actions in Tableau by definition. So by definition, a dashboard action is an interactive element on a Tableau dashboard that is driven from the worksheets within that dashboard. So action basically adds contexts and interactivity to your data. Users can interact with your visualizations by selecting marks or hovering or clicking a menu, and the actions you set up can respond with navigation and changes in the view. So to talk about actions, there are different types of actions that we can see in Tableau. But mainly we use the first three to mention, which are filter, highlight, and go to URL. So in filter, what happens is we use the data from one view to filter that data in another view or in the dashboard to guide with the analysis. Next, when we talk about highlight, in highlight we highlight the marks of interest by coloring specific marks and dimming all the other factors. Next, in go to URL, you can create hyperlinks. So hyperlinks will take you to external sources such as web page or a file or another Tableau worksheet per se. So these three are widely used and are helpful in the visualizations. Other than that, we have three more actions, which are go to sheet, change parameter, and change set of values. So in go to sheet, it simplifies the navigation to other workbooks and other dashboards or stories. While in change parameter, it lets the user change the parameter values by directly interacting with marks on a visualization. And lastly, in change set values, it lets users change the values in a set by directly interacting with marks on a visualization. So we will get to learn about a few actions in hands-on. So for that, let us go to Tableau. Here we have imported the global superstore data. So this is how it's going to look. So we are taking month-wise profit, country-wise profit, and category-wise profit, and putting all the worksheets in a dashboard where we'll see the changes reflected according to the selected parameter. So let's start from scratch. We'll repeat the process by making a new worksheet. So let's see how we have made the first few worksheets and then understand how we can incorporate actions in them and then how we can visualize that in a dashboard. So first we will make a worksheet called month-wise profit. So for that we will drag the date, which is the order date here, to columns and select month from here from the drop down. Now since we want to look into the month-wise profit, we'll drag profit in rows. So this is how it looks. Now if you want to change colors, you can drag profit to color. Then by double clicking on colors, you can edit color. And I want to choose green for the profit. And I also want to add legends to profit. So I'll drag profit to label. And here we can see the data for each point. So this is giving us month-wise profit. Now let us make the country-wise profit. For that, let's name the sheet first as country-wise profit. Now what we have to do is drag profit to rows and countries to columns. So this is a plain bar chart, but we want to see it in a map. So I'll select the geo dimension here and we can see it on the map. So which countries have the highest profit, which has loss, which has less profit. We can see it in a map visualization. And if we want the legends, then here also we can add that by dragging profit to label. But this kind of looks a little clumsy, so I'll let it be. Next, let us make a sheet on category-wise profit. Category-wise profit. So here, same again, we drag profit to rows and categories to column. So there are three categories and we can see office technology. Now if you want, you can also add a region to columns. This will give you a region-wise, category-wise profit. So here we can see that for each region how it is showing. So we'll let this be. Now let us make a dashboard. For making a new dashboard, we can click here or we can go to dashboard and make a new dashboard. So now we have these visualization. The first few were already made, so I'll rather choose the ones that we made now. So we have the month-wise profit, we'll have the country-wise profit and the category-wise. So let's enlarge the size of the sheet like this. So we have the month-wise profit, country-wise profit. Now we have to add the category-wise profit. We'll add it here. So this is our dashboard with month-wise profit, category-wise profit and country-wise profit. So we have dragged all the worksheets in here. So we go to worksheet and select actions. There's also a shortcut key which is Ctrl+Shift+A to get actions. Here we will select this workbook since we want to see the reflection on the dashboard and not this sheet specifically. So now we go to add action. We go to filter. Now here we can choose the name of the filter. Let's choose from here. So let's name it market analysis. And for run action, we have selected select. And there's option like hover or menu, but we want to select from the visualization. And here we are choosing, we'll unselect all of them and select the source sheet as month-wise profit. Since these were already done, so it's showing twice. And now in month-wise profit, we will choose dashboard 2. And we want to see all values. So we'll select show all values. Now we'll press OK. So if we select April, this is showing us the April data for category-wise profit, country-wise profit, and even month-wise profit. So all we have to do is just go here and select a specific date or a specific point on the line diagram, and it can just show the change in data across all visualization. So similarly, when we go to country-wise profit and go to worksheet, actions, add action, filter, and here we will choose country-wise profit, select the target sheet as dashboard 2. So we want to see the changes across all visualizations. Now OK. So when we are selecting Russia, this is showing us the data for Russia in all the visualization. Similarly, if we want to create a highlight, now we go to worksheet, go to actions, add action. We want to use highlight. So let's add countries. We want it across all visualization, dashboard 2, country-wise profit, all fields, because we want it across all fields. Now press OK. So here, if we are selecting Russia, it's showing us the highlighted Russia. If we select Oceania, then it's showing us the highlighted Oceania in the visualization. So you can play around with actions using it in different ways across your worksheets. Next, we'll see the go to URL type. So here we go to action, go to URL. Now here they've asked for a hyperlink. So hyperlink is basically any link that can redirect you to a web page or another Tableau sheet or another Excel file or some file. So what we can do is we can add generalized web page link for an example. So let's take country details. Let's name it as country details. Here also let us select run action to be select. And now for the URL target, we are choosing a new browser tab. So for the URL, we'll select a generalized URL, which let us take it as a Wikipedia link. So we will copy this link and paste it here. So this is a generalized link. Now what we need to filter on is country. So from here we insert country. So whenever you're selecting one country, it is going to lead us to a web page of that specific country. So let's see how it's working. Now we press OK. Now let's go to our dashboard and select China. So when we select China, it's leading us to the web page of Wikipedia where we have the details of China. So similarly, you can make your own URL or you can make your own page and give the URL of that specific page or even a Tableau worksheet if you want. So that's about actions that we usually use. There are more actions, but those are not used at a daily level. I think this would help you get an overall idea of how actions work in Tableau.
Let's say you own a company that makes office supplies and your products are sold across different regions. Now you are coming up with some new strategy to boost sales in the regions with the lowest sales. So after framing the strategy, the next step will be to determine the rank of your regions based on sales. Now how will you determine how your regions are performing? Like which region performed the best, or conversely, which one did the worst in terms of sales? So my friends, this is where bump charts come into play. Let's see how a bump chart looks like. So this is our bump chart. So when we hover over the graph, you can see that it is showing us the sales across different regions. Here in this graph, the different colors represent different regions, whereas the y-axis shows us the rank. So let's say for the month of April, the rank 1 went to the West region with 41,000 sales. Similarly, rank 2 went to East, rank 3 went to South, and rank 4 to the Central. So the user who is looking at this graph can see the rank of the different regions based on sales across different years at a single glance. Now before learning how to create a bump chart, let's understand what are bump charts. So bump charts are very much like line charts, but instead of graphing some measure on the y-axis, such as segment or category, they show us the rank. So when a line crosses another line, that is indicative of a rank change. Pretty simple, right? So a bump chart shows us the change in rank over time, and it can easily convey the rank throughout the entire interval of the given time dimension, or some other dimension which is relevant to your analysis. And these types of charts are more useful when comparing data over a period. Now that we have discussed the use case of bump chart, let us quickly see how to create them in Tableau. So to create the bump chart, we'll first drag order date to the column shelf. And from the drop-down menu, select the month. Now I want to plot my regions on the basis of their sales rank. So we'll create a calculated field for this. And name the field rank. And type rank unique sum of sales. Now let's drag this rank pill to the row shelf. You will see that Tableau gives us a single line chart, but we want it across different regions. So we can simply drag region to the colors card. And then from the drop-down menu of the rank pill, select compute using and select region. Now that we have got a bump chart, let's add ranks into it to make it more readable. So to add ranks into it, we'll select the rank pill and duplicate it and rename the duplicated pill to rank display. Then we'll change the data type to string. Now this rank display pill over here will help us in showing the rank in our bump charts. Now copy the rank pill into the row shelf and make it a dual axis graph. Always make sure to synchronize your axis after making a dual axis chart, so that we have got uniform values on both the axes. So now we have got two line charts over here. So we'll go ahead and make one of the chart as a circle chart. Now we will be representing the ranks inside these circles. So let's drag the rank display pill to the labels card of the circle chart. Now let's make this chart more attractive. We can remove the extra header from here, select entire view, and then edit the labels. Let's make them bigger and give them a white color. And make sure to align them in the center. So now that we have placed labels inside a bump chart, we can see that we have got values ranging from 1 to 12. But we only have 4 regions with us, that are Central, East, South, and West. So to make this right, simply go to the drop-down menu of rank display pill and under compute using, select region. So now we have only 4 ranks that are being shown in this chart. But still, my rank 1 is at the bottom of my chart, whereas rank 4 at the top. So to make this correct, simply right-click on the axis, go to Edit Axis, and under the Scale option, select Reversed. So this is how we create a bump chart in Tableau. Now that we have a required visualization in our hands, let's discuss one of the flaws which is present in it. So with this dataset, showing the rank alone can be a bit deceptive. This chart gives you the feeling that the difference between sales across different regions is pretty much the same, since the line width and the distance between them are exactly the same. But this is clearly not the case. Let me show you why. Let's go ahead and hover over the month of July. You can see that the rank 1 sales is $64,000, rank 2 sales is $37,000, and rank 3 sales is $32,000. So the difference between rank 1 and rank 2 is $30,000, whereas rank 2 and rank 3 is only $5,000. But the people who will only look at this visualization will not be able to tell this major difference. So now, one may arrive at a question, when to use bump charts? So there is a very simple answer to it. I think it comes down to your primary objective. Are you more interested in communicating the changing ranks amongst your dimensions, or in showing the actual magnitude of each dimension and how they relate to each other? So if rank is the only thing of importance, then definitely use a bump chart. Nothing better than it. But if the actual and relative magnitudes are more important, then one would be better off with another type of visualization, such as a simple area chart.
So what is a Pareto chart? A Pareto chart is basically a dual axis combination chart in Tableau. On its primary axis, as you can see, bars are used to show basic raw quantities for each dimension, usually sorted in a descending order on a secondary axis. A line graph is then used to show the cumulative total in a running percentage format. Now, while this chart type serves a variety of purposes, it is most known for being a part of the 7 basic tools of quality control. That is where it majorly dominates. It is traditionally used to identify the biggest opportunities for improvement. Now that we know what it does, let's go ahead and see how it does it. So for that, we are going to go straight to our Tableau desktop. I'm going to be sticking with the quality control scenario, and this session will be using the sample superstore which is already available to you on your Tableau desktop. We shall use the dataset to look at which product subcategories contribute the most returned items.
But before we begin, I'm on this page and I have imported the data. But before we begin, first of all, this tutorial requires 2 additional steps to prepare the data. First, we need to left join the returns table to the orders table. So let's go ahead and do that. I'm going to drag the orders table and the returns table as well. Here I'm going to click on this icon and select left join. And then I'm going to go ahead and close it. Next, what we're going to do is we're going to go straight to our sheet, all right, and create a calculated field to count the number of returns, all right. So we're going to go to analysis on the main title bar and select create calculated field. Let's name this returns, which will be true to its purpose. And we're going to use a function known as count. Here we're going to count the returned subcategories. And now it shows us at the bottom that our calculation is valid. So now we are all set to build a Pareto chart. Now you can see that our returns measure is available in the measures pane. We're going to first start by creating a bar chart that looks at the number of returns per product subcategory, and then we are going to sort it in descending order. So I'm going to bring the subcategory to the columns and return to the rows, and then I'm going to sort it in a descending order. Next, what I'm going to do is go ahead and create a dual axis combination chart, which I'm going to do in my rows. For that, I'm going to drag the returns measure again to my rows shelf, bring it over here, and click on the drop down button and select dual axis. I'm also going to go on the left and select bar chart. And for the next, I'm going to change the mark type again from automatic to a line chart. I'm also going to go ahead and change the color to orange so that it is more visible. At this point, your visualization will look something like the one you see on the screen. I'm also going to go and change the color of the bar chart to something deeper for visibility purposes. Okay, yeah, this color looks good. Okay, now the step that makes a Pareto chart is basically adding a table calculation and a secondary table calculation to this returns bill. They shall display the cumulative percentage of returns across products in different subcategories. Now, to do that, first, upon right-clicking on the second pill, we get quick table calculation option, and I'm going to choose running total. At this point, your chart should look something like this. Now, with the table calculation for running total, you can add a second table calculation to the result, and that is how we are going to be calculating the raw running total number for each product subcategory. And then we'll add a secondary calculation to determine the cumulative percent total. Now for addition of a second table, I'm going to go back to the returns bill, go to edit table calculation, and check this box in the bottom which says add secondary calculation. Okay. I'm just going to move it a little bit to the center. Okay. Now this is my secondary calculation type, and here I'm going to switch it from difference from to percentage of total. All right. At this point, if I move this dialog box, your graph should look something like this. This is basically the cumulative percent of total. Okay. Now, after changing the axis tick marks for a cleaner look, you will be left with this following visualization that you see in front of you. It wasn't that difficult, was it? You know for a fact now by hovering over this, you'll get your subcategory, the percentage of total running sum of returns, and the total number of returns per subcategory. So as we can see right now, 17% of all binders come back, which is terrible for a company and will bring a lot of loss for a company dealing with office supplies. Now, this Pareto chart in Tableau can now be used for drawing insights such as the business's 3 most returned product subcategories, causing about 40% of the total returns, which you can see are binders, papers, and phones. Pareto charts are usually a very effective way to quickly highlight potential for improvement and give enterprises a scale for how urgently a quality control problem should be treated.
So what is a donut chart? Now, to understand what a donut chart is, we need to first know about its predecessor, the pie chart. So what is a pie chart? Now, a pie chart is a circular statistical graph or visualization that is divided into slices, basically to illustrate numerical proportion. As you can look at it, it looks pretty much like a pie that's been cut into separate sections, unequally though. Now, in a pie chart, the arc length of each slice is proportional to the quantity it represents. But there's a little bit of a problem. Now, pie charts are often criticized for attracting too much focus of its viewers on the proportion of the areas of the slices. Now, this obviously incites comparison of one slice to another, and then ultimately the comparison of one slice to the chart as a whole. Now, this makes it very tricky to see the differences between slices, especially when you try to compare multiple pie charts together. Now, we need a chart which somehow remedies this problem by de-emphasizing the use of this area. Behold the donut chart. Now, a donut chart somehow remedies this problem, and again it de-emphasizes the use of that area. A donut chart is essentially a pie chart that you saw previously, except for it has a hole in the center, or the central area has been cut out. A donut chart basically invites the readers to focus on reading the length of the arcs rather than comparing the portion sizes between the slices. Also, this chart is more space efficient than a pie chart because you can pretty much use the central hole to fill in with data or information if you like. But what we need to understand about the donut chart, or rather both of these charts, is what brings about this stark difference in performance. In one word, the answer is perception. So let's go ahead and discover what is the difference between a pie chart and a donut chart. To make it easier for you all, I'll switch to my demo machine, which is the Tableau desktop app. If you want to look at a tutorial solely concerning the Tableau desktop app, we have a bunch of them on our playlist and a particular tutorial video if you like. I'd happily link that in the description box below as well. So moving on, you've probably all seen a pie chart before. It's a big circle cut into pieces, can't really miss it. We saw it a few minutes ago in our first section. And a donut chart, as we also just saw, is essentially the same thing except for that it has somewhat a smaller circular cutout in the middle. So it turns this very filled heavy pie into a somewhat hollow donut. But I've decided to make it easier for you all, and here's a side-by-side image of them both. Now, there may seem like a fairly minor difference between the two, but something important happens upon this timbit removal that illuminates the complexities of the human brain and the visual perception. And my main intention of this session is mainly to make you guys understand what goes on in the human brain to perceive these two so differently. So let's go ahead and look at a pie chart first. So this is a pie chart. Now first, when you guys looked at it, notice how you did. Chances are your eyes directly went to the center of this pie chart, at least at first. Now, because pie charts are filled in, you view them as a whole. You see the circle and judge the pieces according to its areas. It's pretty simple. And then there is this donut chart. Now, because donut charts are hollowed out, there is no central point to attract your attention. So where do your eyes go instead? I'd like to leave your answers in the comments. Okay. So if you're like most people, at least I'm like most people, I'm pretty ordinary, your eyes travel around the circumference and judge each piece according to its length. As a result, you can also think that a donut chart is almost like being a stacked bar chart which has been curled around itself. Can't visualize it? Let me help you. Here is a stacked bar chart, which is the corresponding chart to the previous donut chart you just saw. Now can you picturize it? Very well then. So why does it matter whether you read something by area or by length? Well, our brains process these two properties very differently, and we as humans are only good at one of them. So humans are exceptionally good at judging linear distances. Let's take an example. If you want to throw something at a tree in a distance, okay, I don't know why you're doing that. Maybe you're anti-green, but let's just take that example. If you want to throw something at a tree in a distance, the gray matter in your brain, which is the part of your brain which processes information, will run all the calculations to get the right trajectory and fulfill this weird anti-tree vendetta agenda of yours. You can easily tell if something is taller, wider, longer, or shorter. Basically, what I'm trying to say is single dimension comparisons are pretty straightforward. Now, areas to human brains aren't so easy. Unless the difference is blatantly obvious, it may take you a moment to compare objects of different sizes. And if you're anything like me, you'll cheat and use the linear distances anyway. Because what I do is I check the height and width and estimate the rest. So when a reader sees a circle subdivided into sections, they are going to want to compare section sizes anyways. Even if a comparison isn't your goal, and it has got nothing to do with the graph's core message, comparing sizes is sort of like an automated reaction when you see a pie chart. So what is it that the donut chart has to offer? Simplistically, two things: clarity and spatial efficiency. Okay, consider this particular donut chart. Now, pie chart actually offer three separate options. You compare ratio of angles, ratio of areas of each wedge or slice, or at least you can use the length of the outer circumference. Now, the donut chart only offers the last one. Though it gives you both an inner and outer edge to work with, it basically only gives you the length of the outer circumference or the arc to utilize as your record size. Now, this particular complexity of the pie chart is rarely a benefit. A typical audience will contain individuals who will prefer each of the three methods. This makes the distortion of a pie chart far more common than people realize. Now, people who prefer pie chart over donut chart often do so because pie chart offers more stylization. You can make a pie 3D, you can tilt it, you can explode it, you can fill it with interesting patterns or skins. You can even make different shapes out of it. But all of these options will mostly just distort your graph. At least a portion of your audience will not be able to understand it. Now, I'm not saying that a donut chart cannot get distorted. It is just much easier to avoid in the case of a donut chart. So as long as the edge lengths remain fixed, which basically means you're not getting a tilted view of the chart, the graph should remain very true to its data. Now, the second point I had to come to was spatial efficiency. Now, for fans of Edward Tufte, this is a major theme of what he writes. Tufte rails most against wasted ink. Then there's too much white space. But both can be issues. Filling a page with meaningless color creates clutter and slows down comprehension. While white space that is not purposely put there in your graph is equally troubling. Now, the pie chart suffers greatly from the first problem. By definition, there is nothing you can do about it. Any effort to limit that extra ink will only leave you with a donut chart instead. But the donut chart suffers from the latter. So why trade too much ink for too little? The answer is focus. The white space of a donut chart draws the eyes of the audience. As we mentioned before, it is always the center of the circle where you look at first. So use that space. That space is perfect for a total, a lift comparison, or a trend arrow. Honestly, in my opinion, you should be able to cleanly fit all three as I've done in this chart in front of you. Now that we know why you need to use a donut chart, let's move on to our Tableau desktop and see how you can build one. So I'm basically aiming to recreate this particular donut chart, which is based upon the categories of products of the superstore and the number of sales made by each product. Now, as I've just mentioned, I'll be using the sample superstore provided by the Tableau service to be creating this particular graph. So now let's start by opening up a new sheet. As you can see, this is the sheet 25. Now, while there may be many ways to create a donut chart, this method is my favorite because it is more efficient and it is more goof-proof. So let's start with this marks card. This particular card here is known as the marks card. What I'm going to do is I'm going to select pie chart here because again, pie chart is the predecessor of the donut chart. We are going to start out with a pie chart. Then we're going to select the category and bring it to color. As you can see, there's a different color for office supplies, technology, and furniture. And the legend is here on the right. The legend is here on the right. And there are the three colors right here. And I used this card from the marks card to make sure that each category is represented in a different color. You can also go ahead and change the colors if you like, but I'm pretty fine with these as it does not hamper the visibility of any of the categories. Okay, next I'm going to take the sales, the number of sales, and I'm going to put it on two things. First is the size. So basically, the bigger the size of the sector, the more the number of sales. The next thing I'm going to put it on is the label. So now you can see an exact number that is represented by each of these sections. So what I'm going to do is I'm going to make this slightly bigger, a little bigger, and I'm going to bring this to the center for better visibility. Let me just resize it so you guys have a better view. Okay, done. Okay, so now that I have done this, I have already made my pie chart. Now let's start turning it into a donut chart. So I'm going to go to this measures column and pick out number of records. This is basically the total number of records that there is. And from sums, I am going to pick, I'm going to change the measure to minimum. Now I'm going to do that one more time for the inner circumference of my donut chart. So I take this, drag it to rows, and again select minimum. Now as you can see, we have two different pie charts. Let me just reduce. Okay, now it's really big, so let me just reduce the size of these. Yeah, well then. Now what I'm going to do is I'm going to pick this second green pill and I'm going to choose the dual axis option as we are trying to merge both of these into one. And if you look properly into the marks card, you can see that there are two sections for both of these pie charts. Right now they're overlapped on top of each other, but here you can see there is a section called minimum number of records. That is the first one. And then you have minimum number of records in bracket 2, which is the second one. So I'm going to go to this second section and I am going to remove all of these pills from here. And then I'm going to go to size and reduce it. Not very good at this, pardon me. And then I'm going to go to color and select white to match the background. It's at full opacity. And here you have a donut chart. Finally, I'm just going to go up here and I'm going to uncheck this show header option. All right, now you have your donut chart. Now try and understand this. Visualization is perceived more like a science, but visualization is an art. Honestly, this is not an opinion piece of mine. Really, my opinion on pie charts and donut charts shouldn't matter to anyone. Too many reports and visualizations are already built on opinion and subsequently are quite flawed. That is not to say that nobody's opinion or the opinion of the audience is not important. Visualization is an art, and the only limitation to this is your mind. So with that, let's go back to our presentation where we can discuss a few drawbacks that are there in donut charts as well. Now, as I mentioned, donut charts have their drawbacks, of course. Now, while they are easy to read, they're still not the greatest for comparisons within the same graph. And if I might say, they're downright terrible for comparisons with two different graphs. Now here, I was trying to show a daily percentage of something. I can't tell you what for privacy reasons. And it increased after the October break. I thought I'd be all avant-garde and go nuts with these donuts. That was a bad pun, I'm really sorry. And this was a really bad decision. The one thing this monstrosity does do well, though, I have to give it credit, is illustrate how hard it is to compare between donuts. For example, let me pick out a handy spotlight here. Can you tell me, as the audience, if you look closer, which one of the blue segments is larger? Is it 1115 or 1116? These two I'm talking about. Is this larger or is this larger? Well, unless and until you have like a 30 by 20 vision, it is really hard to tell. So what could I have done with this data instead? Well, since I wanted a before and after comparison, I could have easily used a bar graph. This bar graph makes it much easier to see how dramatically the percentages rose after the October break. Of course, the graph here still invites the reader to look at each date individually. So if I add two annotations for the before and after averages to draw the attention to the changing trend, the individual bars can still be a little distracting. If I instead wanted the readers to focus only on the change in averages, I could have just done a simple bar graph. This so easily compares the two numbers, simple yet effective. Now you can see the pre-break average and the post-break average. It isn't flashy, but it gets right to the point. It would have been the most efficient, effective way for me to convey my message. So let's just take this oath to, I don't know, live and learn and cringe at our past faults, I guess. Now to compensate for this deficiency, I usually prefer to use charts like this, which is a single pie or a donut in a complete set, where your audience is only looking at it for a quick visual, for information distribution. But the lone chart will never be able to convey a depth of information that is very actionable or very satisfying. Let me explain to you on Tableau. Now to compensate for this deficiency, I prefer to use these charts in sets. A single pie or a donut chart may be all you need when your audience is only looking for a quick visual distribution. But that as a lone chart will not be able to convey a depth of information that is very actionable or satisfying. A set or a cluster of charts like the one you see in front of you, this is a dashboard with the executive overview profitability in all states of America, basically will help you compare and contrast changes. It effectively adds an additional dimension to your graphic. This could be across time, population, sales, and so on. It'll also allow you better leverage the legend, in which case you will need just one legend, and then you can use this particular graph to cross-highlight other graphs. Now that is a great feature for this particular graph. The color palette will now serve as a connector as well to other graphs. And for the donut, you can exploit multiple central focus points to convey a message or call out important information. And this is where a donut chart looks best. Now, I hate to write off an entire category of graph, but more often than not, donut is a better option than a pie. When a reader sees a circle subdivided into sections, they're going to want to compare section sizes, even if the comparison isn't your goal. If you do want your reader to compare segments, other types of graphs are a much better option. To be honest, you can talk about your stack bar graphs or your donut charts. And if you don't want the comparison, these round charts make the wrong choice anyway. Aside from stylistic reasons, I can't really think of a good reason to use the pie chart instead of a donut chart. Can you now? If you can, let me know in the comments section below. Which one do you prefer, the pie chart or the donut chart, and why?
When we should use waterfall charts. Let us understand that with an example. Let's assume a scenario where the manager wants to see how the company is performing according to the products they are selling and how to increase the profit looking at category-wise data. So this data has been handed over to the analyst, and now she has to analyze and present the data in a way that can be easily comprehended by the manager. So from this bar chart, we cannot understand much. It shows a haphazard presentation which is not easily understandable. We have random bars on subcategories, but there's not much that we can figure out from this visualization. So what we could do next would be to make it more fathomable. We can arrange it in ascending order, from where we can see which category has the highest and lowest profit. But still, this visualization doesn't show the cumulative effect on profit. Now what should we do to understand how each category has affected the total profit? For that, we present it in a waterfall chart. So to start with a waterfall chart, what we need to do to begin with is to add a running total on the profit. So running total calculates the cumulative total of the measure. This way we will get bars for each categories, and each category is the sum of the next. So this is the final bar which shows here in tables is the cumulative of all the previous categories. But this visualization is still confusing. For that, now we change it into waterfall chart, which looks like this. To change it into waterfall chart, we have just changed the mark type from automatic to Gantt bar, and this is how it looks. Here we can see how much each category has contributed to the total profit from the height of each product. Like from this graph, we can see copiers has the highest contribution to profit. But this is still not very clean to look at. For a more pictorial presentation, we can add colors to the visualization. Here we can see the product with loss. So here it is color coded. The ones with the dark blue have the highest profit, while the ones which are orange have negative values. So from this graph, we can see tables having negative profit, while copiers having the highest profit. So this is how our waterfall chart is going to look at. Now if I present this data to my manager, he can understand which product is doing good and which product is not, and from where we are getting the maximum profit and from where we are getting negative or least profit. So from this data, we can provide an insight to the manager where we can say that if we increase the sales of copiers, then we'll have more profit, and the sales of tables is causing us negative profit, so we should do something about that by reducing the cost of tables or by increasing the price of tables. So in short, waterfall charts can help you get a clearer picture of the dataset and can help you easily apprehend where to put more focus on. So now let us look into the definition of waterfall charts. So what do you understand by the definition of waterfall charts? Waterfall charts is basically a type of data visualization where we can see the cumulative or total effect of transitional data, where we have additions and subtractions from the starting value. These intermediate values can be categorical or time-based. And waterfall charts, how it gets its name is very evident from the way it appears, which is like a waterfall, and it can be used in analytical purposes for understanding the gradual transition in the value. So without any further delay, let's get into the hands-on, where we will explain this example only in Tableau. So we will export the global superstore data which we had been working on. Now we'll go to the worksheet. So in this example, we will look into the profit across the categorical variables. Let's start with naming the sheet as categorical profit. So now here we will see the profit across subcategories, which are the product categories. So for that, first we need to drag the subcategories to columns. here subcategories to columns. Then we will drag profit to rows. So this is the visualization that we were getting. It's a simple bar chart, which is haphazard. But for making it into a waterfall chart, the first thing we need to do is get the running total of the profit. So for that, we click on this drop down arrow on profit and we go to quick table calculation and select running total. So now it looks like this. Here we have starting from accessories to tables arranged in an alphabetical manner. So accessories has a contribution of almost 1.3 lakhs. So for appliances, it will have the contribution of accessories plus the contribution of appliances. So at the end, we can see the tables column will have the grand total of all the contribution of each categories. But this doesn't look like a waterfall chart. And this visualization doesn't get us any insight. So for understanding our data better, we will turn it into a waterfall chart. So for that, what we need to do now is to drag profit to size. So now what we need to do is change the mark type from automatic to Gantt bar. So this is how Gantt bars are looking. But now the Gantt bars, to have the right size, we have to drag the profit to size. Now this is showing us the correct size of each subcategories. But for our waterfall visualization, the blocks has to pick up from where the last one left off. So now this makes the size of each Gantt according to the profit share. But these blocks are of right size now, but they begin at the location of each Gantt mark and go up in direction because the profit values are positive. So to have each block pick up where the last one left off, we must reverse the values to negatives so that we get a waterfall-like chart. So the easiest way to do this is to double click the profit pill that's on the size marks card and type a negative sign before the sum of profit and hit enter. So here you can see the next block picks up right where the previous one has left, and this gives us a waterfall-like view. So now for an illustrated visualization, we can add colors to it. For that, what we need to do is drag the profit measure to colors. So here we can see the color coding that the categories with negative profit are given in orange, while the darker the blue is, the higher the profit is for the category. So from this visualization, we can understand that copiers have the highest profit, and next it is phones. Thereafter we have bookcases. So this is a waterfall-like chart where each block gives the profit of each category. And the height of the last one shows the total profit generated by all the subcategories. So in this visualization, we can add labels as well. If we drag profit to label, where we can see the individual category-wise contribution. Now we can even add more features to this visualization like date filters. So in our example, order date tells us which day the order has been placed. So if we drag the order date to filters, and if we want to see year-wise order, we select years, we select all, and OK. So the year filter has been added, but now we need the filter to be added on the right panel. For that, we'll click on the drop down, we'll go to show filter. Here we can see the filters. So we'll unselect all and we'll see year-wise. So in 2011, we can see that phones had the maximum profit while tables were at a loss. And the second most profitable category was copiers. Next, in 2012, we can see that copiers grew more than phones and tables were still at a loss. Now, if you look at the 2013 data, copiers are still having more profit while phones aren't doing that great anymore, but tables are still at a loss. And finally, in 2014, we can see that copiers are the highest profitable product while tables are the lowest profitable. Rather, we are at a loss because of tables, which we can see from the height of the last bar. So once we present this data to our manager, we can show them that which product is doing how in which year and where should we put more focus on to increase our profitability over the years. So this was an overall idea of how you can use waterfall charts to present your profit or sales data to your manager and get an insight at a micro level. So you can even check day-wise data. So this was a categorical visualization. So now if you want to check the day-wise data or the time series analysis of the same data, we can drag the order date to columns and remove the subcategories. So if we select this drop down, we can change it to month, Here we can see that month on month profit. Similarly, we can also see day-wise profit. Now, if you want to check it for just 1 year, and for filters, we can add monthly filters. We'll add this to the right panel. For that, we'll select show filter. So now we can select year and the month we want to look into. So let's begin with 2011 January. So here we can see an overall profit. So now from here we can also know which category has done how much profit on the same day, and accordingly understand how the overall profit has been affected over the time. So waterfall chart is not something that you can use for a specific data. You can use it for a various range of data where you want to have a visualization like this, where you can highlight and understand which category or on which date which product is bringing how much business. And you can play around with your data using filters and slicers and different measures. So like here we have used profit. You can also take sales and check how much sales are affected and make a comparison between profit and sales. So you can do a lot of things using waterfall charts, and I think this is something that is going to be useful in your day-to-day analysis using Tableau. So this was all about waterfall charts in today's video. And with that, we come to an end to this video. I hope you have understood what waterfall charts are and how you can use it in your data analysis and visualization.
Now, there are a few questions which always arise while dealing with data that has been aggregated to intricate levels of details. And these questions are often simple to ask but really hard to answer. They sound something like, can I plot the number of days per quarter where my company had more than 100 orders? How can I find the biggest deal each salesperson has ever closed, then show the averages by manager? How can I tag every customer by the year he or she first became a customer and then use that tag to group the sales? In order to address these types of questions, Tableau 9.0 onwards introduced a new syntax called the level of detail. Now, this new syntax both simplifies and extends Tableau's calculation language by making it possible to address level of detail questions directly. So in simple terms, level of detail expressions represent an elegant and powerful way to answer questions involving multiple levels of granularity in a single visualization. Now, granularity and aggregations in LOD are inversely proportional to each other. How it works is, the more the level of granularity, the less is the level of aggregation, and vice versa. So here are the shelves which affect your LOD aggregates. You have your columns, rows, pretty much everything except for your pages and filter shelf. And these are the shelves which do not affect your LOD aggregates. These are your pages, filters, and tooltip. Now all these LOD expressions are segregated into three types. We have include, which basically calculates at a lower level of detail. We have fixed LOD expressions, which specify the exact level of detail. And we have the exclude level of detail expressions, which calculate at a higher level of detail. So first, let's talk a little bit about how you work a problem in level of detail. Now this map shows the restaurant inspection data from Yelp in the greater Edinburgh area. So the data in the view is aggregated based on the LOD, which in this case consists of city and state, and is more aggregated than the underlying data source. So the selected point in the image show the average user fans for all the restaurants in Newbridge, Edinburgh. Adding more granular dimensions to the view will result in a less aggregated LOD. For instance, we could add business ID to the visualization by dropping it on the detail shelf to see the average user fans for each individual business. By doing so, we'll also change the visualization. Every single business will appear as a circle on the map. But what if we don't want the visualization to change? What if we want to determine the total user fans for each business ID and average those values for each city and finally show only one circle per city? What we want to see is the average number of fans per restaurant in each city. Now this will require adding an additional dimension to the view without dragging that dimension into the visualization. A level of detail expression will allow us to do this. Now this expression tells Tableau to perform the aggregation for each business ID, regardless of other dimensions used in the LOD. You can use this expression to calculate the total user fans per business ID after dragging this new field into the view. We can then average those values per city. Now the fans per business field have been added to the color shelf, as you can see on your left. Now Newbridge has the highest average fans per business with 185 fans, a value that was computed using the fixed LOD expression. By using the fixed operator in our LOD expression, we gain insight into which cities have on average more fans per business ID, meaning those cities with a darker shade of blue have more popular restaurants, or maybe even the city could have more residents, and hence more total fans per restaurant. Now what you see up top is how the level of detail expression is structured. You have your scoping keyword, and then you have the dimension declaration, and finally the aggregate expression. So your scoping keyword as in your include, exclude or fixed, your dimension declaration, in this case your business ID, and your aggregate expression is what you want to do with that declaration. Like here, you are going to use some expression. Here is the structure given more clearly for the level of detail expression. Now, as a result of that, fans per business field have been added to the color shelf, and it shows that Newbridge has the highest, as computed using an LOD expression, average fans per business with 185 fans. Now let's talk a little bit about the include calculation. So the include LOD expression will add dimension to the LOD. The include keyword creates an expression that is less aggregated, which also means it is more granular than the LOD. The specified dimension are first added to the LOD before the calculations are performed. Now, notice that the include expression is used in the view as an aggregated measure. In fact, all include expressions are either used as measures or aggregated measures when placed on the view. Let's talk a little bit about the exclude calculation now. Exclude calculation basically means calculating at a higher level of detail. Using an exclude keyword will exclude the desired dimensions from the calculation. Tableau first removes the excluded dimension from the LOD and then performs the calculation as if the dimension was not present at all. The result is then displayed visually. The graphical representation of how Tableau performs an exclude LOD expression is depicted in the diagram that you can see. Next, let's talk about the fixed calculation. Now, LOD expressions also open the door to creating an aggregation level completely independent of the LOD, something that was previously only possible by the custom structured query language. Presenting to you, we have the fixed calculation, which basically specifies the exact level of detail. This LOD expression will fix the level of detail to each dimension and does the aggregation specified in the calculated field regardless of any dimension in the view. If you look at the sequence of filters in Tableau, fixed calculations are applied before dimension filters. So unless you promote the fields on your filter shelf to improve view performance with context filters, they will be ignored. Include and exclude level of detail expressions are considered after dimension filters. So if you want filters to apply to your fixed level of detail expression, but don't want to use context filters, consider rewriting them as include or exclude. Now let's go ahead and look at aggregations and level of detail. Now the level of detail of the view determines the number of marks in your view. So when you add a level of detail expression to the view, Tableau must reconcile two levels of detail, the one in the view and the one in your expression. The behavior of a level of detail expression in the view varies depending on whether the expression's level of detail is coarser, finer, or on the same level as the level of detail in the view. So what do we mean by coarser or finer in this case? So if I said the level of detail expression is coarser than the view level of detail, I mean that it references a subset of the dimensions of the view. For example, for a view that contained the dimensions category and segment, you could create a level of detail that uses only one of these dimensions. So when I use this expression here, the expression has a coarser level of detail than the view. It bases its values on one dimension, that is segment, whereas the view is basing its view on two dimensions, segment and category. The result is that using the level of detail expression in the view causes certain values to be replicated. That is, they will appear multiple times. Now, if I say the level of detail expression is finer than the view level of detail, it references a superset of dimensions in the view. When you use such an expression in the view, Tableau will aggregate results up to the view level. For example, the following level of detail expression references 2 dimensions. When this expression is used in a view that has only segment as its level of detail, the values must be aggregated. Here is what you would see if you dragged the expression to a shelf. An aggregation in this case, average, is automatically assigned by Tableau, but you can always change the aggregation if you need it. Now, adding an LOD expression to the view. Whether a level of detail expression is aggregated or replicated in the view is determined by the expression type, which is fixed, include or exclude, and whether the expression's granularity is coarser or finer than the views. Now, for include, the LOD will have either the same level of detail as the view or a finer level of detail than the view. Therefore, values will never be replicated. For fixed level of detail, expressions can have a finer level of detail than the view, a coarser level of detail, or the same level. The need to aggregate the results of a fixed level of detail depends on what dimensions are in the view. And finally, for exclude level of detail expressions, replicated values will always appear in the view as we had discussed before. When calculations include the exclude level of detail, Tableau defaults to the ATTR aggregation to indicate that the expression is not actually being aggregated and that changing the aggregation will have no effect on the view. Now let's discuss a little nesting in the level of detail. Now Tableau does not limit you to write single simple expressions. You can nest as many expressions as you want according to your requirements. So when you approach this kind of a problem, you'll have to understand a few rules that come with this inheritance property. So there are 2 types of inheritance in table calculation. One is the impact of fixed expression, which we had earlier mentioned, has impacts on where it is evaluated and which filters affect it. And then there is the dimensionality itself. So in this case, if you look at the first one, I am doing a fixed state and nested calculation. I'm saying include customer, so include, as you all know, inherits from its surroundings. If you build the dragging and dropping by itself, it will inherit from the parent calculation, so it will include the state. It will do the same things as writing state customer instead of it, and it won't be impacted by filters because the parent is a fixed calculation. With that, let's move on to the data sources that are supported by level of detail. So here I've made a list on data sources and whether they are supported or not supported by level of detail. Now let's move on to a hands-on of how to create level of detail expressions in Tableau. Now the question is how to create these LOD expressions. For that, we'll have to move on to our Tableau desktop. So let's head there. Now for your LOD expression, first up prerequisite is that you need to have a visualization already set up. I've created a very simple bar chart over here with regions from the dimensions data pane in the columns and sales in the rows shelf. Now step 2, instead of sum of all sales per region, which is given by Tableau by default, this one right here, perhaps you would also want to see the average sales per customer for each region. For this, you can use an LOD expression. So I'm going to go to analysis and create a calculated field. In this calculation editor that opens, I'm going to name this sales per customer. And then I'm going to put in this expression. So include customer name. And then I'm going to apply it to my visualization and click OK. So the newly created LOD expression is added to the data pane. As you can see, it's right here. Sales per customer under the measures pane. Now we are going to use this LOD expression in the visualization. So from the data pane under measures, I'm going to drag this sales per customer to the rows shelf and place it to the left of sum of sales. See right here. On the same row shelf, I'm going to right click on sales per customer and select the measure sum and then take the average. You can now see both the sum of all sales and the average sales per customer for each region. For example, you can see in the central region that the sales totaled approximately $500,000 with an average sale for each customer being approximately $800 US. Now this was all about the include expression. We're going to do the same for exclude and fixed. Now for exclude expression, we're basically going to try and exclude region from a calculation of sum of sales. And to illustrate how this expression might be useful, first consider the view that you see on your screens right now, which breaks out the sum of sales by region and by month. So I'm going to be creating this expression the same way I did before. You see a new measure being created here called exclude region. Now we're going to drop exclude region, this measure that I just showed you, on color shades, which is right here. We're basically showing the total sales by month, but without the regional component. I'm going to change the colors a little bit so it's more prominent. So let's go with this orange and blue divergent color. All right. So this is how the exclude expression is created. Now let's move on to the fixed expression, which is another sheet. Now, as I had mentioned before, a fixed level of detail expression computes a value using specified dimensions without reference to the dimensions in the view. So the fixed LOD expression I'm going to use now computes the sum of sales per region. So we're going to do the same thing, which is go to analysis and create a calculated field. As you can see, this measure has been created here. So what I'm going to do right now is I'm going to take this measure and place it on the text to show the total sales per region. So the view level of detail is region plus state. But because fixed level of detail expressions do not consider the view level of detail, the calculation only uses the dimension that is referenced, which in this case is region. Because of this, you can see that the values for individual states in each region are identical. With that, let's switch back to our presentation. This is a very common question of how the level of detail compares to the table calculation. And now that we have level of detail, do we actually need table calculations? The answer is yes, you will still be needing table calculations, but the LOD is here to take care of a lot more of the things. Now, first of all, table calculations are generated by query results, whereas the LOD expressions are generated as a part of query to underlying data source. The table calculations can produce results either equal to or less granular than said LOD. Dimensions that control the operations of a table are separate from calculation syntax in table calculations, whereas in LOD expressions, dimensions that control the operations of an LOD expression are embedded in the expression itself. Another big difference is table calculation can be used as aggregated measures, and LOD expressions can be doubled for various other constructs. The filters on the table calculation act as a hide, whereas filters on the LOD act as an exclude. And finally, let's discuss the limitations of level of detail. Now, there are a few limitations and constraints that apply for the level of detail expressions. Now, level of detail expressions that reference floating point measures can behave unreliably when used in a view that requires comparison of the values in the expression. The LOD expressions are not shown on the data source page. While referencing a parameter in a dimensionality declaration, we cannot use parameter values. We have to always use the parameter name. So if you do not know the parameter name, then you're going to face a problem with dimensionality declaration. And finally, with data blending, the linking field from the primary data source must be in view before you can use a level of detail expression from the secondary data source. In addition, some data sources have complexity limits, and Tableau will not disable calculations for these databases. But query errors are a possibility if calculations become too complex. With that being said, LOD expressions are a powerful new capability of Tableau which allow us to easily solve problems that previously required very complicated formulae. They allow us to intuitively define the scope of calculations and stay in the state of flow as we explore our data. They are not a new form of table calculations, even if they can replace many of them, but they do open doors to new possibilities. Contrary to popular belief, LODs and table calculations operate very differently from each other. And finally, I'd like to say that LOD expressions represent a vital step towards the goal of complete flow, where all questions are simple and elegant to answer. So what is the objective of data blending in Tableau? Why do we need data blending? Now let's suppose you have transactional data stored in Salesforce and quota data stored in an Excel workbook. The data you want to combine is stored in different databases, and the granularity of the data captured in each table is different. So in such a case, you use data blending. Now data blending could be very useful under a few conditions. Like you want to combine data from different databases that are not supported by cross-database joins. Now, cross-database joins do not support connections to cubes. Take Oracle Essbase for instance, or some extract-only connections. Take Google Analytics as your example. In this case, set up individual data sources for the data you want to analyze, and then use data blending to combine the data sources on a single sheet. Next is when you have data at different levels of detail. Now sometimes one data set captures data using greater or lesser granularity than the other data set. For example, suppose you are analyzing transactional data and quota data. Now your transactional data might capture all transactions. However, quota data might aggregate transactions at a quarter level. Because the transactional values are captured at a different level of detail, in each data set, you should use data blending to combine data. Now, third case is when you have a lot of data. Typically, joins are recommended for combining data from the same database. So join is basically another method of data merging in Tableau. We shall discuss it in depth in the later parts of this module. Now, joins are handled by the database, which allows joins to leverage some of the database's native capabilities. However, if you're working with large sets, joins can put a strain on the database and significantly affect performance. In such a case, data blending might be of great use to you because Tableau handles combining the data after the data is aggregated. There is less data to combine. When there is less data to combine, generally performance improves. And finally, you can use data blending when your data needs some cleaning. If your tables do not match up with each other correctly after join, set up data sources for each table. Make any necessary customizations, which basically will include renaming columns, changing column data types, creating groups, and so on and so forth. Then you can use data blending to combine the data. Now that we know when to use data blending, let's find out what data blending actually means. So data blending is a method to combine data that supplements a table of data from one data source to another data source. For people who use SQL, it is basically an advanced version of your left join. Now, what is a join and how is it different from blending data in Tableau? Now, data blending simulates a traditional left join, which I had mentioned a few seconds ago. The main difference between the two is when the join is performed with respect to aggregation. Now, when you use a left join to combine data, a query is sent to the database where the join is performed. Using a left join returns all rows from the left table and any rows from the right table that has a corresponding row match in the left table. The results are then sent to Tableau to be aggregated. For example, suppose you have the following tables. If the common columns are user ID, a left join takes all the data from the left table as well as all the data from the right table because each row now has a corresponding row to match. Now, how is it different from data blending? Now, when you use data blending to combine data, a query is sent to the database for each data source that you're using. The results of these queries, including the aggregated data, are sent back to and combined by Tableau. Now, take for instance, you have the following tables. Again, the same tables. If the linking fields again are user ID on each table, blending your data takes all the data from the left table and supplements the left table with the data from the right table. The view uses all the rows from the primary data source, the left table, and the aggregated rows from the secondary data source, and it is done based on the dimension of the linking fields. If there are multiple values for rows, an asterisk is shown. Measure values are aggregated based on how the field is aggregated in the view. In this case, not all values can be a part of the resulting table for two reasons. First, a row in the left table does not have a corresponding row match in the right table as indicated by the null value. And second, there are multiple values in the rows in the right table as indicated by the asterisk or the star sign. Now, suppose you have the same tables as before, but the secondary data source contains called finds. Again, if the linking fields are user ID, blending your data takes all the data from the left table and supplements the data from the right table. In this case, you see the same null value and asterisk previous example in addition to two things. Now, because the finds field is a measure, you see the row values for the finds field aggregated before the data in the right table is combined. As for the previous example, a row in the left table does not have a corresponding row for the finds. It is indicated by the second null value. Now, how can you blend your data? You can use data blending when you have data in separate data sources that you want to analyze together on a single sheet. Example I'm going to show you now demonstrates how to blend your data from two different sources. Now, for this, I'll be moving on to my Tableau desktop. And here I'm going to be using two data sources named the sample superstore, which is already included in the sample data sets of Tableau, sample coffee chain, which is another very easily available data set for Tableau Online. So first, I have already loaded the sample coffee chain. Now, here is its metadata. We see profit, margins, sales, COGS, total expenses, marketing, inventory, budget profit, margin, budget sales, etc., etc. And this is all in an MS Access database file. Here you can see all the various tables and joins that are there in this query right here. Next step is adding a secondary data source. So what we're going to do is we're going to add a secondary data source named sample superstore by again following the steps. It's pretty simple actually. All you have to do is click on this add button and you will find the data set right there. You can search for the data set here and that's it. Here we have both of our data sets. Now blending your data. These are both our metadatas. We're going to go to our sheet. Now what we can do is we can integrate the data from both of the sources based on a common dimension. So when I select this, go to state. So what I'm going to do, I'm going to select the sample superstore, go to the profit ratio, put it in my columns. Then I'm going to rows. I'm going to be selecting state, putting it in the rows shelf. Then I'm going to select this chart. Let's try the Gantt bar. Nope, automatic it is. Now, if I go to my coffee chain query and if I look at my state dimension, what do I see here? This is a small chain-like image that is appearing near the state dimension. This basically indicates that the common dimension between the two data sources is something called the state. If I open my other data source as well, which is the sample superstore, this is my common dimension. And the chart here basically shows how the profit ratio varies from each state in both the superstore and the coffee chain shops. And that was it for our Tableau desktop. Let me go back to my presentation where we can go ahead. Now, limitations of data blending. Now, what are the constraints that apply to this method? First of all, blending with non-additive aggregates. Now, there are some blending limitations around the non-additive aggregates, such as your count D, median, and raw SQL aggregate. When you blend on a field with a high level of granularity, suppose date instead of year, let's say, queries can be slowed down. So basically the speed of the query gets compromised. Null values appear after blending the data sources. Now null values can sometimes appear in place of the data you want in the view when you're using data blending. And this happens because of a few reasons. It can be so that the second data source does not contain values corresponding to the primary data source, or the data types of the fields you are blending are on different levels of detail, or the value in the primary and secondary data sources use different casing. It can be anything, but the null values sometimes after data blending appear in place of the data you want to view. And finally, sorting by fields is unavailable for data blended measures. But despite that, data blending is a whole new approach to merging of your data. It saves more time, makes your system way more efficient, and optimizes the data cycle as a whole.
So what exactly is TabPy? TabPy is an analytics extension from Tableau, which basically enables you as a user to execute Python scripts and saved functions using Tableau. So essentially, using TabPy, you can run Python scripts on the fly and display the results as a visualization on Tableau. Users can control data being sent to TabPy by interacting in their own Tableau worksheet or dashboard or stories using various different parameters. So basically, you get the functionality of Python with the ease of Tableau. So when you use TabPy, you can define calculated fields in Python. Thereby, you can leverage the power of a large number of machine learning libraries straight from your visualization platform. This Python integration in Tableau enables extremely powerful scenarios. For example, it takes only a few lines of Python code to get the sentiment scores for reviews of products sold at an online retailer. Then you can explore the results in many ways using Tableau. There are other common business scenarios as well, such as lead scoring, which basically means that you create a more efficient conversion funnel by scoring your users' behavior with a predictive model. You can also churn prediction to learn when and why your users are leaving your platform, and you can predict and prevent it from happening. Now, TabPy uses the popular Anaconda environment, which comes pre-installed and ready to use with many pipes including SciPy, NumPy, and scikit-learn. But you can install and use any Python library in your scripts. If you have a team of data scientists developing custom models in your company, TabPy can also facilitate sharing those models with others who want to leverage them inside Tableau via the publish model. And once published, all it takes to run a machine learning model is a single line of Python code in Tableau, regardless of the model type or complexity. You can estimate the probability of customer churn using logistic progression, multi-layer perception neural network, or gradient boosted trees just as easily by simply passing new data to your already available model. Using TabPy, complex functions become easier to maintain, share, and reuse as deployed methods in the predictive service environment. You can improve and update the model and code behind the endpoint while the calculated field keeps on working without any change. And a dashboard author does not need to know or worry about the complexities of the model behind the endpoint. So together, Tableau and Python enable many more advanced analytics scenarios, making your dashboards even more impactful. But why exactly do you need TabPy? What problems does it solve, and how does it make our lives easier? Now, as I had previously mentioned, TabPy makes it possible to use Python scripts in Tableau calculated fields. So basically what you're doing is you're pairing Python's machine learning capabilities with the power of Tableau's strong data visualization. You can rapidly develop analytics applications that can aid various business tasks. So let me show you what I mean using an example. Now, this is a pretty interesting one, which I found off of Tableau's official website. So let us say that I'm trying to identify a criminal hotspot or multiple criminal hotspots in a certain city. So here we are going to be using a data from the city's police department, which consists of calls over 6 years reporting various types of criminal activities. Now, if you look at this data, it's really hard to visualize and identify patterns by just looking at all of these numbers and boxes. The density of activity and noise in GPS readings included make your job even tougher. But there is something known as density-based spatial clustering of applications with noise, or dbScan, which is a well-suited unsupervised machine learning algorithm for this sort of a job. And the great part is, it is also installed very conveniently by default as a part of TabPy. So this is how it works. It takes in two parameters. One, to specify the maximum allowed distance between points for them to be considered a part of the same cluster. So anything beyond those points is not a part of the same cluster. And the second one, to specify the minimum number of nearby points to constitute a cluster. So basically, to be qualified as a cluster, you need a minimum threshold of points. As simple as that. Minimum number of points and maximum distance between the points, right? Now, once that's done, it allows for experimenting within various different values and event frequencies and puts on different labels on different areas. Now, this data can be applied anywhere. For a police department looking for criminal hotspots, where they know which areas should they be sending more patrol vehicles to a tourist looking for places to avoid from getting mugged when they're traveling to this particular city. Also, if you are a tenant or you're looking for a house to buy, you know which areas specifically to avoid when speaking to your broker. This is a great example where embedding the Python code into Tableau worked great for us. Now let's move on and install TabPy. For the sake of simplicity, I will default to using Anaconda. Also, for you guys following the tutorial, please make sure you have the latest version of Python installed. And if you're not using the latest version of Python as yet, it's time you update. So this is my Anaconda navigator, and I'm going to launch the command prompt. All right. So the first step is to create a virtual environment. Now, this way it will be way easier to track what versions or packages you have installed if they are all in one place. We've already opened the Conda command prompt, preferably as an admin or a base user. So I'm just going to type Conda create virtual environment. Now you can go to your desired path and type this particular command, virtual env, or whatever you feel like calling your virtual environment. Now this will take barely a couple of seconds. And now what we're going to do is we're going to install and upgrade pip. So again, Python install, pip install, upgrade. Okay. Upgrade pip. Now this will also take a couple of seconds. As you can see, it's trying to uninstall my current installation of pip, and it is trying to upgrade it to a newer version. So now it has successfully uninstalled version 20.0.2 and finally successfully installed 20.3.3. Now once pip is installed, we can easily install TabPy. Now the latest updates to TabPy makes this incredibly easy to do. Without the need to clone the repository and go into the setup folder, all that jazz is not required anymore. So we can just go ahead and type pip install TabPy. Now this should only take a few seconds to complete. Again, see, this is the advantage of running this on a virtual environment. If I would have tried it on a CMD on my current environment, it would have taken ages to download this much. Okay, so now you have TabPy. Great. So to run the TabPy server, all you have to do is simply type TabPy. Okay. So now at this point, it'll be a good idea to go to your browser and type http localhost and enter port number 9004, because that is where TabPy usually runs. Alright, you should see a page like so. It's not very fancy. So the next step would be to go into Tableau. So we're going to open our Tableau desktop, go to Help, Settings and Performance, and click on Manage Analytics Extension Connection. So now if you're using an older version of Tableau, you might see this as an option called Manage External Service Connections. Yeah, a dialog box or a window like this should appear for you. So under the Select an Analytics extension, you should have TabPy/external API. On server, use localhost, and port is 9004 as we just saw. This is the default port for TabPy. Now we have to click on Test Connection to test out our connection, and you should get a message saying Successful Connection Established. Click on OK and you are connected to the TabPy server via Tableau. So congratulations! Now our Tableau is already connected with TabPy and now it's good to go. Alright, so first things first, there are two ways in which we can use a Python calculation in Tableau. The first one is to write code directly as Tableau calculated fields. The code then will be immediately executed on the fly in the TabPy server. And the second one is to deploy a function into the TabPy server that can be reachable as a REST API endpoint. In this article, we will talk about how to do the former, in which we will write code directly as Tableau calculated fields. So since this is our first, we are going to be performing a simple clustering to an Airbnb dataset that is publicly available through the Tableau website. What we are going to do is that we are going to cluster each zip code based on their housing characteristics using several popular clustering algorithms. So the first step would be to import our dataset to Tableau. Let's open a workbook. As you can see, we have 1, 2, 3, 4. Now understand that our main motive here is to learn how TabPy works and not exactly create the best machine learning model. Hence, we are not going to focus on creating the best possible model. We'll only use some variables in the dataset to perform clustering. Our first variable is the median number of beds in each zip code. The second is the average price of each zip code. And finally, the median number of ratings in each zip code. So I'm going to go on to my first sheet, and we need to create control parameters here. We need to create two parameters that we're going to use to select our clustering method and number of clusters, which are cluster numbers and clustering algorithm. So I'm going to select this drop down and click on create parameter. Name the first one cluster numbers. Data type will be integer, current value is 1, automatic. And for allowable values, I'm going to select a range. Minimum is going to be 1, maximum is going to be 10, and then step size is 1. You can change it according to your requirements. I'm just going to keep the range of values less because this is a very rudimentary design. The second one, I'm going to create another parameter, and as I had mentioned, I'm going to call this the clustering algorithm. Again, clustering algorithm, data type is integer. Under current value, I'm going to write k-means. And I'm going to use list as allowable values. So again, I'm going to go create a parameter, name this clustering algorithm.
And now I'm going to go ahead and list k-means, add 2. And we're going to add another one called affinity propagation. Okay, and these are your two parameters. Next, what we're going to do is we are going to create a script. Same way, we're going to go to this drop down and we're going to create a Python script as a calculated field in Tableau. So we're going to click on create calculated field. And in that particular calculated field, you can insert this piece of code. I'm just going to open this up so you can see the full code. Now, understand, that this code is wrapped up in script_real, which is our function from Tableau. And step by step, this is what it is doing. First, it's going to import the required Python libraries right here. Then scaling features with the standard scaler. Then it's going to combine the scaled features and it'll handle null values. Let me just bring this down. Under modeling, we have conditions to check which algorithm to use. Okay, we have k-means, mini-batch k-means, and affinity propagation. And then this model is going to return our result as a list, which has average price, median of review scores or ratings, and the median of beds, cluster numbers, and algorithm. And in the end, it's going to return the clustering results as a list. You have average and both the medians. Then we will convert the results into string data type and make it as categorical data. So that's that. One more thing to notice is that we need to do the table calculation in zip code or pin code. So we need to change the default table calculation to zip code to make sure that the code works. So we're going to click on default table calculation and select zip code and click on OK. So finally, now it's time to visualize our results. I'm going to use a zip code to create a map and visualize the clustering results. So our longitude and latitude go there. All right, you've been successfully integrating Python and Tableau. And this integration is a beginning step for way more advanced calculations to use TabPy.
Now the problem statement is as goes. It is the January of 2016 and the CEO of Superstore is looking to bolster business for the upcoming year. The finance team has noticed that there were profit problems for some inventory categories during 2015. So here is what you're tasked to do. First, you've been tasked with figuring out which item or items have had profit problems multiple years in a row, both the net and year over year, where the problems are happening and why. Second, you also need to visualize this data so that multiple teams, including leadership, sales, finance, marketing, and manufacturers, can view the results and understand the data quickly. So here's what you must do. You need to connect and analyze Superstore's data from the year 2012 to 15. You need to create a variety of views to explore the data while calling out insights along the way. You're going to then analyze the business profits and discover where and why profit loss is happening. And finally, you're going to summarize the data on a visual dashboard to submit to the company. Now, through this exercise, what you should hope to learn is 1. How to connect data using the Web Data Connector, how to analyze your data, how to visualize your data, to join tables in Tableau and run table calculations, to use highlighters, to use filters, formatting, hierarchy, aggregations, and geocoding, through which you are going to be creating various visuals using Tableau, general data analytical skills through dashboarding and publishing as well. Now for that, I'm going to move to my demo machine. So here's our demo machine. Here is my workbook open. I'll be using the public version of Tableau as it is the free version, and I'd encourage all of you to do the same because you might get all the theory in the world, but you would not learn how to use the service if you do not use the service. And a great starting point is to use the free version of Tableau, so you know what you're getting into before investing into this option. So first of all, let's start by connecting to our data. I have already made a file where I have saved the Superstore, the 2 different files from the Superstore. You can also connect to the Superstore. You can just go to connect to data, and here in save data sources, automatically you have these 2 data sources, which are sample Superstore and world indicators. But there is a reason why I have downloaded the file, which you will see in some time. So instead of selecting it from here, I'll go up to Microsoft Excel as the type of file which I'm going to connect to. As you can see at my desktop, I have made a file called Tableau for Data Science. Here I have two data sets, Global Superstore Orders 2016 and Returns 2016. So I'm going to connect to Global Superstore Orders first, and I'm going to open it via Tableau Public. Okay. So arguably one of the most powerful things you will be asked to do as a data analyst is joining tables of data to expand your analytical capabilities. Now that's the reason I did not connect directly to the sample data source to show you how joins work. So first of all, I am going to add the other table as well. So here is returns. All right. So let's join these two tables by dragging them into the view. Yes? So first of all, I'm going to drag orders here and people to union with the orders because that's one particular data set. And then I'm going to go to returns, and the table it has Global Superstore Returns that I am going to join with these two tables here. Pretty simple. Now this might take some time for some of you. For me, it joins really quickly because I have made this join before. Now, Tableau has defaulted to an inner join based on order IDs. I'll show you right now. If I click on the join icon, you can see it has the inner join selected. Now this is what Tableau has automatically defaulted to. So an inner join basically includes records where the join fields match in both tables. In this example, only orders that have been returned will be included from both the tables. However, we want to see all the orders regardless of whether or not they were returned. Therefore, what I would like to use is left join instead. So I'm going to click on left join and then close the window, and that updates my data set. So congratulations, you've successfully connected and completed your first join. So let's go back to our worksheet. All right, you can see a bunch of things on your left. Now, like most software, Tableau uses some very specific terminology. It may be very useful to quickly review these terms before proceeding, as you've already seen a few, and they will continue to be used throughout the lesson. So feel free to skip the step if you are pretty advanced in Tableau. For people who are beginners, I'm going to break this down for you a little bit. So this particular sheet that you see where you're going to work on, this is your workbook. Now, this is the Tableau file that holds your visualizations, and it usually does so in formats such as .twb or .twpx. Now, what you just saw earlier is the data source. Let me just open it real quick. Okay, so this is your data source. It's basically this table compiled in Tableau. Now, this is your data source. It's basically nothing more than a table compiled in Tableau. Now, this is the source of data that you will be using for your visualizations. Now, these data sources can be created from a single source or multiple sources, as we did, by joining or unioning. Haven't you already done this? Now, with your newly gained experience, let's go back to the sheet. Now, connection is the process of stacking Tableau on top of a data source so that it can be visualized. We've done this too. We have connected to our data. Now, that could be a wide range of connectors like Excel files, text files, Amazon Dropbox, Google, IBM, MySQL, Salesforce, etc. Earlier in this exercise, you've already connected to Excel files through the same process. Now we have sheets, which are single tabs in the workbook that you're currently using. As you can see, sheet 1. Now this will hold your visualization, and most of the analysis and building takes place within the sheet. Then you have a view or a viz. Now this is the area where all the magic happens. This is the workspace where visualizations are developed. Apart from that, you also have dimensions and measures here on your left. They're basically data field types located on the left hand of the screen that are often categorized or ordered numerically. Now, measures are basically values of things. As you can see, profit, quantity, sales, discount, shipping cost, so on and so forth. Dimensions are basically attributes like date, time, department IDs. so on and so forth. Now let me just drag this here really quickly. Okay, now this blue thing you see here, I should be calling it throughout the tutorial as a pill. Now pills are what most users call dimensions and measures when they are dragged into the view because they look like a pill. No other explanation. Now, since I dragged it from the dimension, it's colored in blue. If I would have dragged it from measures, it would be green. Now, this particular box where it rests upon is called the shelf. Now, it is a designated container for housing these data fields, and that's it. Among these fields, you will find discrete and continuous, which are terms for describing these data fields. Now, as the name suggests, discrete means that there are a finite set of values, while continuous means there is no limit. In most cases, dimensions are discrete, whereas measures are continuous. Now, another word you will be hearing a lot is aggregation. Now, aggregation is a word in the world of data and is basically any process in which information is gathered and expressed in a summary form. Now, remember, measures are always aggregated in Tableau. Understand this. It'll help you conceptualize the visualization of the 5 primary aggregation types in Tableau, which are sum, average, median, count, and count distinct. Now, one last thing you need to be aware of is the undo button, or more historically known as the hotkey Ctrl+Z, can be almost used infinitely here. So when you make a mistake or you need to go back a click, utilize this magnificent button. All right, are you ready to continue to the next part? So let's get to work and begin visualizing some data. Now, basically what I'm going to do is provide you with the first step. So it's a few tips on data visualization and visual formatting for a beautiful end result. So we already have a sheet to view the data. And basically we are going to start out by creating a sheet to build a year-over-year profit visualization based on category growth by month. So I'm going to double click the profit measure. So basically what you're viewing now is the sum of all profits, which, let me hover over this, will give me a number. So it is $1,467,457. So looking at the number is usually a good place to start as an analyst, as you will likely come across many situations where the numbers are off. Now, this can lead to misleading analysis. So make sure you don't do that. So the next step will make more sense when we create a final dashboard, but we would want a sheet to look at the total profit as a foundational reference. So I'm going to drag this pill. As I had mentioned before, this is a green pill, which means it's a measures pill. So I'm going to drag it from here to the label mark. Next, let's just duplicate it and drag it to the color mark. Then you can click on Control and select the sum profit label and drag the copy to the color mark. Now let's use some revenue style coloring. So let's make it green for profit growth and red for profit loss. And this will be the color theme that we are going to use throughout the tutorial. Again, this will make more sense once we create a dashboard. You'll just have to trust me on this one then. So I'm going to click on color and then edit colors. And we're going to pick this red green diverging from this automatic drop down. And I'm going to check on stepped color and make it up to 6. Select use full color range. Click advanced, check center, and input 0. So basically what I did is just that I told Tableau to make my positive profit numbers green and my negative profit numbers red. So I'm going to apply and OK. Lastly, let's create a visual label for this number. So I'm going to click on the text mark box and it basically will give you the number, which is basically your total gross profit. And I'm also going to name the sheet as total gross profit. Okay, so you've just created a sheet, viewed some data, created a workbook color, palette or theme, and formatted some labels. These skills and setup will come handy throughout this tutorial. So let's continue to the next part. Let's look at profit problems. So basically what we're going to do is we're going to figure out what products are having profit problems by looking at the total profit and comparing it to the year-over-year percentage increase or decrease.
So I'm going to go to a new sheet. I'm going to again double click the profit measures. I'm going to drag the order date as a column. Then I'm going to click on this plus sign here, and I'm going to also drag the year of order date fill to the column mark. Then I'm going to right click here and convert it from quarter to month. Now you're going to see two options, okay? Now the first part in this column is going to show you your quarter, month and day, and so will the second. The second is also going to show you your quarter, month and day. Now the thing is, the top one is the discrete option and the bottom is the continuous option. This example is going to require you to select the discrete option. So I have all my months together here in the same graph. So along with this, let's just learn how to run a quick table calculation to view the year-over-year profit growth. So I'm going to right click this sum of profit bills, go down to quick table calculation and click on year-over-year growth. Now compare this to the original profit that we had done. So I'm going to drag this sum of profit here. So now you have two graphs, one with the profit and one with the difference percentage in profit. So what I'm also going to do is I'm going to drag the one with the table calculation to the tooltip mark. Now understand that when you hover any mark in the view, you will see the total profit and the percentage difference from the previous year. See, exactly like this. Finally, you can look at a gross profit and a year-on-year growth by category. So what I'm going to do now is I'm going to drag this category dimension to the rows shelf. Sorry, missed out on that one. Now with that, you can see all the subcategories and their profit, year-on-year profit, month of order date, so on and so forth. Now I'm going to name the sheet, let's say, profit seasonality. Now, before we move on, I'd like you to know that we have just created our first visualization. So welcome to the club. Conceptually, you just queried the data sheet to provide the sum of all profits based on the year that the profit was obtained from. You then ran a calculation on that profit data to determine the percentage of increase or decrease when comparing to the previous year. Now, before we continue, another useful tip is to format numbers the way they are meant to be displayed, especially if your data hasn't been curated very well, which is most of the time, by the way, let's be honest. Now, based on this data set, it looks like there are multiple currency formats in our measures column. So I am going to right click on profit, hover over, let's say, default properties, click on number format, currency custom, negative values. Now this is already at negative of 1, 2, 3, 4. Now this will save some confusion later. So now we could just repeat this process for sales and shipping cost. Now let's dive even deeper into this previous visualization as we are still looking for specific products that are having profit problems. Again, it's a very good idea to verify the numbers to make sense before diving into visual analysis. So let's create a sheet examining the profit over time by production category. So I'm going to right click on the profit seasonality sheet name and I'm going to duplicate it as a crosstab. So basically makes this easier to read by either clicking swap rows and columns button or using the hotkey Ctrl+W. Now I'm going to drag the category pill from the column shelf. Okay, so again, to remind you, that was Ctrl+W to swap rows and columns. Now basically what I'm going to do is I'm going to drag the category pill from the column shelf down to the row shelf. Okay. Now we're going to adjust fitting options to make viewing the data easier. We're going to right click on the sheet title and click on hide title. Next, we're going to click on the fitting drop down menu and change it from standard to entire view. Now you can notice any year-on-year profit problems in 2015. So let's see if we can spot them using the cross tab. So we drag profit from measures and take it over the column mark and right click on this to select quick table calculation and year-over-year growth. The default colors are
hard to read and not aligned with our theme. So let's change this. Go to edit colors. Where is our red green diverging? I'm basically going to do what I had done earlier and then click on OK. Let's enhance this visual to really call out our profit problems. So basically what I'm going to do, I'm going to change. Now this is a neat feature that allows you to highlight specific categories. So I'm going to rename the sheet as Profit Crosstab. Now you've created another whiz in the process and started calling out visual insights. You can use your highlighter to hover over each of these to determine which has the worst year-on-year profit, the most negative difference for 2015. But you can see it through the colors, which are red already. So now basically I took the measure names out and automatically turned these into line graphs. Now based on the information we've dug so far, it looks like furniture has had the worst year-on-year profit comparison across the year. So we should probably figure out where and why these profit decreases are happening. So let's understand this via a map visualization to explore the world. Now this is also a good time to utilize this Show Me tab, which Tableau is so famous for. Now this Show Me provides you a multiple number of options, as you can see, for visualizing data, while also providing a recommendation based on the selected data or pills that you've used so far. So I'm again going to create a new sheet. Let's click on country. I'm going to click on country and then I am going to click on state using control. Now I'm going to click on show me in this top right, and you should see multiple options, but because we have geographical data selected, there's already a red box around a map symbol. So now I'm going to drag profit to the color mark, click on the color mark and edit my colors. I'm going to do the same thing since we are keeping up with the theme. Now uniformity is a big thing when it comes to Tableau. I think uniformity is very important when you're visualizing data to keep a consistent theme so as to not confuse your viewer. Now keeping the color consistent will basically help your end dashboard look unified. Now I'm going to drag sales to this size mark. Okay. Now we're going to create some filters so that we can hone in on our data. So I'm going to drag order date to the filters card and select years from the option and then next and all and okay. Now I'm going to right click on this order date and I am going to show filter. Now you should see filters on your right sidebar like so. Now I'm going to click on the drop down arrow and at the top of it, I'm going to click on multiple values drop down. This is basically going to help the aesthetics of your final dashboard. Now I'm going to repeat this process with category and dimensions as well. Now I'm going to name the sheet Profit and Sales Map. Nicely done. Now you've just created a map visualization with filters and analyzed data at a deeper level. Now we can see where we have negative profit by year and category with the use of newly created filters. Feel free to navigate around the map, explore the map tools and adjust filters. Are low sales numbers the reason for furniture profit loss in 2015? It doesn't look like it, but it's hard to say. Let's dig deeper. We now need to look at specific items within each category and find any that have negative profit 2 years in a row. Now let's start by duplicating the sheet. Now the benefit of duplicating previously created sheets is that filters, calculations and the coloring will carry over. So I'm going to right click on this and click on duplicate. So I'm just going to remove this. Now let's drill into the categories. Drag category and subcategory from the dimensions to the rows. Now we're going to drag order date to columns. We're also going to take profit to the columns and take here on your growth. Then we changed our sum of sales from size to tooltip. Now, based on this data, it looks like there's a hierarchical relationship between category and subcategory of products. So now I'm going to create a hierarchy of category followed by the subcategory and product name so that you can drill into the category pill in the rows. Now you can browse through specific subcategories and view both the gross profit for consecutive years and the difference percentage in profit from the previous year of the order date. You can find all the subcategories that have both net profit, loss, and negative year-on-year difference for the past 2 years. And since we can't calculate year-on-year with our first year, but we also can't remove it from the view as the following year relies on 2012 data, let's hide the 2012 column. So I'm going to right click on this and click on hide and change standard to entire view in the fitting drop. So I'm going to name the sheet profit by subcategory. So with this sheet, you just learned to create a bar graph and learned how to create hierarchies. Now you can see profit for all items being sold, browse through each subcategory and spot any that have bought both negative net profit and year-on-year growth for 2 years in a row. If you've done this correctly, your visualization should help this stand out immediately. Do you see it? You can see this ginormous block of red right here. So we know our stuff is working. And we see that this is furniture. So why are we here? Now that we know there's a major profit problem with tables in the furniture category, we know that sales is not the problem. I wonder if it has to do anything to do with shipping cost, returns, or discounts. So let's take a look by creating a scatter plot. So I'm going to duplicate this sheet again because we will need the filters, and I'm going to clear the column shelf and row shelf. So I'm going to clear both of these shelves. So now we can format and examine our variables that are sales, discounts, returns, shipping cost by customer ID and subcategory. So if you haven't done so already, format discounts in measures as a percentage. And we are doing no decimal places. Ready, set, visualize. Now we're going to add the subcategory filter and show and format it like the year or the date thing. And drag the customer ID and subcategory from dimensions to detail mark. Now we're going to drag discount and shipping cost to the detail mark as well. And you can scan through the entire place according to your customer ID. You can use the tooltip to spot any correlations with regards to the aforementioned variables like so. Now there may be definitely an impact from shipping costs, but there's something else that seems to be bringing the profits down, and those are the discounts. Since Tableau has automatically aggregated discounts as a sum, but discounts are more of a stable attribute, we are first going to want to format them into an attribute. Now we are going to drag it to detail, columns, and swap axes. And now we have heat maps by subcategory. Now attributes are sometimes difficult to conceptualize, but Tableau defines an attribute as an expression that returns the value of a given expression if it only has a single value for all rows in the group. Otherwise, it displays an asterisk. In this exercise that we just did, each subcategory item has a unique discount percentage and will therefore return that specific percentage. If we left discount as a sum aggregate, now Tableau would attempt to sum the discount percentage together, giving us inaccurate information. So basically, I'm going to rename this discounts affecting profits. Now that was intense work. You just created an in-depth visualization to assess variables impacting profit, learned more about aggregations, all while solving a business problem through visual analytics. It's almost over, except for one really fun and important step, the final dashboard. Now that your analysis is complete, we are going to create a dashboard to display these results. It can be challenging to get all these sheets into areas you want them to be in, and the directions are a simple way of organizing this dashboard. So feel free to create your own. I'm going to click on New Dashboard and I'm going to rename it as Profit Analysis or something. I'm going to click on Size drop down arrow and change. So I've changed it to Automatic. All right. Now this will basically allow your dashboard to resize automatically to any monitor. First, let's drag the horizontal object or container to view and then drag another. I'm going to put seasonality into this. Bring this in and I'm going to put the profit cross tab here. Bring it down and profit by subcategory here and bring it up. I'm going to delete this. And the reason I've done that is because cross highlighting is possible in Tableau. So, okay, let's clear this also. Yeah, this looks so much better. And here you have all of your filters as well. So basically we have 1, 2, 3, 4, 5 sheets, various filters and keys on this dashboard. I left out that totally random total gross profit sheet that I created in the beginning because it would not contribute to this dashboard. Now, if you would like to publish this dashboard, you can easily click on the server drop-down and use the option Publish Workbook. With that, you have created a what, where, and why dashboard to answer a business question and solve a data problem. Congratulations! Now, if you have successfully followed along from start to finish, you have experienced the world of data analytics and visualization. Tableau Public also has daily competitions for what is known as Whiz of the Day, and you could check out some really interesting data sets across the world through it. With that, let's move on to our next problem. Now, taking what we understood in problem statement number 1, let me show you what can be done using Tableau in the next problem statement. Basically, we are trying to find out that can we use the tools of natural language processing and statistical models to understand why some TED Talks work to see how persuaders persuade? Or can we use transcripts from TED Talks to find out text features that predict persuasive ratings by users? Now, the purpose of this project is to understand and emulate the content and linguistic style of persuasive talks. Now, this project is inspired from 2 people that I found on Tableau Public, one by the name of Ronak Banik and Visualization by Owen Temple. This is basically a natural language processing project to reveal linguistic features that predict what is persuasive. So I web scraped every TED Talk transcript and its metadata through 2017 and then used decision trees, random forest regressors, and linear regression to find the key predictors of persuasive ratings by viewers. For professionals who need to communicate and influence others, this will provide some insight on how to speak to persuade. So basically, I found out that the change in negative and positive emotion words across the talk and the speaker's use of key social pronouns like I and we made a big impact on persuasive ratings. My analysis also resulted in a few important categories of words that make up linguistic signature of persuasion and a classifier that you can use to predict the persuasiveness of your own text. Whether or not you ever give a TED Talk yourself, and no matter what your job title is, developer, data scientist, or recruiter, your job is ultimately to communicate and influence. So the words you say matter. Whether it's a morning stand-up meeting, a training, or a conference call, you need to persuade your clients and sometimes even inspire. And what better way to learn how to persuade and inspire than from the masters of persuasion, the TED speakers? So I have to give in, I'm a TED Talks enthusiast and I've watched one a day for almost 6 years now. And I noticed that some talks are very persuasive. They change your day and maybe your life. Some others fall flat and are completely forgettable. What we are trying to find out is, can we use the tools that are available to us to understand why some talks work and to see how persuaders persuade. Our job here, no matter the title, is to influence and persuade others. So can we use successful TED Talks to learn how to become more persuasive communicators? So for the solution, first, as I said, you have to scrape the transcripts of TED Talks.
followed by using natural language processing techniques and linguistic inquiry and word count LIWC module to analyze those transcripts. The embedded models include decision trees, random forest regressors, and linear regression to find text categories with statistically significant relationships to TED.com's user ratings and to the number of times the talk has been viewed. So let's move on to our hypotheses. So a more persuasive or inspiring talk is related not just to what people are saying, but how they are saying it. So when I say what people are saying, I'm talking about content words like job, brains, computer, something like that. How they are saying it are emotion words and function words. How can be two ways. Function words as in talking about the subject matter. Is it I, you, we, or what? Emotion words are how they are saying it, happily, sadly, angrily. Emotion words basically are the ones that use positive and negative emotions in the shape of hero's journey that will be more persuasive and inspiring. Now, function words are basically socially powerful words like I, we, you, what, where, how will be predictive of persuasive and inspiring ratings. Talks that use I, me, my more will be less persuasive. Talks that use we, us, and pronouns like that will be more inspiring. Now let's talk a little bit about the tech stack. Now the tech stack consists of a couple of technologies, including Python, where we are using its various libraries to count the number of words from the talk transcripts. We're using linguistic inquiry and word count, which is a software package which takes as input a particular talk's transcripts and returns a percentage of words from the talk that fall into one or more of the particular categories in the LIWC library. Then we have the natural language toolkit for running our natural language processing techniques. Apart from that, we are also using scikit-learn, HTML, CSS, Flask, Heroku, and finally for data analysis and visualization, we are using Tableau. So we are basically going to be focusing more on that. So let's move on to our demo machine. All right. So here is what we found out. First of all, let's look at these two graphs. These two graphs, the green one and the red one, mostly represent emotion words across all talks. The first one, the green one, shows the positive emotion by transcript quarter, and the second one is the negative emotion by transcript quarter. So this is the basic dashboard that we achieved. Now, what can we take from this? First thing, we understand that text features were associated with higher persuasive ratings by TED.com users. So basically what you say, risk words such as danger and doubt, moral words such as care, fair, and loyal, and money words such as audit, cash, and owe, and how you say it, like negative emotion words like hurt, ugly, nasty, negate words like no, not, never, question words like how and what, and focus on present words like today, is, now, were associated with higher persuasive ratings. Now, linguistic signature, as you can see in this graph, now we understand that text features exist that were associated with higher persuasive ratings by TED.com users. For example, what you say. So it's 0.496 on risk words such as danger or doubt, a moral word such as fair or loyal or justice, and money words such as audit or cash. They are words of what you say. The second aspect is how you say it. Negative word emotions like hurt, ugly, nasty, interrogative words such as how, when, what are basically how you say it. Now, consistent with a hero's journey framework that calls for many challenges in the course of a narrative, increased use of negative emotion words like sad, angry, depressed, and frustrated across all quarters of the talk were related to higher persuasive ratings by TED.com users. All right, let's just take the most persuasive talk, the most highly rated talk. Why gun violence can't be our new normal.
Now, as we can see on this graph of the linguistic signature, it's consistent with a storytelling framework where there is an increased number of negative words as well as quantitative words. It also has a fair amount of average interrogative words and very few number of risk, moral, and money words. One thing we understand for sure, we don't know what can make a good TED Talk, but we definitely know from this graph what are the few aspects, what are the few words or emotions you can use to directly affect the statistic of that particular TED Talk. Now, a further improvement on the accuracy of this model could be a sublime text classifier model. You can expand the analysis to find the text features that predict more user comments online. Now, if we take the rearranged version of the same dashboard and I select, say, this talk in random. So if we pick up a topic such as a critical look at geoengineering against climate change, you realize it furthers our estimate that the use of more negative emotion words has resulted in it being a more persuasive talk. You can see how less the positive emotion words are. In the first quartile, second quartile, it's even less, the third quartile, and the fourth quartile. Here, the average risk words in the linguistic signature has increased to 1.34 because obviously we are talking about climate change, which is a high risk subject. Along with that, we have more quantitative data along with an increase in interrogation words, which, considering the topic, is well justified.
What is the overall architecture of any data visualization tool for that matter? It takes data from a lot of data sources. And after taking the data from different sources, we create the graphs using that data, represent that data in a visual format. After having created the charts, we share it with the end users. There are multiple methods using which we can share. We can send the Tableau workbooks. We can send them as PDFs, PowerPoints, Word documents, Excels. We can also publish them to servers. And then different people who have access to the server will log into the server and access the content. Okay, that is the architecture, overall architecture. Now we can do forecasting in Tableau. What does it mean to perform forecasting? It means that you're trying to predict what will the future value be like, depending on the current and the past performance of a business. If you're trying to determine the future direction and trend, that is called as forecasting. Okay, I will show it to you. So Tableau has some advanced analytical capabilities like performing forecasting. Okay, when you open Tableau, you're presented with this kind of a screen with some data sources which are inbuilt into it. I'm using the inbuilt connection Superstore. Here we have data for 4 years. Okay, we have data from 2018 to 2021. Let's say I'm looking at the profit made by the business or the sales of the business. Okay, and I will, let's say I'm having data about the quarterly performance. What is the performance of this particular business across different quarters in each year? Each year, what is its performance like across different quarters? Now, I need to estimate for 2022. I have data up to 2021. I would like to estimate what will be the sales like in 2022 and in 2023 for the next 2 years. So we can do forecasting. It's very simple. Here we have an analytics pane. So from here, we can just drag the forecast option and drop it in the graph. Immediately, Tableau will do the estimation, tell you what could be the sales for the future time period. Okay, it's that easy. So let me show you. We will take for 2 years. Okay, let's estimate for 2 years. So we have data up to quarter 4 of 2021. Now we are estimating for 2022 and 2023. It automatically takes the historical data, the old data that we have, and estimates for the future. That is forecasting. Taking historical data and telling what it will be like in future. Not just forecasting, we can also do something called as, we can put trend lines and do prediction. Okay, for example, let's say the same graph, I'm looking at data like this, and let's say I'm looking at profit. Now, looking at the current trend in the business, looking at the current trend, I have to estimate the future profit based on the trend. I will just go ahead and add a trend line. It will show us what is the overall trend in the business. Upward trend, downward trend, constant trend. Okay, it gives you the equation of the trend line, R squared value and P value. These two values, they will tell you whether the model is significant or not. Okay, it's talking about the trend in the business. Okay, I'll keep it like this. So there is an upward trend is what we can see. There is an upward trend in this business. Year over year, slowly we can see that the business is improving. There is an upward trend, it's going up. So trend lines will help us determine the overall direction in which your business is moving, the trend. Okay, so that is the next concept, which is estimating the future and also checking the overall direction, the trend in which the business is moving. Okay, now what is the learning path for Tableau at Edureka? Overall program is divided into 12 modules, each module approximately 3 hours. That makes it 26 hours. Okay, first module is data preparation using Tableau. We look at a tool called as Tableau Prep, which helps us understand how to prepare the data by cleaning it. Then there is something called as data connection with Tableau. We can connect to different data sources in Tableau desktop and we can create reports with it. Then we talk about basic visual analytics in module number 3. That is where we get an idea of how to actually interact with the tool. What are the basic charts that we can create? Simple graphs and some concepts like sorting, filtering, etc. Module 4 is where we see how to create calculations in Tableau. Now here I want to point out one thing. You don't need to be from a programming background to learn Tableau. You don't need to know coding. Okay, even if you're from a non-programming background, you can write calculations in Tableau because they are pretty simple. And Tableau gives us a lot of support also internally when we are writing calculations. It helps us. It gives us the syntax, the explanation, all that is available. So it's very, very easy to write calculations. We proceed to advanced visual analytics, where we will look at some advanced graphs and analytical capabilities of Tableau. Okay. There is one module called as LOD. It stands for level of detail. Here, this is also calculations, but it is slightly more complicated. So after you have covered calculations, you get familiar with how to write a formula. Then only we proceed here to LOD, which is little bit difficult compared to the regular calculations. It's a different concept. However, we have one module where we covered this concept in detail and thoroughly. Okay. Then we have module 7, geographic visualizations in Tableau. Everything about geographical maths is covered over here. We proceed to module number 8, where we look at some advanced charts, some of which we are also going to be seeing in today's webinar. And then we will be looking at how to create dashboards and stories. And then there is one industry grade project that we will be working on in module 10. Apart from this, there are 2 more modules. We will be looking at Tableau Online, a server platform of Tableau. How do we work on it? And there is one project in module number 12 that we will be solving. So 12 modules, in total 36 hours. Okay, let's proceed to advanced charts and very quickly see how different types of graphs can be created in Tableau. First, Pareto chart. Very interesting concept. Pareto is built on a very interesting concept. It helps you understand how many members in a dimension contribute to what kind of measure value. It is basically related to the Pareto principle, the 80-20 rule. The 80-20 rule, which says that by doing only 20% of the work, we can generate the benefit of, we can generate 80% of the benefit of doing the entire job. Okay, so that is possible when we focus on high performers. Not randomly any 20% activities, right? we focus on very important, critical, crucial activities. That is when we can go and create, when we get Pareto. Okay. All right. So Pareto chart is based on the Pareto principle, which is the 80-20 rule. It says that by doing it is the vital few, focus on the most important things and get 80% of the benefit of doing it. So how do we do this? Let's say this particular business, okay. So we have different subcategories here, and we are looking at the sales from different subcategories. Okay, I'll sort the data in descending order. Why? Because I'm going to focus on the high performers. Okay, and Pareto is built on the running total of measure. Running total is what I have to apply. I need to get the cumulative total, and the cumulative total is supposed to be represented in percentage format. Okay, so how do we read this graph? Let me tell you. Phones alone giving this business 14% of its entire sales. Phones and chairs together give it 28% of the sales. Phones, chairs and storage collectively 38%. And like that, as you proceed, you can see just a few members, okay? These few members are giving Superstore almost 80% of the sales. Okay, and these members here have very, very little contribution, 99.32. This comes and increases the sales by a few decimals, and this increases it a little more. So for some reason, if Superstore is not able to stock up these products, if it's not able to sell fasteners or labels, or if it's not able to sell something related to supplies, something related to art, something related to envelopes, no harm. It will not lose a significant portion of the market. It will not bring down the sales of Superstore drastically. However, imagine if Superstore is not able to sell phones and chairs, it's not able to stock up these things, then what will happen? 30% of the market it will lose, right? 30% of the sales is coming from just these two members. So very, very important members they become, right? Like that, these are all the members which are giving Superstore 80%, nearly 80% of the sales. Very important things, very important products. Okay, that is what a Pareto will help you understand. And then to show the actual contribution of the members, you can go ahead and put the actual contribution and bring them together using a concept called as dual axis. So the bars here are telling about the actual sales, and the line is telling about the cumulative total. Pareto tells you about two things. That is what makes it very interesting chart. Two things it's telling you. What is the actual value? And in terms of percentage, what is the cumulative contribution of these members? Which members are very vital to the business? Which members are not very significant to the business? Okay, it tells you those things. That is Pareto chart. Then bar chart is simple. It is simply for performing relative comparison, categorical comparison. So when I present you with a graph like this, what will be your inference? So we can clearly understand that technology is the most profitable member. Furniture is the least profitable member. We have very little profits coming from here. How do I know it's profit? Look at the title on the axis, profit, across different members, which are categories. Okay, so very simple chart. Bar chart is basically for relative comparison or categorical comparison. Relative or categorical comparison. So across different categories, what is the profit made by this business? This is the profit from different categories. Next, line chart. Line chart is used when you have to show the trend over a period of time. You need to show the overall performance of the business over a period of time. Okay, so when you have time series data and you have to check the direction in which the business is moving. When you have to do time series data analysis, how is the performance of the business over a period of time? What is the profit like? What is the sales like? Year over year, we can see the profits are increasing, right? Year over year, the profits are increasing. So it helps you perform time series data analysis, looking at time series data and determining the overall direction. Then we have text tables. When do you create them? When you have to show the exact value, when attention to detail is important, when the value is more significant for your analysis, wherever you're dealing with money, right? When you're purchasing something, you might want to know the exact value, not just if somebody says, okay, this product costs 10% less than product B. We are not going to purchase something based on that kind of comparison. Would not want to know the exact value. Okay, not 10% less than something or 20% more than something. Tell me what is its value. Tell me what is the price. So especially when you're dealing with money, like the utility bills that you get, electricity bill, water bill. When you go to a mall and you get a bill for whatever you purchase there, right? So those are all text tables. How do we create text table? Very simple. When do we create them? When you have to show the value. Let's say I want to see what is the profit made by various subcategories. There, I can see profit. I want to see sales. I want to see quantity. I want to see the discount offered. Whatever it is, you can simply take into the table and you can create a graph like that, showing the actual values. Okay. Then we have a heat map. It is a slightly different way of visualizing the data. It is for comparing itself, for comparative analysis. It's more like a text table only, but the data comes in the form of squares. Rather than showing the values, we show all the information as a matrix of squares. Let's say across different years and different, what shall we take, subcategories, I want to show the sales. Okay, if I do this, this is the sales data. But instead of doing this, if I go and take sales here, like this, I use some other mark type called square. If I represent the data as squares, this is called as a heat map, where the size of the square is telling you about the value approximately. So relative comparison. It's consistently everywhere big squares. So every year the sales of chairs is good. Every year the sales of fasteners is very little bit, very little, right? You can see tiny squares there. Years, look at the size of the square. Year over year it is increasing. Sales is improving. Year over year the sales is improving. We don't know the exact value, we're just getting a relative comparison. Okay, this kind of a chart is called as a heat map. Waterfall chart. Waterfall chart is, okay, before waterfall, let's do, I think Gantt chart will do. Gantt chart is used to show the change in the value over a period of time. Gantt chart is like a project plan. Okay, sorry, it's not change in the value, it is a project plan. Waterfall is change in value. Gantt chart is a project plan. Now let's say I've been given a project and my project is to build a house. Okay, I've been given a project to build a house. I will not randomly go to the site and start off doing whatever I feel like. Right? I cannot say my team, okay, start off with the electric work, call the plumber, do the painting. No, plumber will not come and start doing fixing the taps even before the walls are constructed, even before the foundation is laid, right? There has to be a proper sequence in which we do the activities to complete a project. First, I'll have my team complete the work on the foundation, then build the walls, then the roof, fix the doors and windows after that. Then maybe the other people will come and the electric work will go on, the plumbing work will go on, the flooring work, finally the painting work. So I need to make sure that my team is aware of the activities to be performed in that project. And I also need to give them some timelines. Because if we just give the list of activities and tell them do this in this sequence, it's not enough. Need to know how much time they have to complete the task. Otherwise, they'll take their own sweet time, right? It may take forever to do simple things. So you need to give them timelines. Then only the scheduled deviation will not happen. Then only the project will be implemented, completed on time and implemented. So Gantt chart is that. It is a list of activities to be performed in order to complete a project, and we also associate timelines with it. So let's say I have data for a project, request evaluation, then we gather the requirements, we know when it is supposed to start, how many days we have to complete that activity. Design document, start on so and so a day, you get 4 days to complete it. Working on the coding part or building it, the drafting phase should start on so and so day, and you get only 2 days for that. So when you have a list of activities against a timeline, we create a Gantt chart. In such situations, we create a Gantt chart. Okay. The request evaluation first. Then comes, okay. I'll just sort it. See, request evaluation, then starts requirements, look at the steps, then starts design, look at the steps. Like this, step by step, we have to do the activities. That is what you understand when you see a Gantt chart. That's how you read or interpret data on a Gantt chart. So waterfall chart, it is used to tell you about how different dimension members are contributing towards a measure value. Okay. What is the contribution of each member? This is contributing to almost 42,000 of the profit. This is contributing to nearly 18,000 of the profit. This is giving 6,000 profit. This is giving 30,000 profit. This is giving a loss of 3,000, loss of 17,000. Okay. Now, it is built on cumulative total. We take the cumulative contribution. And to make it a waterfall chart, we use Gantt bar as the basis for it. And we are going to size it, okay, by the negative counterpart of that field. Now you will see how beautifully the waterfall is going to come. Look at that. Look at that. Okay, that is a waterfall chart. How are these members contributing towards the measure value? And to show the source, okay, I can see the fall. I can see the fall. I can see the contribution of different members. But where is the source, right? So we go and show the totals. So this is the overall profit and how different members are influencing the profit. How different members are influencing the profit leading up to that value. Okay, that is waterfall chart. Pie chart. It is used to show the shares, the ratios. What is the contribution of different members? So let's say this is the complete profit made by a business. What is the share given to each category? What share of this profit is for furniture? What share of this profit? Which part of the profit? How much part of it goes to technology? How much goes to office supplies? Like that. Okay. For example, let's say this particular business, Superstore, is operating in 4 regions. Okay. So now from each region, I want to see how much is the profit and collectively what is the overall profit. How much is the individual profit and collectively everything put together, what is the overall profit? So here, this is the overall 100% profit. Then you can see the slice belonging to West region. Highest contribution is from here. We have East, then we have South, and then we have Central contributing towards the profit. Okay, you can also show that in the form of percentage. What is the percent contribution and the actual contribution of these members? So 37, nearly 38% of the total profit is from West region. 14% of the profit is from Central region. That is the share of Central in profit. Okay. Then we have scatter plot. It is used to show the relationship between the variables, between the measures. Means, suppose I have to tell you what will be the profit given sales. What is the relationship between the weight gained by a person and the calories consumed by a person? What is the relationship between the are generated in a power plant versus the wind speed in that location. Okay, what is going to be the profit relationship between profit and discount? So scatter plot tells you about the relationship. Okay, for instance, let's say I want to check the relationship between the power output and the wind speed in an area. Okay, if the wind speed is high, is the power generation going to be high? If the wind speed is less, is the power generation going to be less or more? You see, there's a direct relationship. As the wind speed increases, the power generated is going to increase. You see, upward or a positive or a direct relationship. It tells you about the relationship between the variables. That is a scatter plot. Area chart. Again, to represent any measure over a period of time. So we saw line chart. It is in line with that only. It is area chart is nothing but a variant in line chart only. But it will tell you about the overall effect. So let's say across different years, I am looking at the sales of the business. Now I will show the sales from different categories or segments, let's say by segment. So I have each line representing the performance of a segment. Consumer segment, the highest sales is coming from here. Then we have corporate segment, and then we have home office. Now, what if I have to stack these together? If I stack their performance one on top of the other, can go with an area chart. So the performance of home office, on top of that is stacked the performance of corporate, on top of that the performance of consumer. So stacking the areas together is an area chart, putting everything together. Dual axis chart, when you have to compare the actual performance against a target or a goal, that is where dual axis comes in very handy. Dual axis or dual combination. For example, let's say there is a business which is selling different types of coffee and tea products. Okay, and every product has a target that it is supposed to reach, a target profit given to it. And it has also made some actual profit. Now I want to compare them easily, so I can merge them using the concept of dual axis. Okay, the actual the target I will show in the form of a line. That is the target. And the actual performance I will go and show in the form of a bar. Okay. So bar is telling you about the actual performance. And the line is talking about the target. So here we can see this bar could not reach that line. Means it missed the target. It made a profit of only 17,000 when it was expected to make a profit of 23,000. Could not reach the target. Here we have gone above that point. So we have gone beyond the expectation. Expected profit was 27,000. It made a profit of 29,000. It did really well. Getting it? So when you have to compare like that, you can create a dual axis chart. Bubble chart. It is a beautiful visualization which gives you information as a cluster of bubbles. So depending on the size of that bubble, you can measure whether it is high value or low value. Phones, it is very high value, and this numbers like art, etc., very low value of whatever measure you might be looking at. So let's say I want to create a bubble chart. Across different products, I want to check what is the sales like. Okay, so I've selected both of them. I'll go to the Show Me panel. It contains a lot of charts which we can create very easily from here. Clicking on the bubble chart icon, it's ready. So the sales of various products from the coffee chain business we can see. Colombian is selling the most. Right? Then we have lemon, and these are nearly equal, like cafe mocha, decaf espresso. Next set, Darjeeling chamomile and decaf Irish cream, Earl Grey, mint, green tea, and the least, I think, regular espresso is selling the least. After this, we have a histogram. Histogram is used to show the distribution of the data. Okay, the distribution in the sense, let's say I want to check the sales distribution. Okay, so by selecting the pill, when we go to the Show Me panel and click on the histogram icon, Tableau will create it for us. It is breaking the data into smaller intervals called as bins. And then it's helping us understand the data. I'll use a bin size of 100. So what do I understand is there are 1,000 transactions which happened in this business with the selling price in the range of 0 to 99. Bin size is 100. 0, 1, 2, 3, 4, like that up to 99. There are 1,800 transactions with the selling price in the range of 100 to 199. Look at this, 100 to 200. That is 100 to 199. 200 to 299. 600 transactions happen. 300 to 399 selling price. 250 transactions happen. So as the cost of these products is increasing, selling price is increasing, the transactions are reducing. Mostly people are preferring the products whose cost is in the range of 100 to 149. So it is telling you about the distribution of the data, the number of records in each bucket. Few of them are still there, I think. Okay, you see here, this is sales bin 0. All the transactions with the selling price in the range of up to 99. Okay, up to 99 will be in bin 0. Up to 99 will be in bin 0. Transactions with their selling price from 100 onwards go into bin 100, and we're getting counting those records. Okay, which is quite a lot of records. Like we have 1,800 records, I think. Then you see transactions with the selling price up to 199 are here. Then 200 onwards, 200 to 299 go into bin 200. 200 to 299 they go into bin 200. Then more than 300, 300 and above they go into bin 300. 300 to 399, like that. So we're getting the number of transactions in each bin, in each interval, and we can notice that as the sales price increases, the number of transactions are reducing. People are not purchasing products which are very, very expensive. I think we have just one more topic left out, which is integrating Tableau and R. I will quickly show you that also. If we have to make Tableau communicate with R, if we have to integrate Tableau with R, okay, if you have to integrate Tableau with R, then means Tableau wants to talk to R, right? Tableau wants to talk to R. So R also should be ready to talk to Tableau. Both of them should be ready to communicate with each other. So how do we do that? First, we start R itself, and in R there is one service called as R serve. It will help R to communicate with external applications like Tableau. Okay, so first we need to install that service, for which these three commands are to be executed. We need to run them, like install.packages rserve. Once we do that, the package will be installed. Okay, after that we have library rserve, which will load the package. Then we have rserve with empty parentheses that will start the service. That will start the rserve service for us. Finish. Now we can minimize R and go to Tableau. Now from Tableau, how do we connect to R? Okay, R is ready. We have prepared R to talk to Tableau. Tableau also needs to connect to it. So here what we do is we go to Help, Settings and Performance, and from there manage Analytics Extension Connection. Now we connect to R, which is local host on our machine, and there's a port that is reserved for Tableau to communicate with R, port number 6311. And I'll save this connection. Now Tableau and R can talk to each other. So using the existing fields which are present in this connection, you can create some reports. Let's say for some requirement, I would like to take the help from R. For example, over here, I want to check whether this number is positive or negative. Very simple. Is it greater than 0 or not? For this, if I want to take the help from R, we can do it only through calculated fields. So the formula should use something called as a script function. Script followed by the code. The data that we pass from Tableau to R, they are called as arguments. I'm passing the profit. When this concept of Tableau and R integration was introduced in Tableau, so the Tableau people came up with 4 functions called as the script functions. There is script boolean, script integer, real and string. Depending on the result that you're expecting from the call that you make to the external service. Means I'm going to send profit to R. R is going to give me back true or false. So depending on what I'm going to get back from the call that I make to the external service, we have to choose one of the script functions. If you're expecting Boolean result, then you go with script Boolean. If you're expecting an integer, go with script int. If you're expecting a real number, go with script real. If it's a string value, then go with script string. Depends on what we're expecting. And syntax. So when you are passing data from Tableau to R, such values are called arguments. .arg hash is the syntax to use. If it is Python script underscore arg hash. It's an R script, so I will use .arg. Hash is the number. One value I'm passing. I want to check whether that is greater than 0. Okay. Now when I do this and take the script, now Tableau will send this data to R. R will look at it and tell you whether it is greater than 0 or not. True means it is greater than 0. Getting the point? So that is how the communication happens. You can break it down the way we want. This is per region. This is for different categories in each region. And here you can see a false, not greater than 0, so false. Okay. So for Tableau and R to communicate with each other, first we need to establish the communication link. Means you need to have R installed on your machine. In R, you need to activate a service called rserve. What will this rserve do? It will help R to communicate with external applications. Then in Tableau, go to Help, Settings and Performance, Manage Analytics Extension Connection, and we connect to rserve. That way, the communication link will be established. Then we create the reports using Tableau. And if we want Tableau to communicate with R, then we have to do it only through calculated fields. And that too, only one of the script functions can be used. We can't do anything beyond that. The scope is quite limited. It is there, but it is quite limited. Okay. So that is about integrating Tableau with R.
So our first trick is a profit calendar. Did you know that we can represent our data in the form of a calendar using Tableau? Let us see how. So to create the calendar, drag order date to the column shelf. Make sure to right click and drag the pill and then select weekday from it. Now by pressing the Ctrl key, copy the order date pill in the row shelf. And from the drop down, select the week number. Now let's say I want to depict profit in my calendar. So let's drag profit to the colors card. You can see that we have got a nice layout of a calendar. Now let's add dates into it. So to add dates, let's drag order date to the labels card. And from the drop down, select day. Tableau automatically switches over to a text type chart. So make sure to make it a square type chart. So here we are with the profit calendar. This calendar shows us the day-wise profit for a single month. Now moving on to our next trick. Bar inside bar charts. So these types of charts come in handy when comparing data for consecutive years or months. So let us now see how to create them. So I have plotted my measure values in the column shelf and region in the row shelf. Now let's copy measure names pill to the colors card because we want sales and profit depicted in different colors. Now we'll copy the same pill to the size card so that we can control the size of our bars. Now go to the analysis tab, stack marks, and make sure that it is turned to off because we want both our sales and profit from the 0k value. So this is how you create bar inside bar charts. Moving on to our next trick. Our next trick is a donut chart. So donut charts are very useful as they provide us with empty space in between for quick high-level view of percentages or shares of total. In this chart, we can see the sales across different segments, as well as the total sales at the center. So let's see how to create a donut chart in Tableau with few simple steps. So I plotted region in the colors card and my chart type is selected to pie. Now let's drag number of records pill to the row shelf and change its measure to minimum. Now copy the pill and make it a dual axis graph. We can remove the headers. So now we have got two pie charts over here. So the next thing that we are going to do is to remove the region pill from one of the pie chart and make it white in color, so that when we increase the size of the other pie chart, it gives us a shape of a donut. Let me show you how. So let's remove region and make it white in color. Now for the other pie chart, when we increase the size, we'll get a nice shape of a donut. Now let's add some labels into it. Let's say I want my donut chart to depict sales. So let's drag sales to the labels card. At the center, we want the total sales. So let's rename the label to total sales. Now for the outside region, we want the regional sales. So let's drag sales to the labels card of the other pie chart. And let's rename the label to regional sales. So this is how we create a donut chart in Tableau. Let's see what's next. Axis formatting. So did you guys notice that my axis is appearing on top of my chart? Also, I've used the abbreviated form for each of the months so that my chart looks clean and less cluttered. Let's see how to do this in Tableau. So one way to move your axis on top of your chart is go to the Analysis tab, select Table Layout, and then go to Advanced. Uncheck this checkbox of Show Innermost Level, and you'll see that Tableau automatically moves your axis on top of your chart. I'm sure that this looks very tricky to you all. So now I'll show you the easy way to do this. So let's undo this and duplicate the order date pill. Now let's drag the duplicated pill to the column shelf, and from the drop down select month. You will now see that my header is appearing on top of my chart as well as on the bottom of my chart. This is because both the headers are represented by two different pills. So what we can do is simply turn off the header for one of the pill. So this makes us move our axis on top of our chart. But the things look a bit cluttered over here. So let's see what we can do about it. So we can simply right click on the axis and go to Format. And under the header pane, go to Dates and select Abbreviation. You'll see that Tableau changes the name of the months to their abbreviated form. We can even select the first letter to represent each of my month only by the first letter. So this helps make my chart clean and look more attractive. Moving on to our next trick, nested sort. This is a tricky one, but let's see how to implement sorting in Tableau with few easy steps. So I plotted my sales in the column shelf and market, product type, and state in the rows shelf. Now we'll duplicate the sales pill in the column shelf and add a negative sign to it. So now you will notice that we have got a mirror image of sales in a chart. Now let's make this pill discrete. Now when we select discrete, the pill will turn blue in color. So now let's drag this blue pill between market and product type and see what happens. So when we do so, you'll see that your results get sorted on the basis of market. And when we drag the same pill between product type and state, you will notice that the results get sorted on the basis of the product type. Now, what if I don't want to keep dragging the pill every time I wish to sort? So to make it more interactive, we'll now make use of a parameter to give dynamic controls to the user. So let's remove this pill from here and create a new parameter. Let's name the parameter sort by. Make it a string type parameter and go to the list option. Under the value tab, type all the values on which you want to perform the sort. For example, in this case, I want it on the basis of market and product type. So once you create the parameter, go to the drop-down menu and select Show Parameter Control. So right now our parameter doesn't do anything. So we'll create some calculated fields so that we can make use of a parameter. In this case, we'll create two calculated fields. We'll name the first one as sort by market and type if sort by, which is a parameter, equals market, then negative sum of sales. The negative sign in front of sum of sales depicts that the results will get sorted in descending order. If I only write the positive sum of sales, then they will get sorted in the ascending order. So in this scenario, we'll go with the negative sign. Now let's copy the code and make another calculated field. Let's rename this to sort by product type. Just paste the code here and instead of market, type product type. Now let's drag both the calculated fields to the row shelf and make them blue in color by selecting discrete. Now drag sort by product type pill between the product type and state and sort by market pill between the market and product type. And now when you select product type in the parameter, you'll see that your results get sorted on the basis of the product type. So now with the help of a parameter, we can sort by any means we wish without dragging the pills every time. Moving on to our next trick, 2 pills on the color card. So usually the color mark card can hold only one attribute. But today I'll show you how you can put tuples on the color card and your data model will still make sense. Let's see how. So I have plotted my quantity in the column shelf and ship mode and category in the row shelf. Now by pressing and holding the control key, select category and ship mode from dimensions and just drag them to the colors card. You will notice that both the pills get added onto your color card. But right now our data doesn't make any sense because the random colors are assigned to the random values. So now let's drag this category pill below the ship mode. Once you do this, you will notice that each of my ship mode is depicted by a different color, whereas different shades of a color represent a different category. So this is how you can add tuples on the color card. Now I'll show you how you can quick color your chart. Let's say you want to color your chart on the basis of category. So you can simply drag the category axis onto the chart. It's that simple. So with this trick, you can apply quick color to your visualizations. Moving on to our next trick, a word cloud. So word clouds are an eye-catching element on an infographic or a PowerPoint presentation and may attract more attention than the usual suspects like a bar chart. They provide a kind of first insight as the most popular product pops out and can be seen at a single glance. Now let's see how to create word clouds in Tableau. So to create a word cloud, I'll drag variety to the text shelf and again copy the same pill to the size shelf. And from the drop-down menu, change its measure to count. So by doing this, the words that have the highest count will appear bigger in size. Now Tableau automatically makes it a tree map chart. Let's switch back to text chart. So now we've got a nice layout of a word cloud. Now let's say I want to apply color in it on the basis of country. So let's drag the country pill to the colors card. So here we are with a word cloud, which analyzes that which wine variety is most popular across the countries. And in this case, you can clearly see that the winner is Pinot Noir. Moving on to our next trick. Diverging bar charts. So these types of charts are useful when you want to compare survey results across two measures. In this example, we'll look at the trend of male versus female population of Bermuda across different years. So to create the diverging bar chart, I have plotted my male and female population in the column shelf and year in the row shelf. Now we'll double click on the male pill and add a negative sign to it. So adding a negative sign to the male pill reverses the direction of the male chart. But now we have got some negative values on our axis. So to make this right, simply right click on the axis and go to Format. Under the Axis pane, go to Numbers and select Number Custom. Reduce the decimal places to 0 and the display units to thousands, similar to the female axis. Now go to Custom and remove the negative sign just after the semicolon. Now when you do this, you will see that your axis is similar to the female axis. Now we can simply edit the axis and remove this negative sum of male and replace it by male. So now we have got a nice layout for our diverging bar charts. So now let's add some colors into it to make it more attractive. Let's add the female pill to the colors card of the female chart and male pill to the colors card of the male chart. Let's say I want to represent females in red color. So simply edit the legend and select a red color from it. So this is the fastest way to create a diverging bar chart. So these charts help declutter a grid bar chart, making the data more engaging and easier to understand. Moving on to our next trick, replace references. Let's see what are replace references. So in this chart, you can see that I have plotted my month alongside my earnings. Now let's say that your enterprise in which you are working chooses some other measure for depicting earnings. Let's say they renamed earnings to profit. So we'll quickly go to the data source and rename the earnings column by profit. Now we'll save the data source. The next step is go to Tableau, right click on the data source and hit refresh. So as soon as you hit refresh, you will see that the earnings pill turned red in color, which means that Tableau is unable to locate this pill in your actual data source. Now let's say that you have used the same pill in many sheets and now you have a humongous task of making the change in each one of them. So this is where replace references come into play. So you can just go to the red pill, which in this case is earnings, and from the drop-down menu, select replace references. So over here, you will find the new field, which was profit. So simply select profit and click on OK. So Tableau will automatically replace all the instances of earning by profit, making your life easier and saving you a lot of time. Now moving on to our next trick. Our next trick is assign palette. So did you guys notice that the month of Jan is appearing red in color in my chart, whereas all the other months are appearing in a different shade of blue? Now instead of assigning colors one by one, you can directly assign the whole palette instantly. Let us see how. So I have plotted my order date in the column shelf and sales in the row shelf. So to apply color, I'll first drag order date to the colors card. So right now each of my month is depicted with a different color. Let's say I want them in a shade of blue. So go to the color legend and select edit colors. Select the blue palette. Now by pressing and holding the shift key, select January and then December. You'll see that all the months get selected. And now click on Assign Palette. So when you apply this, you will notice that Tableau automatically assigns each of the shade to your months. So you don't have to do it manually one by one. Now let's say I wanted Jan in red color. So simply select Jan and select red color from the legend and click on OK. So this is how you can make use of the Assign Palette function in Tableau. Now let's say you want to plot profit also alongside sales. And there are many measures and you are unable to find profit in it. So the conventional way to do that is go to the search bar and search for profit. You'll see that a profit pops out as a search result. Now another easy way to do this is simply double click on the row shelf and type sum of profit. So you will see that Tableau automatically finds profit for you and plots it on the chart. Now moving on to our next trick. Our next trick is a multicolored area chart. So area charts usually appear only in a single color format. But suppose you want different colors for your negative and positive data. So let's see how to implement that. So I have my order date in the column shelf and sum of profit in the row shelf. Now I'll copy the profit bill into the row shelf. Now you'll see that we have got two rows of profit. In the first row, we'll right click on the axis and go to edit axis and make the fixed start equal 0, which means that it will only show us the positive values of the chart. Similarly, in the second row, right click on the axis and go to edit axis and make the fixed end equal 0, which means that it will only show us the negative values. So right now my positive and my negative values are depicted by two different profit bills. So we can color them separately. Let's say I want green color for my profits and red color for my losses. So this is how you can apply multicolor in your area charts. Now let's see how to customize your area charts more to make them stand out and make them more attractive. So we already know that the color gradient does not apply to the area charts. So in this case, what I have done is applied the color gradient on the line chart and I have enclosed my area chart within it. So let's see how to implement this feature in Tableau. So I have plotted my order date in the column shelf and a running total of profit in the row shelf. Now we'll again duplicate the profit bill and this time we'll make it a line chart. So you can see that we have one area chart and one line chart over here. So now we can add profit to the colors card of the line chart to apply the color gradient. Now let's make these charts a dual axis chart. So as soon as you click on dual axis, you'll see that your line chart automatically encloses the area chart. Now we can remove the extra headers to make it more attractive. And to highlight your line chart more, we can reduce the opacity of the area chart or even change the color. So this is how we can play with area charts in Tableau. Moving on to our next trick. So in this trick, we'll look at how we can play around with labels in Tableau. So you can see that I have right aligned my labels inside the bar chart. So let's see how to do that. So I have plotted my sales in the column shelf and region and segment in the row shelf. Now if I simply drag the sales bill to the labels card and go to the alignment options, you'll see that I have three options over here: left align, center align, and when I click on right align, the labels go right outside the bar chart. So now we'll see that how to make them right align inside the bar chart. So let's remove this bill from here and duplicate the sales bill in the column shelf. And now we'll make it a dual axis graph. Always make sure to synchronize your axis. Now we'll make one of the chart as a bar chart and the other one as a Gantt bar. Now we'll add sales to the labels card of the Gantt bar chart. And in the alignment option, align it to left hand side. Now you'll see that my labels are right aligned inside my bar chart, but my axis now shows us the negative values. So to get rid of the negative values, simply right click on the axis and go to edit axis. And under the fixed range, select fixed start to 0. So now we have got rid of the negative values. Now to make our chart more attractive, let's remove the headers and edit the labels. Let's make them white in color so that they are more visible. So this is how you right align your labels inside the bar chart. Moving on to our next trick with labels. Labeling only the top end bills. Let's sort this result first. Now when I make use of my parameter and let's say I'll type 5 in it, you'll see that Tableau automatically returns 5 pills in colored format along with labels, and rest all the pills are grayed out. So now let's see how to implement this trick in Tableau. So I plotted sales in my column shelf and subcategory in the row shelf. Now first let's make a parameter and let's rename it to top n. Select the data type as integer and click on OK. Now go to the drop-down menu of parameter and click on show parameter control. So let's type 3 in my parameter. As we can see that our parameter doesn't do anything. So we'll create one calculated field for it. We'll rename the field as top n to color and type rank sum of sales less than equal to top n, which is the parameter we just created. Now when I drag this top n to color pill to the colors card, you'll see that Tableau automatically returns 3 fields in the colored format. Let me first edit the colors to make it more attractive. Let's say I want the grayed out results. So let's select gray for false and red for true. So now the next step is to apply labels to the colored fields. So to apply labels, we'll create another calculated field. And we'll rename this one to top n to label. And type if top n to color, which is the calculated field we just created, then sum of sales, because we want to depict sum of sales as labels. Now when you drag this top n to label pill to the labels card, you'll see that Tableau applies labels to the top 3 fields.
So our first case study is going to be based off of a data set on FDI, or the foreign direct investment. For those of you who aren't aware of this term, a foreign direct investment, or FDI, is an investment in the form of a controlling ownership in a business in any country. Now, this is by an entity based in another country. It is hence distinguished from a foreign portfolio investment by notion of direct control. Now, we are going to be dealing with a data set which has various different sectors and the direct investment in them over the years. Now, if you're a company or a startup and you want to venture into a certain economic sector, you obviously will look at the sector which is most profitable to you. Now, our case study is based off of that. We shall look at various sectors and determine which of those will prove most beneficial to collaborate with as a company, as a venture. And we are going to answer a couple of questions along the way, like the maximum and minimum direct funding for a given year. We are going to also find out the trends for direct investments for different sectors and how they can be grouped or clustered together. We are also going to determine the sectors with the highest and least growth in the last 5 years and sectors which have a little shaky performance throughout the years. We're also going to find out if there is any correlation between certain sectors from an FDI perspective, and are there specific clusters to present the data. And finally, we'll try to forecast the trend for the following year. With that said, let's move on to our Tableau start page and then connect to our data. All right. So this particular file is going to be an Excel file. So I'm just going to go to where all my files are. And this might take some time, so kindly be patient. Okay, now this is our data. As you can see, the first row has sectors followed by all the other rows, which are basically fiscal years and the amount of direct investment per year. Now, as you can see, apart from all of these data cells that we need, we also have a few extras like showing 1 to 64, Power by Visualize, some rows that we do not need, even the ones on top. So what we can do is we can click on this option which says Clean with Data Interpreter, and now finally we have an automatically cleaned data set where we have all the columns and rows that we need. You have all your sectors, you have metallurgical, you have mining, power, non-conventional, coal production, so on and so forth. You have diamond, gold, ornaments, tea and coffee, miscellaneous, and you have the grand total. And then you have the direct investments made in those sectors along the years. Now we have data starting from 2001 to 2017. Now another thing is that we don't actually need the grand total, because here we are trying to find out which sector will give us most profit. If we don't take out the row grand total right now, Tableau is going to start considering it as a sector of its own. So for that, we are going to add a filter. You can always go back to your Excel sheet and clean this up, but my purpose here is to show you how you can do it with Tableau. So what I'm going to do now is I'm going to add a filter. I'm going to click on sectors and then click on exclude. I'm going to check the box exclude right here, and I'm going to search for grand total. Here it is. So I've excluded the grand total row from my data set. I'm going to click on OK. Now this is the simplest way in which you can clean your data in Tableau. You can also go ahead and click on this link to review the results. What this is going to do is it's going to open an Excel sheet where you have the key for the data interpreter, the data that it has selected to keep. You can look at all those things right here. You can look at the data subtables. Okay. And when you go back to the key for the data interpreter, you can see the different patterns and colors of the cells and what they indicate. For example, the red line indicates that the data is interpreted as column headers. And if you go here, you can see that the entire row number 5 is basically used by Tableau as header. And that's all there is to it. Let's close this and go back to our Tableau dataset. Now let's look at what we can determine using the data that we have. Now before we begin, I'd also like to point out something, that the data we have is presented in a wide format, which is usually the most common type of representation of data. Government data sets and institutional data sets are usually presented this way. Now the problem with this type of format is that it is good for viewing purposes if you're just going to go ahead and look at numbers, but from an analysis standpoint, this quite doesn't hold. So what I'm going to do is I'm going to convert it into a long format. So I'm going to start out by clicking on the year 2000 to 2001, and then I'm going to go all the way to the end and press Shift and click on this. This is going to select all of the year columns. Then on any column, I can just right click and select the option Pivot. And as a result of that, we have 3 rows. Now what I'm going to do is the sector remains sector. Pivot field names I'm going to rename into year, and the pivot field values I'm going to rename into FDI. Now what happens if we do this is now we are going to get all of our columns under dimensions, through which we are going to have a little more freedom to play around with our data, which would not have been possible if we had chosen the wide format to work with. Yes? Okay, so another issue I have is the representation of year. Here, the year is given by a start value and an end value, which I think I'm going to change. Now, this is great for viewing purposes, but I wouldn't prefer it for carrying out data analysis. Now, this might differ from case to case, and you might feel differently. There's nothing wrong with this. It's perfectly fine. It's just not in a way in which I would prefer it. So what I'm going to do is I'm going to add a calculated field. Since we've already named it year, I'm just going to call it fiscal year or financial year. You can also call it FY. And we should be using a function known as left. So I'm going to put in year, comma 4, and at the bottom it is going to show the calculation is valid. So basically what I did was I'm excluding all characters from the left after the fourth space. So when I apply it, you can see my fiscal year only has the first 4 characters of every year, which is 2000 in this case and 2001 in the next. And now I have no use for this particular column, which is the regular year column. So I'm just going to hide the column. Now I have all 3 of my columns ready to go, and I think I'm pretty satisfied with my data. With that, I'm going to move on to my worksheet. I can see all of my dimensions and measures here on the left in the data pane. Now, for those of you who are new to this is what a Tableau worksheet looks like. On the left, you have all your data in the form of dimensions and measures. We're going to play around with that. And then you have a couple shelves having rows and columns, which is exactly how it is in Microsoft Excel, except for here, you can be pretty specific and drag your dimensions or measures into rows and columns, and your rows and columns are going to change from context to context. Then this is our canvas. This is where the visualizations are going to be viewed. And on the left, you have pages, filters, and marks. Now, these are the cards which are going to help us create more intuitive visualizations out of the ones we already have. On the right top corner, you have the Show Me option, and right now you can see a couple of grayed out visualizations. But once you have data appropriately input into the rows and column shelves, it's automatically going to highlight the graphs that you can make out of it. So yeah, with that, we can get started. Right now, I am going to go back into my presentation, and here you can see that I have already figured out a couple of questions that we're going to answer through this exercise. So first, let's focus on the first 2 questions, which is determining which sectors receive the maximum direct funding or the minimum direct funding for a given year. Both of them are questions of the same nature. So let's go ahead and find out. So basically now what I'm going to do is I am going to drag my sector dimension into rows right here, and you can see that all of this has been arranged in alphabetical order. It's not in the order that was presented to us in our data set. Yeah. Then what we're going to do is we're going to get our FDI value and drag it to our table. If you hover on the table, you can get the various FDI values. Now, all of these values are in crores because this is based off of India. For people who are based outside of India, 1 crore is basically 10 million. So you can go ahead and do the math. So the question said we needed to find out the maximum and minimum values for a given year. So I'm going to drag fiscal year into the filters, and here it's going to open up a fiscal year dialog box. I'm going to go down, click on 2016, because in cases like these, we usually prefer the latest data. And I'm going to click on apply, and then OK. You can just go ahead and click on OK. And then if I go up and click on either of these sort buttons, for example, I'm going to click on the sort button for descending order, you can see that my entire sheet has been arranged in a descending order. And now I can see that the 5 sectors which get most investments include the services sector, telecommunications, computer science and hardware, trading, and electrical equipments. And at the bottom, we have photographic raw film and paper, mathematical surveying and drawing instruments, defense industries, coir, and coal production. Now, this is a great information if you're suppose an analyst or you conduct market research. This is actually great information that you could go ahead and give to your managers so that they know which industries to invest in. Of course, this is not the only factor. There are going to be many factors which we are going to discuss through the course of this project. but this is simply one of them, and the most fundamental, if I might add. So now if you want to take up this list to your manager and say, sir or ma'am, these are the industries in which we should invest, you obviously would not take the entire list to them. Obviously, you would take the top 5 or maybe top 3, top 10 of the sectors that deserve to be invested in, right? So for that, what we need to do is go on filter, go to edit filter. Here we're going to select all, and then go to top and click on the option by field. As you can see, it says top and then it says 10. I am going to change this to top 5 and change the sum to maximum. And I'm going to apply that value and click on OK. Now, you might have noticed that the order of the sectors has changed, and that's only because we have selected all the years instead of just 2016, which was previously selected. So you will see right now that the top 5 is not being filtered out. And that is because we have not filtered out our sectors. So we're going to drag the sectors into the filter. And then we are going to this tab called top. Select by field again, top 5. And then apply it. Okay. And now in front of you, you have all the top 5 performing sectors in which there have been most foreign direct investment. And I'm also going to rename the sheet. Let's call it Max FDI because, it's always great to be organized. So with that, let's move on to our next worksheet. For that, I can just click on this new worksheet button, or I could do something else and I could duplicate the Max FDI sheet. Now, what happens when you duplicate a sheet is that all the filters that you have applied on the previous sheet, all the calculated fields, get copied along with the sheet, which is why this is a greater option if you have to make minute changes and don't want to apply all those filters again. So I'm going to rename this instead of Max FDI 2. I'm going to rename this into Minimum FDI. And all we have to do is we are going to edit the sector filter. And instead of the top 5, we are going to select the bottom 5 and click on apply. And here we have the bottom 5 values, which are industrial instruments, coal production, so on and so forth. So now that we have our maximum and minimum FDI sectors, next what we have to do is we have to see if there's a trend for direct investments for individual sectors. And what I'm thinking is we could make a filter for individual sectors. We should be able to filter out different sectors. So now to determine trends, I am going to move on to sheet 2, and I'm going to again rename this as overall trends. All right. So what I'm going to do right now is I'm going to drag my fiscal here to the columns and the FDI value to my rows. So almost intuitively, Tableau has turned this into a bar graph. But since we are showing trends, I think a line chart would be more apt. But if I drag down here to the line chart, either of the line charts, it basically says it needs one date. Here at the bottom, you will see requirements for a chart. So if I hover on line chart, you can see for lines continuous, try one date, 0 or more dimensions, 1 or more measures. Now we already have our date, so why aren't we getting the line chart option? Now majorly because our fiscal here has been imported as a text format. So basically we're going to go on the drop down arrow, change data type and convert this into date. And the moment we convert it into a date, it automatically turns into a line chart almost instantly. And we get the trends from 2000 to 2016-17 with our line chart. And it's a clear indication of what has happened. This also might be the reason that sometimes you might have taken up the date as one of your columns, but you still don't get the option for a line chart, you can go ahead and check the data type in which your date column is imported. And if it's not date, you can turn it into date or datetime, and you will open up the option for a line chart. Now what you can see right here is a couple of high points, 2008, 2011, and a couple of down points which start at 2008, the downfall, and go down 2009 and 2010. And I think it's pretty obvious because 2008 and 9, the fiscal year of 8 and 9, was actually the year of the global economic crisis and global recession. So it makes a lot more sense if you think about it that way. And then it shot back up in the year 2011 and carried on to our current fiscal year, which has most FDI value, 2016 and 17. Now, if you wanted to make the chart a little more interesting, what we could do is we could bring down the FDI values and maybe drop it on label. This way we have labels on all of our data points, and you can see how the FDI values have changed over time. It started with some 2,400 crores, and now it's at 43,000, nearly 500 crores, or you could call it 435 billion. You can see all the trends changing overall, the highs, the lows, the little bit of recovery after the 2008 debacle here in 2011. With that, we have our overall trends. Moving on. So now if I go back and see what next, I see that we have to find out the overall trend for individual sectors. So for that, we obviously have to use a filter. Let's go back and finish what we started in the overall trends. So putting up a filter is pretty simple. You can either drag your sector dimension into filters, and you will get a filter based off of sectors. Then you can select all, apply, click OK, and then you can right click on the blue pill which says sector and click on show filter. Then it'll show the sector on the right. Or you can simply click on the dimension sector, right click, and use show filter. Then if I clear all the check marks, I can just go on individual sectors and see how they have performed throughout the years. Let's take education, for example. As you can see, there has been great investment in education in the year 2013, closely followed by 2015 and 2008. But since we have applied this filter, this particular line chart type is kind of odd to be looking at. So what you can do is you can click on path in the marks card and select the kind of line you want in your line chart. So one of the options is this jump line chart, but what I really like is the step line chart. Here you can see individual rises and falls of every sector that you choose. If I cut out on education and if I click on the search button here and select maybe railway, even railway has seen massive growth between the years 2013 and 14. I wonder what happened. Was it the year of the election? Was it the year after? I am quite leaning towards a change in political parties in power. If you guys know what happened in 2013 which affected this change, do let me know in the comment section below. Maybe let's try food. Click on food processing industry again. Between the year 2013 and 14, you can see a massive growth in the investment in the food processing industries. And with that, I go back to my general line graph. I think I'm going to keep it this way because I quite like the whole step line graph. It will also look good on my dashboard, I think. Okay, so now let's go back to our presentation and see what do we have to do next. So the next actionable item is to group certain sectors together based on similarities.
So I'm going to go on to sheet 4 and I'm going to get all sectors here. If I right click on the sector pill in the dimensions, you can see the create option where you get options like calculated field, groups and sets. I'm going to create a group, and here I'm going to find similar looking groups and group them into a single group. So I'm going to group agricultural machinery and agricultural services into one. I'm just going to call it agriculture. And similarly, I'm going to make a couple more groups just to show you guys. And once I click on apply, you can see that we have the groups that we had made earlier right up top here. And if we bring our FDI values, we have combined values from all the sectors that are present in one single group. And that's as simple as it is. So I'm going to rename the sheet as groups. So moving on next, let's see what else we have to do. Okay, so now we have to find out sectors which reported highest growth and highest decline in the past 5 years. For that, new sheet. And then I'm going to drag the sector dimensions into rows. And I'm going to drag fiscal year to the columns. I'm just going to drop the FDI value in there. And as you can see, remember the first few numbers so you can see the change happening. What I'm going to do is I am going to change the measure from sum. I'm going to go on quick table calculation and change it from sum to year over year growth. And now, as you can see, all of the numbers we had changed into percentages, except for 1 year, which is 2000. And obviously, you cannot see year over year growth for 2000 because we do not have the data for 1999. So now we're going to drag our fiscal year into filters. And now you can see we have our latest 5 years, but 2012 is not going to show any values. It has a completely blank column because of the same logic that I had mentioned earlier when all the years were in display. Because we filtered out all the years before 2012, by that comparison has no year-on-year growth. So we are going to change the top 5 into top 6. So we actually get our top 5. And voila, we have 2012 through 2016, and we have the latest years. And now what I'm going to do is I'm going to click on this row, 2016, and sort everything in a descending order so we can get our top 5, which is glue and gelatin, cement and gypsum, scientific instruments, electrical instruments, and telecommunication, which are giving us the most year-on-year profit. And then I select this filter and go on top 5, and this displays my top 5. Now that we have our top 5, let's duplicate this so we can find out our highest decline, in which case I am going to change this filter, edit the filter, and instead of top, I'm going to go for bottom 5 and apply. And as you see, the bottom 5 sectors are defense, photography, mathematical and surveillance, choir, and coal production. What happened? Defense industries in 2016, almost a negative 100% growth. It's kind of a shame. People, please go join the defense. I could if I would, but I can't. But you guys can. So go give the direct investment something to invest in the defense. So with that, we have our highest growth sectors and our highest decline sectors. So next, as far as I can remember, we had to show maximum variance. For this, I am going to rename the sheet. I'm going to call it variation. And one of my favorite charts to do that, to show variation, is this box and whiskers plot. I can never remember the name. So what I'm going to do is I'm going to drag sectors to columns and FDI values into rows. And then I'm going to go into analysis and uncheck the box. Okay, so I basically switched them up. I kind of like this view better. Then what I'm going to do is I am going to arrange this in a descending order. Here, if I hover over a certain box, I can see the upper whisker, upper hinge, median, lower hinge, and the lower whisker, which obviously clearly is a lot for the services sector. But I'd like to point out something more interesting. If you see the second and third boxes, now the second box has an upper whisker of 2613 and the median is 872. The third one, which is constructional development, clearly has a higher upper whisker, but the median is lesser than that of computer softwares, which is actually why it comes on number 3 and not on number 2. And things like that are what make these statistical graphs more interesting. These are also called the 5-point graphs, basically because they give you 5 points from a separate sector or factor or whatever your data is. So we have our maximum variation, which is the services sector, and the minimum variation, which is this COIR or QA or however it is pronounced. I don't know. This is a Tableau video. Moving on. So next we are going to find out what is the proportion of investments between sectors from the FDI's perspective. For that, very simple, we are going to have a tree map. I'm going to move on to the next sheet and rename it as portion of FDI. And for that, basically, I am going to give sectors and FDI values. And I'm going to select the tree map, and it makes everything pretty visible. So I'm pretty happy with that. You can also put fiscal year in the filters here. Show filter on the right. Here you can see the filters. Now you can see year by year proportion of investment in a particular sector, let's say computer software and hardware, was at top of its game in 2005, but in 2016 it was taken over by services sector. I think this is the clearer of the graphs. So now that we have the proportions of investments, let's move on. So there's a lot of visibility in here. We can see telecommunications, trading. So moving on, let's see if we can find out specific clusters present in our data. For that, I'll bring in the sectors. And obviously, we are going to bring the FTI values in here. Now, if we switch from the data to the analytics pane, you can see in the model category, only cluster is enabled. So what I'm going to do is I'm going to drag the cluster and bring it right here. If you see on your right, it automatically has made 11 clusters on its own, but here you can add the number of clusters that you would like
3, 4, 5, 7, any number of clusters. But simply put, this is basically going to categorize all of your sectors based on similar properties. So now we are going to close this, and you can see from our data, Tableau has picked out 11 clusters. That means all of our, I think, 100 or something, nearly 100 sectors can be categorized into 11 different clusters based on their similarities and how they attract their direct investment. And the values are color coded according to the clusters. But this is going to take me a lot of hard work to sift through, and I can't even imagine showing this to somebody else, for example, my manager or stakeholders of the company. So what I'm going to do is I'm going to click on the Show Me tab again, and at the bottom I have Packed Bubble Chart. I'm going to select that, and this makes it way more visually appealing. We can see how many of our sectors are colored in the same color, which represents the cluster they are in. You can see that cluster 9 and cluster 11 have just one sector each, while cluster 5 includes computer hardware, construction development, and telecommunications. It's pretty self-explanatory. I think we can also filter out the clusters. Let's see, what is cluster 9? Cluster 9 is the power sector. Pretty understandable, isn't it? And cluster 11 is the automobile industry. Yes, again, pretty understandable. Now, finally, we have to forecast the trend for the following year. And for that, we are again going to open up a new sheet. I'm going to name it Trend Forecast. So again, for the last time, I am going to get my fiscal year to the columns and FDI values to the rows. And it automatically, within a matter of seconds, turns into a line chart. So if I go into the analytics pane again and click on forecast, and I drag it to my canvas, it almost intuitively, immediately gives me a forecast for the year 2017. The end of year 2016, it says the value is going to drop to 39,000, and in 2017 it's going to be 41, and 2018 it's going to be 44,000. Now this is just an estimate with the upper limit and lower limit grayed out in a lighter blue shade for the next 2 years. Now, what could be fun is maybe if we could find out, say, sector-wise forecasts. So I am just going to add a filter, and let's see. I work in IT, so I am going to check the computer software and hardware. And it seems like it will go from nearly 6,000 crores to almost half. That's kind of sad. Now let's move on and see something else. Let's see what our leading sector has to offer. Let's select services, and it comes down almost significantly as well. So another way of doing this is the trend line. So in the analytics pane again, you're going to drag the trend line and add a linear trend line. This basically is a linear equation. It says to get the FDI value at any given certain point, you have to use the equation given for FDI value, which is a pretty big number. The R squared value is 0.79 or 79%, which basically means you can depend on it. And the P value is 0.0001, which, let me tell you, according to hypothesis testing, if it is less than 0.05 or 5%, you can basically depend on the value. Some basic statistics, and that's exactly how you can forecast the direct investment per sector for the coming years based on the data that you already have. Now, there are many other methods through which you can do this. Now, this is just by using this BI service. And with that, we've answered all of our questions. Now, all there is left to do is create a dashboard for presentation purposes to your manager or your stakeholders or your customers, whoever you might want to show it to. So for that, I am going to create a new dashboard, and all we have to do is drop sheets here and resize them as we go. All right, with that, we have our dashboard. This is our page 1. I've added a text box here, which gives us the name of our overall workbook. I've named it Insights on FDI Data. You can name it however you like. We have the proportion of FDI, the clusters, the trend forecast, and on page 2, we have our overall trends with highest growth and decline. We have individual filters on each of the pages and individual cluster filters on page 1 with indicators of the forecast here as well. With that, we come to the end of our FDI case study. With that, our project 1. Let's move on to see which case study do we have next. Now for our second case study, I have a data set of the Boston real estate. Now, this was a data set which was taken maybe in the 1960s to see how different factors, different parameters are involved in the real estate prices in Boston and understand the correlation between various parameters with each other. Through this exercise, we will try to find out how crime affects the price of real estate, how is the age of the building or the proportion of owner occupied and establishing building affect the price of the estate, how are number of rooms related with the price of the flat you take, and how these rates vary in time. Basically, we are going to create a couple of KPIs which are going to help us make a decision regarding purchasing a plot in said real estate. So without much ado, let's move on to our Tableau desktop. Here I have already connected to the data. It is a CSV file, and here you can see all the different variables, all the different columns which have different parameters. We have crime rate, we have the NOx rate, we have age of the buildings, we have tax, we have the pupil-teacher ratio, we have the proportion of lower income class people living in a certain area, and finally we have the median price of said plot. So we are basically going to find out how do people in the industry determine the prices of a certain plot in Boston. Pretty simple. So with that, I'm going to move on to the first sheet. You can see all your variables, all your measures here on the left as usual. So on sheet number 1, I'm not going to create any visualizations. I'm going to start out with clarifying all the variables and what they mean. And I'm going to put it up clearly here in place of its sheet name text. And I'm also going to rename this sheet to variables. So because I know all the names of columns are not very clear, here I've put them up clearly. Okay, let me just quickly put in some So here I have specified what each of the variables stand for. So the first one is per capita crime ratio. Then ZN is proportion of residential land zoned for lots 25,000 square feet. Then next we have proportion of non-retail business acres per capita. Then we have NOx, which basically weighs the concentration of nitric oxide in parts per million. Then we have average rooms per dwelling. Then we have proportion of preoccupied houses which were occupied before 1940. Then we have distances to Boston employment centers and again distances to radial highways. Then we have the full value property tax per $10,000. Then we have the pupil teacher ratio per capita. Then we have proportion of segregated minorities as well as lower income class in every area. And finally, the median value of homes in a particular estate. So now that we know what all of our columns stand for, let's go ahead and start visualizing. So let's start out by opening a new sheet. So first I'm going to bring in the price or the median value into rows, and then let's see its relationship with crime. Now, as you can see right now, we can only see one data point. If this is happening with you, all you have to do is go to analysis and uncheck the aggregate measures box. So it gives you an unaggregated view or an unaveraged view on your screen. You get to see all of the data points that exist. So suppose I don't want to know about crime. I will want to see where the median pricing moves if I correlate it with pupil-teacher ratio in every school. And here we can see there's no such rising or falling relationship. Let's try something else. Let's bring taxes. All right, as we can see here, we are getting somewhere. So once we have our average number of rooms per dwelling, we can see that it shares a positive relationship with the median pricing. So now basically I want to give this power to my user. I want all these visualizations to be at his or her disposal. So what I'm going to do is I'm going to go to the dimensions pane and click on this drop down arrow and click on create parameter. So I am going to call this measure of interest. And keep the data type as string. Click on list. And I'm just going to add as I go, but currently I am just going to put in some of the main measures. So let's see: age, crime, average number of rooms, tax, nitrous oxide, teacher ratio, and like radial connectivity. That's very important. Then I'm going to go right click on the parameter. Once your parameter is created, you can see it here at the bottom under parameters, and I'm going to right click and click on show parameter control. So then you can check out your measure of interest and how it relates to the pricing of a particular area. But you will notice that this is not working right now. And that is because we have forgotten to establish a connection between said measure of interest with the pricing. So again, we go to dimensions and we click on this arrow and create a calculated field. We'll just call it So we're going to write a case statement, a pretty simple case statement. Basically, what we are trying to tell Tableau is that when we are selecting a certain option, we need it to use that option as your column input. Let's see, what all have we put in our measure of interest? There's age, crime, tax, NOx, PT ratio. Right? And finally, we are going to end it with an end statement and apply it. Here on the left under measures, you can see measure of interest, which is our dynamic measure. And then we are going to click on OK. Then we're going to switch out this column from rooms to measure of interest. Remove this. And then we're going to see if our pricing is in average. So for these kind of analysis, usually your pricing needs to be in average. Everything else also needs to be in average. And that's it. Now let's see how tax affects your pricing. followed by crime affecting your pricing. As you can see, where there is zero crime, the prices are really, really high, which is very obvious. And here is the radial distance to your highway, pupil-teacher ratio, which is kind of more evenly distributed along the canvas. And that is how you create a dynamic measure to determine the effect of various parameters on the pricing of a certain plot. Now that answers the first few questions in our case study. Next, we are going to see how do rates fluctuate based on the crime rate in an area. So here I'm going to introduce you to something known as bins, where basically you are going to create bins of say 3 or 4. You're going to club 2-3 numbers together, create categories basically. So here I'm going to introduce you to something known as bins. Bins are nothing but ranges. Suppose your crime index is on a scale of 10. You can club the first 3 together, then the next 3, like 0 to 3 together, 3 to 6 together, 6 to 9 together. That's how you're supposed to read bins. So here is the green pill, the crime pill. I'm going to right click, go to the create option, and then bins. As you can see, it automatically suggests bin size as 3.3. I am going to keep it as just 3. Then OK. And right up in the dimensions, you can see that the crime bin has been created. So I'm going to bring this to the columns and then put in the price for rows. And it automatically brings me this bar graph. But here is one column with null value, so we are just going to exclude it. Yeah, but I'm still not happy with the representation. So instead of this, I'm going to change it into a box and whiskers plot. I'm going to make a few changes, bring this right here. But as you can see, this does not open up. So if you face a situation like this, so you can basically go up to the median pill and select dimensions, and that will give you the proper cats and whiskers or the 5-point plot. And it happens so because dimensions, this option that we selected, the dimension option basically brings out all the points, whereas a measure aggregates all the points to 1. Yes? Now you see the median price of an area which lies in the crime index 0 to 3 is as high as $23,000. And here are a couple outliers which go even higher, and the highest price somebody is ready to pay is $50,000. And this just gets lower and lower as crime increases, and you can see there's a direct relationship between crime and pricing of a certain plot. And you can do this with all the other measures that there are, but crime rate or crime index is a really important parameter for people to choose a locality in which they want to live. So now let's go ahead and add a few metrics to this workbook. So for the KPI, I am going to drag out the measure names pill here and then maybe the measure values. This immediately gives me a bar chart, which is okay, but I don't think it's an apt way of representing this data. So I am going to convert it into a metric form, a table form. Also, for the sake of creating a dashboard later on, I am going to swap out the rows and the columns, and this gives me a swapped version of the previous metric chart, and I can choose to pick as many or as few of the parameters to display in my dashboard. Also, it doesn't really make any sense that all the measure values are there in our sum form, so I am going to convert them into average. You can see all your metrics change. This makes more sense. I'm not interested in all the measure values, so here I'm going to keep only my top 5 measure values, which I think is relevant if I had to pick a house. So age of occupancy is really important. Rest. This I'm going to remove. Crime distance. The dynamic measure also I'm going to remove. All right. Now, how do you make use of it? What I'm going to do, I'm going to bring out the price into the filter. And hence you can see all the values, pricing. Suppose I'm interested in a house between 15 and 25,000. Here I can see my average crime rate is 1.8. Average distance to a workplace is 4.1. I have average nitric oxide in the air, pupil-teacher ratio, so on and so forth. And that is how you turn these basic metrics into key performance indicators to make decisions on whether you want to buy a plot in a certain area or not. And this can be used to create an application out of it for user benefit. Suppose you're working in real estate or your company has stakes in it, you're an analyst, you have to conduct your market research. This is how you can give all the power to the user and enhance user experience using Tableau. So how to enhance this metric further? What I'm going to do is I'm going to create a calculated field and call it crime indicator. And here I'm going to write a very simple if statement based on the crime bins that I created. So let's see. Crime is less than equal to 3. Then it's going to display low. Crime is less than equal to, say, 8. Then moderate. Is equal to else high. All right. So now we have our crime indicator. This makes it easier for your viewer and enhances user interaction with this particular application. It also makes it easier for people to read out rather than looking at lots and lots of numbers on your table. So I'm just going to apply it and click on OK. So for this to show, I'm going to open a new sheet. So I'm going to select this crime indicator and the price. And this table does not do it justice. I'm going to make it a pie chart, and to make these colors more indicative of the crime in a certain area, I'm going to change. For high, I'm going to keep it red. For low, I'm going to keep it green, and for moderate, let's keep it yellow. Let's turn them into a complete traffic signal. I'm going to apply it, and as you can see it in the crime indicator box in the right. Also going to bring the price filter out and show filter. Okay, so now if I set up a range, say 15 to 25, you can hover over it and see the crime indicator for different median values. Moving on, let's see if we can find out an equation between various factors and the price. Go on new sheet. And equation. And here I'm also going to bring in my price, and I'm going to pick crime again. And this will give me a scattered chart. What I'm going to do is I'm going to go to analytics and select a trend line under the model. And my scatter chart looks more like logarithmic chart, so I'm going to use that. And you can see when you hover over the logarithmic line, you see an equation for crime, and you also find the r-squared value and the p-value. The r-squared value is 0.28 and the p-value is again less than 0.05, which is 5%, which means that you can trust this equation. This is a usable equation. Now, if we switch, let's see, the crime for the Knox value, you can see the equation has changed. The r-squared value has come down to 26. So now basically we are trying to predict the Knox value, but if I go ahead and swap the two, here you can see how the increase in NO2 affects the price of a certain real estate. If I go up here on the line, and here you have the logarithm, and if for a moment I change this into a linear model, you can see a formula for your price of a certain estate, which is minus 33.9161 times Knox plus your 41.34, which is nothing but an intercept with your r-squared value at 0.18. This basically is how much your Knox value is going to affect your pricing. And then you have your p-value, which, as I had explained before, is the value you get from hypothesis testing. Now, this worksheet is a great way through which you can find out how certain factors affect the pricing of real estate. I have taken Boston, for example. You can pick any data set that you like. You have your equation for predicting price based on the Knox value. Your r-squared value is 0.18, which just means you can barely use this variable as a complete indicator for price. You have your crime indicators. You have your metrics for the 5 most important things people look at while determining the pricing of a certain real estate. You have your crime rate versus building pricing in boxes and whiskers plots. Here you have your dynamic measures affecting the price, and this is your personal help page for all the variables. All in all, this is a pretty useful method to make decisions by creating key performance indicators and dynamic measures. Let me go back and check if I have uncovered the entire case study, and I have. So to conclude, we basically studied a data set which had multiple factors affecting the prices and the outcomes of pricing on multiple parameters in a certain area. And we understood the correlation between parameters and its rates. With that, let's move on to our next case study. So the third and final case is based off of a data set on IMDb. Here we are going to conduct statistical data analysis or exploratory data analysis on the data set and understand the relationship between different parameters or factors in the data set. We have a couple of movie budget and revenue related questions, genre related questions. We also have a few correlation questions between the revenue generated by the movie versus its impact on social media. So all in all, this is going to be not a step-by-step kind of a solving like we did for the 2 previous case studies. This is going to be focused more on the implementation side. It's going to be slightly more fast-paced since we have already done like a step-by-step in the previous 2 case studies. I would assume it's safe to be presumptuous about you guys being able to catch up. So let's get started. So here's my data set. We have color or no color, director name, duration, Facebook like, names of all the actors. And if we go here, as you can see, all the movies have at least 2 or more genres separated by pipe separators. So we're going to right click and click on split. So now basically all the genre has been split into 3 different columns. But if you want more columns, you can just right click on either of these and select custom split. So I'm going to hide the genre. Here you have a few numbers from Facebook, the IMDb link, country of production, budget, so on and so forth. So let's look at our first question. Is there a relationship between movie budget and revenue? So we're going to start out with sheet 1. So normally we would assume that a high budget movies generally make higher revenues, but we can be proved totally wrong through this analysis. So let's go ahead and check it out. So let's go ahead and bring our gross versus budget. And here, as you can see, again, it's showing us only 1 point, which means we go to analysis and we uncheck the aggregate measures. But I still can't understand anything on the scatter plot because all of these points are so closely gelled in together. And we have a couple of outliers. We have 1 point which has a budget of, I don't know, 12 billion? Yeah, it's 12 billion, which I'm pretty sure might be a mistake on the typist's side, but maybe if I click on this and I go on detail, then I see that the movie's title is The Host, and it gives all the other factors and parameters for the movie. So what I'm going to do is I am going to put up a filter for budget. I'm going to show filter so I can drill it down to at least see some points. If I bring it down to 9 billion, we have these many points. And if I go further down, I can see all these points. And you can go ahead and make all of these changes. And this is how you play with data. And if you can't see your data points, it's a futile exercise. With that, let me open the second sheet and we'll go to the second question, which is about the duration outliers in various genres of movies. So for this particular question, I think it will be most apt to use the box and whiskers plot. So I'm going to bring in the primary genre and I am going to put that against the duration here. This brings down one of them. And as you can see, we see most number of outliers in the drama genre, but we have the most significant outliers in the crime genre, which let's see which movie this is. Oh, and it's the movie Trapped, and it's an Icelandic movie. So yeah, that's about it. The music genre seems pretty consistent. So does sci-fi, which is surprising. You can click on either of these points and check out which movies they are by clicking on View Details and look up those links and download them and watch. Who knows? You might just have a movie night tonight. We are going to rename this Duration Outliers. With that, we are moving on to our next sheet and next question. So according to this question, we have to find out the distribution of various movie durations. So for this, we are going to go for a histogram type chart. So I'm going to bring in the duration and I'm going to create a histogram, and as you can see, it is a basic histogram which is skewed a little bit towards the right, and in the duration bin of 99 minutes you have the maximum number of movies. Moving on. Now we have a couple of questions on social media's impact on the performance of a movie. We have the relationship between Facebook likes and the impact of it on revenues. We have relationship between the likes and IMDb voting. So we're going to go ahead and try all of that. So first, let's create our Facebook versus revenue. So we are going to call this. So we have a couple different like bins. We have cast total like, we have director Facebook likes, we have the movie Facebook likes, and this is the one we will be needing. And as you can see, we again only see like one. Yeah, and with this, you can see that there's actually a linear relationship between the gross revenue and the Facebook likes. Similarly, we had the question for Facebook versus IMDb voting. And we're going to do the same thing. We're going to go for the IMDb score as well as movie Facebook likes. And here we can see that the IMDb score actually affects the Facebook like. It's pretty linear till IMDb score 5, and then it goes up after 5 in a sort of polynomial like fashion. So if I can go on analytics and bring in a trend line, we can see it goes up in a polynomial like fashion. This will also give you a formula for the Facebook likes for a certain movie as well. It is a fairly long formula, but we're going to deal with it. So that covers our Facebook versus revenue and Facebook versus IMDb. Let's go on to our next question, which is to create a correlation matrix between various numerical data points. So correlation matrices actually comes off as really complicated in the end, but it's actually really simple to pull off. So let me start with two numerical data measures. I'm going to start out with budget and duration. By now, you know that if somebody is asking questions about two different numerical measures, the answer is always a scatter plot. Okay? So budget and duration. Now I'll just go on adding measures to it, and it will keep building various different plots, giving us a lot of information about everything that we need to know, correlating all of the different numerical measures that there are. Just go ahead and keep adding, and I'm going to change this to fit entire view. And all of a sudden, within a matter of 10 seconds, you have so much data, the correlation between duration, budget, gross revenue, the IMDb score, the Facebook movie likes with the duration, so on and so forth. You have so much information which is going to take you hours to make sense of. But what I had to show you is that within less than 10 seconds, we basically created this correlation matrix. Moving on, we have, this is an interesting question, is the genre budget changing with time? So what I'm going to do first for this is I'm going to search for the title here, and I'm going to change the data type into a date. Bring in the budget as well. And this automatically gives us a line chart, but this is for the entire budget. What we want is A, the average budget, and B, the budget per genre. So I am going to take the primary genre and I am going to put up a filter on the right. So we can see how the average budget has changed with respect to time for action genre or maybe animation genre. You have comedy, you have crime, you have documentary, you have neo-noir films, you have family, you have sci-fi movies, so on and so forth. Next, we have the distribution of IMDb ratings amongst various genres. So what we're going to do is we are going to create a bin for the IMDb score. And then we are going to bring down genre over here. All right. With that, we can see that action movies are leading the pack, followed by adventure, animation, biography, comedy, and crime in terms of IMDb ratings. Next, so what is the most revenue fetching category for a movie? So for this, we are going to do something very similar. So by category, we actually mean content rating. So content rating revenue. We're going to take content rating and cross. And then this is also a way, this is an okay way to show it, but there is nothing intuitive about it. There is nothing that pops in this. So what we're going to do is we're going to clear this out and we are going to go by year. Okay, and with that, we can see that PG-13s are actually making a lot of money, but what's making more money than that is the G rating. And with that, we arrive on our final question, which is to show Facebook ratings relationship with the movie rating. So again, this is our final sheet. I am going to take the IMDb score versus Facebook likes. And again, I hope this is coming back to you. Every time you have a question related to numerical measures, you are always going to go for a scatter plot. Let me show a trend line as well to show the positive trend. And it gives you a formula for movie likes, and we can actually duplicate this and then flip it over to again find a formula for IMDb score as well. And with that, we found out how various factors affect the budget and revenue of a movie. We have graphs for budget and revenues, duration, Facebook versus revenue, IMDb ratings, correlation matrices, the budget per genres, the IMDb ratings per genres, so on and so forth. And finally, we have a correlation between Facebook and IMDb and vice versa. You can go ahead and make a dashboard out of this, but this is all I had to show you. And this is just the tip of the iceberg of how you can explore data using Tableau.
Who is a Tableau developer? Now, a Tableau developer creates solutions for data visualization to enhance the business processes. This job comprises of various tasks such as working with developers, creating Tableau reports, creating BI visualization, and participating in feedback sessions to improve systems. Now, this job is perfect for people who work well as a part of a team and who have problem-solving skills that can manage their time productively to meet deadlines. A Tableau developer is usually someone that is proficient in data visualization, mathematical reasoning, database skills, and extract, transform, and loading processes. Pursuing a career as a Tableau developer can mean many things. A few of those I want to discuss with you today. First of all, the connectivity option you get. The reason why Tableau stands out amongst all the BI tools is that there is a wide range of connectivity options. Now, Tableau can connect to any data you can possibly think about, starting from spreadsheets to databases and even big data. You can access warehouses, cloud applications like Salesforce, and even connect to cloud database like Amazon Redshift. It has a web data connector, and it is used to pull API directly from web in order to connect to any desired data source. Now let's talk a little bit about pursuing a career as a Tableau developer. Tableau is known as the leader in BI tools, and it has been crowned the best by the IT research giant Gartner. Gartner's Magic Quadrant mentioned Tableau for the 5th time in a row as the best amongst Tableau's competitors like Microsoft, SAP, and Qlik. In addition to having a great demand for Tableau experts, there are always rewards to offer. If you browse through the job portals like Indeed and AngelList, you can find plenty of job postings. Tableau professionals get the best of salaries in the IT/BI industry with an average of $91,000 per annum. There are tons of jobs available which require Tableau as a major skill set. Now let's take a look at the responsibilities that come with this lucrative job profile. Now, Tableau developers' responsibility vary depending on the type of organization they work for. Here are a few job descriptions that I have picked out by major companies for a Tableau developer. This is the one by Cognizant, which says they want somebody with industry experience with hands-on in design and development of Tableau visualization solutions. They want somebody with creation of users, groups, projects, workbooks, and appropriate permission sets for Tableau server logons and security checks. Apart from this, they also want the professional to have strong data warehousing and business intelligence skills. Next, we have a job description by Bosch. They've kept it pretty simple. They want an engineering graduate with at least 2 to 3 years of experience on Tableau, minimum a year or 2 of experience on Tableau Professional or Analyst Software Suite, experience in desktop and server architecture, creation, configuration, and deployment of Tableau servers, in visualization and publishing, authorization concepts, along with some good communication and analytical skills. Apart from which, they want somebody with the experience in working with multiple data sources and handling large volumes of data. Next, we have a job profile by Tech Mahindra. They have kept it pretty simple as well. They want somebody with a strong understanding of advanced Tableau features, including calculated fields, parameters, table calculations, joins, and dashboard action. The shoes they expect you to fill generates Tableau dashboards with quick context global filters, parameters, and calculated fields on Tableau 10.x reports. Apart from which, from what I see, they need somebody with strong structured query language skills in building complex queries, triggers, indexes involving multiple tables from different database schemas. But all of these job descriptions basically boil down to these major points. A Tableau developer is responsible for creating technical solutions, which basically means the primary objective of this developer is to create a solution which matches the needs of the business. This can be done by finding innovative resolutions and translating their requirements. Another responsibility is working with data storage tools which preserve data within organizations. This is also known as online analytical processing or OLAP. Apart from which, they need to conduct tests for which they develop database queries and conduct unit tests to troubleshoot and analyze the issues that arise. This process is an ongoing part of the development that occurs continuously throughout the project. They also need to enhance systems, which is a crucial part of the job. It means they have to evaluate and improve existing systems. This also includes collaborating with other teams within the business to incorporate new systems to streamline company process and workflow. They also need to create technical documentation for completed projects, to communicate with senior staff members and colleagues within the organization for reference. And finally, they need to use BI technologies, structured query language, data analysis and ETL tools for storytelling and forecasting of data. Tableau represents data like no other tool with unique features like forecasting and storytelling. One can even connect to the data personally and understand the depth of the analysis. Having said that, let's move on to look at certain skills that are required to fulfill these responsibilities of a Tableau developer. Now, the required abilities to become a Tableau developer are as follows. A Tableau developer should have a bachelor's degree in business, computer science, or any similar field. They require experience in the whole life cycle development of applications at an enterprise level. They need to have proficiency with structured query languages in large data sets. They should have excellent analytical skills as they are needed to analyze the requirements of a client or a business. This role also demands to work with software from the beginning till the end of the project, so they need to solve any issue that occurs during the development stage. Apart from that, this profile requires the ability to create innovative solutions to problems within business. They need to be self-motivated for finding solutions and improvements to system. During the phase of the customer's testing and prototyping, they need to maintain strong attention to detail for spotting errors in data or coding. Having a knowledge of MicroStrategy and data architecture is a set bonus. And a little efficiency in written and oral communication skills never harmed anybody. Now, the skill set that I've mentioned is enough to make yourself fit for the position of a Tableau developer. There are many opportunities available in the IT market for candidates who acquire the skills that I have just mentioned. If you take a look at Google Trends, it seems like this is a wonderful time to get certified in Tableau. A Tableau developer's average salary, as observed for the year 2019, is about $111,000. But as I dug deeper into this situation, I realized that there are multiple facets to this one story. Tableau combines a laser focus of how people see and understand data with the kind of robust, scalable platform you need to run even the world's largest of organizations. Now, this makes a Tableau developer one of the most sought-after profiles in the BI industry, which also implies that acquiring a certification in Tableau will give you the credibility to meet industry standards. Therefore, it comes as no surprise that Tableau developers are coveted professionals across all industries. In addition to having a great demand for Tableau experts, there are rewards to offer as well. If you browse through the job portals like Indeed and Glassdoor, you can find plenty of job postings. Tableau professionals are also getting the best salaries in the IT industry with an average of $91,000 per annum. Now, there are tons of jobs available, so all you have to do is brush up your skills. With that, let's look at a few market projections and trends when it comes to Tableau. Now, if you take a look at Google Trends, it seems that this is a wonderful time for Tableau. As you can see, the demand for Tableau and its interest over time, as showed by people, has grown right from 2004. The rising trend for Tableau in Google Trends could be a testimony to the expansion in demand for Tableau professionals. It's one amongst the quickest evolving business intelligence and knowledge visual image tool. It's terribly fast to deploy, straightforward to find out, and extremely intuitive to use for a client. It's evolved into one of the quickest and simplest ways to share analytics with the cloud as well. So it should come to you as no surprise that Tableau professionals are getting paid recent average salaries growing to as high as $158,000. By 2020, the globe is ready to get 50 times the number of information as compared to now. In line with the study by the International Knowledge Corporation, with this large quantity of information and real business implications at play, business organizations across the globe have the necessity for a simple to use tool to research knowledge and derive unjust insights from it. Tableau helps organizations to do precisely just this. Therefore, the recognition of Tableau is predicted to travel through the roof. As the demand for Tableau professionals is increasing, there is a unit called Brobdingnagian rewards on supply additionally. Tableau professionals are becoming paid the simplest salaries within the trade with a mean of $106,000 per annum. The common salaries too are on an associate degree in an upward trend, with the recent average salaries growing to as high as $158,000. With that, let's move on to the salary trends by geography. So while we see annual salaries as high as $168,000 and as low as $53,000, the majority of Tableau developer salaries currently range in between $90,000 to $127,000 per annum across the United States. The average pay range for a Tableau developer varies very little, which suggests that regardless of location, it's pretty uniform. As you can see from the table in front of you, here are the Tableau developer salaries by location of 5 major cities in the United States. We have New York paying the highest salary at $120,000, and we have Houston, Texas at $80,000. Moving on, the same cannot be said for India though. While other IT hubs like Chennai, Hyderabad and Bangalore maintain their 8-point-something LPA average, New Delhi seems to have attracted better paymasters as it has an average of 12 LPA to offer to Tableau developers, as you can see from the graph in front of you. The column for Delhi goes way higher than its contemporaries. Now that we've seen the salary breakdown by geography, let's look at the same by years of experience. Now, the average Tableau developer salary in the US is nearly $55 per hour. While most of the entry-level positions start at $58,300 per annum, most experienced workers can assume even up to $180,000 per annum. Candidates in the 3 to 4 year experience bracket bag an average of $111,000 USD salary bracket, which isn't a bad number at all. Now, let's take a quick look at the current job openings for Tableau developers across the companies. So if you take a quick look at the current job openings, it reveals that more than just a few top companies are looking for Tableau developers. Now, these brilliant paymasters include but are not limited to Facebook, Dell, Capgemini, Wells Fargo, Vodafone, JP Morgan, PepsiCo, and Citibank. Not just that, you also have companies like Sony Electronics, SunGard, Bank of America, KPMG, and Verizon. Hence, if you aspire to work for the big names in the industry, a career in Tableau is the way towards it. Now that we know the companies that are hiring, we obviously should not take it for granted. Hence, before you apply to one of these companies, make sure you have your skills brushed up. Now, while Tableau developers should have an aptitude for data interpretation and are analytical in their approach to tasks, they must also have a strong business acumen. Typically, employees will require a bachelor's degree in computer science or information technology or any alternative of the same, as well as a few of the abilities that I have listed here, which are very specific to Tableau. First of all, using Tableau Desktop. Most of the job descriptions that come up online expect the candidates to have a deep knowledge and understanding of Tableau Desktop and Tableau Server. They need people with a knack of patterns and trends in numbers that are generated by the market and who are able to create beautiful and not to mention interactive dynamic dashboards with it. Apart from that, you also need to know how to deploy filters and parameters in Tableau, which will help you in the drill down of the data. Talking of drill down, you obviously ought to know LOD or the level of detail in Tableau. Now, the role of a Tableau developer often involves working with the Tableau software from the beginning of the project until its completion. So obviously, throughout the entire course of those few months, you won't just be making dashboards. You need to solve problems using those graphs. And for that, you need to drill down into certain details of the numbers that you're getting. For that, you need to know and have a deep understanding of level of detail and its expressions. Then you have to know how to use SQL queries in Tableau. Finally, you have data warehousing and ETL, for which you use ETL tools like Talent and Informatica. Now, this may or may not be a part of your job description, but a little extra knowledge did not kill anybody.
So the first question, why is there a need to go for Tableau in spite of having huge number of open source and less costly visualization tools? So some of the reasons which I have mentioned, this particular question has been asked by one of you, okay? And this question actually makes sense. Tableau has a lot of competitors, okay? So the answer is, first of all, Tableau is very, very easy to use. Dashboards are simple to build, even for a novice. Somebody who has never really worked with the visualization tool can learn Tableau easily. That is one big reason. Also, even for an end user, from an end user perspective, Tableau is very easy to use. So they have all the filtering capabilities, parameters, all at their disposal. You can provide your end users with these features and they can play around with the dashboard you have created for them. So adoption from a developer's perspective and from an end user's perspective, both is very high. Rapid visualization drag and drop feature. So Tableau has this drag and drop feature, which you can use for creating visualization very rapidly. Even very, very complex dashboard do not take months to create, which they usually do in some, if you're going to try some other visualization tool. Within Tableau, even complex dashboards you can create in matter of few days, okay, not even a week, I'll say. So it's just drag and drop, and you have to be aware of some advanced feature from time to time. You have to use them, but mostly it's just the basic feature which you are going to require most of the times. Now, the charts which Tableau provides you are very visually appealing. Okay, Tableau is based on best practices of visualization. It doesn't provide you 3D charts. 3D charts are not good. Okay, so this has been proven through different research that 3D charts and other those fancy charts, they are not good for visualization. Simple and visually appealing charts are best means to present your data. And Tableau is based on best visualization practices. It allows you to create visually appealing charts with vibrant, automatically generated colors. That is another reason. Tableau is very intuitive. You can customize, you can modify your visualization to a great extent, and once you practice Tableau enough, and I'm not talking about months and months of practice, I'm just talking about several weeks of practice. If you work like do 3-4 projects in Tableau, it will become very, very intuitive to you, because all the components which you utilize to modify a chart are right in front of you. So we have those shelves and cards where you need to drag and drop your values. If you want to show legends, they are right in front of you. You know how to do that. And if you want to change the color scheme, the option of changing the color scheme is right in front of you. So Tableau is very intuitive. I have tried to use QlikView and it was not that intuitive at all. In fact, if I compare it with Tableau, it doesn't stand anywhere in terms of ease of use and intuitiveness. Also, Tableau uses Excel-like formulas, and it's an easy transition for many, because many people work on MS Excel. And those of you who have already worked on MS Excel, and since I'm assuming all of you have learned Tableau, so it'll be an easy transition for you. Many of these formulas follow the same syntax within Tableau and Excel. For example, if-else formula. Okay, the syntax is more or less similar. We have date diff formula. All of them are used in Excel as well as Tableau. So easy transition. Then we have an active user community. Now this is one feature of Tableau which is not very commonly mentioned, but I'm going to mention it here. Okay, so as a developer, if you've worked on some other platform, some other programming language, you may realize that from time to time we have to depend on other users, user community. We have to Google our answer. Okay, we cannot just remember all the keywords, all the technicalities of the software ourselves. Either we have to keep like a thick reference book or reference manual, or we Google our answers up. So there is a need that your software should be supported by an active user community, and Tableau serves that feature. Tableau has that feature. So there's a very active user community which supports Tableau. Okay. Then Tableau has in-memory BI platform enabling high scalable and rapid visualization. Tableau is pretty fast. If you are working with large chunk of data, Tableau is not going to disappoint you. I mean, of course, if you're working with billions of rows of data, you have to optimize the performance of your dashboard. The response will be relatively slower than when you're working with smaller data. But just compare Excel and Tableau. There is no comparison. Tableau just doesn't compact your data. It actually handles the data much more faster. Okay. Ability to apply filters and date range on the fly. Of course, you can apply filters, you can filter out date range, you can show those filters right on top of your dashboard, and your end users can play around with those filters as well. Not only that, you can click on one portion of your chart and filter down other charts as well. So if you have made a dashboard, there are 6-7 different charts, you can click on one particular chart, other charts will filter down automatically if you have enabled those features. And Tableau works on user feedback. Now, again, this particular benefit of using Tableau is not mentioned commonly, but what I have seen is, I've been using Tableau for quite some time now, and I started using it way back, like I think from version 5 or 6, I do not remember exactly, but it was lacking a lot of features back then. And users were constantly providing feedback that this particular feature should be available, that feature should be available. In fact, we got this survey from Tableau where we provided our feedback, and several of those feedback which we provided, we saw that in action after a few versions. Okay. So now Tableau has an integrating feature with R. Tableau provides floating filters, floating containers. Earlier, these features were not available. But Tableau works on user feedback, and in coming few years, we may see most of the desired feature are available in Tableau. Right now, there are some limitations, as I mentioned, like ETL tool is not there. Who knows? We may see some ETL tool within Tableau itself in a couple of years from now. In fact, Tableau has started providing some data manipulation feature in the latest versions. All right, let's move on to the second question which we have: how to optimize the reports for better performance. Here I have put down certain pointers. This is not a limited list. This is not a complete list as such. Okay, as you keep working with Tableau, you'll realize that there are many more options which you can employ to fasten, improve the performance of your dashboards. So a recent test which was run side by side on two different machines running the same data pull from Tableau server. Internet Explorer 7 returned results in 11 seconds. Firefox returned results in 3 seconds. So the browser which you are using, that makes a difference. Okay, so when you're working with Tableau server, it's preferable to tell your users to use the latest browser, which is the fastest one. Okay, so it does make a difference. Second tip which I would like to share with you: if complex calculations are needed in Tableau, consider creating a DBMS view that does the calculation. The database server is usually more powerful than the desktop. Okay, so if you are going to filter your data, okay, if you're going to create some aggregation, you can do that right within your DBMS as much as possible. Are you aware of granularity of data? Okay, so keep in mind the granularity of your data. If you feel that you are not going to use data at a very granular level, at a very small level, if you are always going to use it at an aggregate level, go ahead, aggregate your data within DBMS itself, and then pull that within Tableau. It's always going to help. Okay, so Tableau doesn't have to do all that hard work of aggregating your data. Let's see if I can give some example here. Let's say you have daily transaction data, or maybe per transaction data. We are collecting data for a superstore. Let's say we have Walmart and we are collecting data for Walmart. We have data for each transaction. But the analysis which we are doing, that is happening only at a product level, or maybe at a daily level or at a monthly level. Okay, you're never going to go to a particular transaction level and analyze the data. You know that. already. Okay, so what you should do is you should summarize your data at DBMS level and then pull that data within Tableau. It's going to help. Does that make sense? And consider the use of pre-computer aggregated summary tables when large data set are required, typically when summarized when used. Okay, again, same point. You have to sort of like keep in mind the granularity of your data. If you are working on calculated fields, which are not going to change frequently, maybe row level calculation, some if else calculation which you are doing. Okay, you can do that right within DBMS. If you're aggregating your data, summarizing your data, do that outside of Tableau. It's going to increase your speed. Of course, these points are applicable only when you're working with large data sets, maybe beyond 10 million rows or something. Then it's going to improve your performance drastically. Otherwise, if the number of rows you're working with is less than 1 million, then Tableau will be able to handle that seamlessly. It's not going to be a problem at all. Also, you should turn off automatic updates whenever possible. So Tableau doesn't automatically updates your data. Instead of making a live connection, make an extract, update it manually whenever possible if you do not want auto refresh of the data. That's going to speeden up the things. So next point, use as few data sources as needed to achieve your analysis and remove any unused data source. We have this tendency, of connecting to different data sources. As an analyst, I can say this. I do it from time to time. I've seen other people doing it. Even if they do not need a particular data source, still they make a connection to it. Okay, because they might need it in future. If you're working with big data, do not do that. Okay, connect to only those data sources which you are going to use, which you are sure you're going to use. And use extracts. So when you extract the data, you will actually get additional features like, you can use certain formulas. Tableau is going to optimize your data to improve its performance. So use of extract is going to increase the performance of your dashboard. When filtering, try to avoid the exclude option. So when you're filtering the data, there's this exclude option. If you use that, Tableau will perform a bit slow. So when exclude option is used, Tableau will scan all the selected data and then it will exclude it selectively. Okay, so try to avoid the exclude option, rather use the include option. And use Boolean calculation whenever possible with alias. Okay, so how to do that? How to use Boolean calculation whenever possible? Okay, so I'll just repeat what I said. So a couple of tips which I was sharing. You can create an extract of your data that's going to speeden up your calculations because Tableau optimizes its extract to make the dashboard perform better. So always create an extract whenever possible. You can refresh an extract. So refreshing your data, if you're worried about refreshing your data, whether it's going to work or not when you're extracting it, it's going to work. You can refresh the extract as well. And when filtering, try to avoid the exclude option, because when you use the exclude option, Tableau will scan all the selected data and it's going to slow down the calculations a bit. Okay, slow down the process a bit. Rather, try to use the include options. All these points are applicable when you're working with big data set. And use Boolean calculations whenever possible with alias. So for example, if you're using an if-else formula, okay, if you're using an if-else formula, you're trying to, let's say, analyze if let's say if age is less than 25 years, or if age is less than 18, say not adult, else say adult. Okay, if that is the formula you're trying to build, just build a simple formula, age less than 18. You will get results in form of true and false. Okay, and then use alias to rename true as not adult and false as adult. Okay, does that make sense? Let me just quickly show that to you through an example, how that works. Here, let's say we have fixed salary of different employees. Okay, so we have different employees and their fixed salaries. So some employees are getting above 10 lakhs, some employees are getting less than 10 lakhs. All right, so next suggestion, use Boolean calculations whenever possible with alias. Okay, now from times to times, you may face a situation where you have to categorize something. So for example, here I'm working on a data set which contains salary of different employees. Okay, and I want to categorize them, whether they are earning substantial salary or not. For me, substantial salary, let's say, is anything above 10 lakhs per annum. If a person is earning above 10 lakhs per annum, his salary is good, else his salary is average. Okay, so I'm going to build a formula here. So create calculated field, and I will call it salary categorization. And the formula I'm going to use is if fixed salary is greater than equal to 10, then good salary, else average salary. Okay, and you say end if. Okay, so you end the if statement. You say okay, and you have this category of salary right here, and then you can keep it next to your data set, and you can see anywhere if the salary is greater than 10, it's calling it good. If it is less than 10, it's calling it average. Now if you're working with large data set, there's actually a way. So let me just quickly repeat the steps I've done. What I did here was I pulled up salary of different employees. So we have different employees working in a company, and the salary they are getting in lakhs of rupees. And I want to categorize these employees in two different categories, whether they are earning above 10 lakhs or whether they are earning below 10 lakhs. So I built this formula. I built this particular formula. I wrote this formula. If salary is greater than or equal to 10, then say the salary is good. Otherwise, the salary is average. Okay. And I said, okay, if I pull this data here, now it is performing as expected. Okay. If the salary is above 10 lakhs, it's calling it good. If the salary is below 10 lakhs, it's calling it average. It's performing the job. But if the data set is huge, if the data set is measuring in millions of rows or billions of rows, there's actually a way to make it faster. Okay, the way you should do it for performance optimization is this. So I'm going back again to fixed salary. I'm creating a calculated field, and this time I'm going to perform a very simple calculation. Fixed salary greater than equal to 10. No if statement. Okay, and I'm going to call it salary category 2. Second category I'm creating. I say okay, and I'm going to pull up salary category here. And as you can see, whenever the salary is greater than 10, it's giving me true. Whenever the salary is less than 10, it's giving me false. All I need to do now is right click and create alias. Whenever it's false, I'm going to call it average. Whenever it's true, I'm going to call it good. Okay, so there is no if statement here, just a very simple comparison statement which I built. This will be faster than the if statement. Salary category 2 will be faster than salary category 1. Okay, so this is another tip which I wanted to share with you. Does that make sense? Any questions? Is it okay? All right, let's proceed further. There are other ways in which you can optimize your formula. Use else if rather than nested else if in your logical statement. Here is a formula you can see. If region is east and customer segment is equal to consumer, then call it east consumer, else. Now this is the start of another if statement, hence two end statement here. Are you able to recognize this? So one if statement, another if statement. This is nested if, one statement within another. Okay, this one will be slow. You can write it like this. Instead of giving this space between else and if and making it nested, just give the next option as else if. Okay, check the second criteria. Here we have just one if statement, therefore just one end statement. This will be much faster. So these are some ways in which you can optimize your if else statement. Let's say you do not need the details of timestamp level. Okay, so in that case, use today, do not use now. For smaller data set, more or less you can use today or now, depending on your preference. I mean, it doesn't really matter. But when it comes to large data set, if you're performing a lot of time related calculation based on today's date, you do not need timestamp level details. Don't use now, use today. Okay, so that will restrict the scope of calculation. It will be faster. Also, you should logically optimize your calculation. So for example, here, make use of logical calculation. These two statements, these two if statement are going to produce the exactly same result, but this one, the one at the bottom, will be faster. Okay, so what does this statement do? This statement is checking if the sales is less than 10, then it is categorizing the sale as bad. Else, if the sales is between 10 and 30, then it is saying okay. If sales is greater than 30, then it's saying great. Many people will write the statement like this, and there's nothing wrong. But if you want to make it perform faster, then you can just ignore this statement. This is the default statement. Okay, you do not need to check for this condition. Check for first condition. If sales is less than 10, then it's a bad sale. If sales is greater than equal to 30, then it's a great sale. Otherwise, it's lying somewhere in between. We have already, I mean, this is a logical statement, right? So we make use of logic and we just skip this entire check, and that will make our code run faster. Next step, when using extracts and custom aggregation, divide the calculation into multiple parts. Place the row level calculation on one calculated field and the aggregated calculation on a second calculated field. And then extract can optimize the pre-computed row level calculation. So for example, if you are trying to calculate the sum of salary of all male employees or average salary of male employees versus average salary of female employees, you can write the formula something like this. You can type in the formula something like this. You can say sum of salary, whatever, if gender is equal to male, and then salary, else 0. So what are you doing here? If gender is male, then you're taking the salary of the person, else you're taking 0, you're not taking the salary of the person, then you are summing it up. So in one way you are performing a row level calculation and then you are aggregating it. Okay, this particular tip tells you, if you are doing something like this, break it apart into two different pieces, create two variables, type it like this. This entire thing will become a new variable. Let's say we'll call it male salary, and then you will say equal to, this will be the formula of male salary, and then you will just perform a sum of male salary. So there'll be two variables. If you create two variables and then take an extract, Tableau is going to perform the row level calculation and optimize it, and then aggregations will be faster. Is it okay? Were you able to comprehend this particular point which I just mentioned, this particular thing? Any questions with respect to this one? Okay, perfect. Thank you. Thanks for confirming. Okay. Remove any unneeded dimension or measure from your palette. Next point. So we are working on some particular visualization, let's say this one, and what you will see from time to time, there'll be something lying in the detail section which you're not using. Maybe you were experimenting with your view. You tried to create 3-4 different kind of visualization, and then you landed upon the visualization of your choice. Okay, but what happened in turn was there was some information which got left behind in the detail section. It has happened with me. From times to times I go back to some of my visualization and I see there is something lying in the detail section. I never intended to put it there, but then I was experimenting with my visualization, and by mistake I left the particular unwanted field in the detail section. It didn't hamper my visualization. It has no effect on my visualization as such. Okay, but it's still just lying there, sitting there, making my dashboard slower. So in those cases, it's actually good to revisit your shelf and see if there is some extra item which is not needed. Typically in the detail shelf, you'll find some of those things. Just remove them. Okay, so there are a lot of tips which I shared with you in terms of making your reports perform better, performance optimization. There are further tips which I can give you. For example, if you are making a tabular structure in Tableau, you're not really creating a visualization, rather creating a tabular structure like this. This is a table, and people are supposed to scroll through this table and look through the data. So we have this tabular structure. If you're picking any of these three, make sure the scrolling feature is not taking you very far down, because if your table is very, very big, it's going to give a terrible hit to your performance. Okay, so just make sure if you're doing something like this, create a hierarchy, enable plus and minus features, especially people create huge table when there is hierarchy involved. So for example, global sales broken up by regional sales, broken up by country level sales, broken up by state level sales, broken up by city level sales. This will turn out to be a huge table, and people have to really scroll down. Create a hierarchy, let people click on plus and minus button, expand or collapse the view, because that view is going to slow down your dashboard considerably. So that's another tip I wanted to share. And then we have some context filters. Anyone of you is not aware of context filters? There are context filters. They are also used for optimizing the performance from times to times. So there are many different features you can use to optimize the performance of your dashboard. Okay, third question, can Tableau create operational report where data changes every second, and also it looks like the drill down table data that Tableau shows as picture format and cannot be refreshed real time? And this is question asked by one of you. I was not able to comprehend this question completely, but I'm assuming this question actually means that how you can actually refresh the data table. Okay, so there is a scheduling and sort of like a scheduling task which you can perform in Tableau. That is done on server side actually. So here is a link which I provided. You'll get this PPT, and once you click on this link, it'll give you step-by-step guidance on how to schedule your reports. There are some predefined schedules. So for example, you can enable your report to refresh every 15 minutes or end of a particular month or every 4 hours. So there are different predefined timings in which you can schedule the refresh of your report. The person who asked the question, does that answer your question, or was it something else? Okay, so just in case if anyone has any further question with respect to scheduling, just follow this particular link, and it will guide you further. Thanks for confirming. Let's move on. Next question. How a real-time Tableau project will be in an organization from development to publishing? Okay, so it actually differs from condition to condition, from situation to situation. There can be different kind of Tableau projects you can encounter, and I'm just purely answering this based on my experience. There can be other situation as well. Okay, Tableau project can either be a migration project. A migration project means your report was existing in some other tool. Maybe it was an Excel report. Maybe it was a business objects report. And now you have been given the task to migrate it to Tableau. This real stuff which I'm talking about. And you'll probably encounter situation out of these 4 only. But there might be some other situation which I have not encountered, and you may. Okay. So these migration projects, they are easy to work with, and they are profitable. So by profitable, what I mean to say is people will actually get to compare your report versus the older report, and they will be able to see the difference, and you will get a lot of praises. I've got that, my colleagues have got that in past. So these are like good projects to work on. Plus requirements will be crystal clear because you are migrating something. All the requirements have been noted down. There's a practical application sitting in front of you which you have to replicate in Tableau and make it better, of course, visually appealing, and Tableau's fast engine, slicing and dicing ability, all these things you have to apply. These projects will be easier to handle, and mostly it'll win you a lot of accolades and appreciation. Then you have brand new projects as in, like, business doesn't know what it wants. You have data sitting in front of you. Maybe business has asked you to create a particular report. which was not existing earlier, and you are doing it in Tableau. This is also a good thing to work on. You'll in turn learn a lot of things. But here, what you have to do is really experiment a lot with visualization. Just be creative. Think about what all visualizations you can show in your dashboard. So again, these kind of projects are there. Then we have ad hoc reporting projects where you are given exact set of requirements, smaller projects maybe, okay, and you have to create a small Tableau dashboard in order to fulfill those requirements. It may be required for one-time use, maybe it's going to get used for only 1 week and then scrapped. Okay, so these ad hoc reporting projects are also very common across different enterprises. These are done in Tableau. Why? Because Tableau is very fast and you can actually create reports like you do in Excel pivot tables. You can actually create reports that quickly in Tableau. So ad hoc reporting is again a very common task in Tableau. Then exploratory research to guide predictive modeling. If you're working on full scale predictive modeling projects, anyone here who's from predictive modeling background or anyone who's planning to go into that domain? Okay, so Tableau is going to be a very handy tool for you. I'm from predictive modeling background, and I can tell you that within predictive modeling, there can be a lot of permutation combination. It would really help if you know your data best. Okay, and Tableau helps you do that. Tableau gives you output in a very, practical and the entire feel of data you will get while working with Tableau. Okay, so you will know in and out of your data once you come out of the Tableau environment. You'll slice and dice the data. You can go to any level in Tableau. So exploratory research to guide predictive modeling is done quite commonly in Tableau. So you'll pull your data, you'll create scatter plot, you'll create some bar charts, and you'll see how the trend is moving. And then you will deploy predictive models where you find interesting trends or where you see there is potential of predictive modeling to bring out some good results. Okay, otherwise it's difficult to just go ahead and deploy predictive modeling and then come out with no results and try some alternate approach. It's a slow process and very intensive process. So Tableau is going to help you there. These are different kind of projects you may encounter, and based on the kind of project you are doing, the approach which you're going to take will vary.
And with this, we have come to an end to this full course on Tableau. If you enjoyed listening to this full course, please be kind enough to like it, and you can comment on any of your doubts and queries. We will reply to them at the earliest. And do look up for more videos and playlists, and subscribe to Edureka's YouTube channel to learn more. Thank you for watching and happy learning.